Good morning, everyone. This is Dr. Dheeraj Singh Chauhan, and I warmly welcome you, all of you, on behalf of AKS University, Satna, in this 3-day international conference on science, technology, mathematics, and UN Sustainable Development Goals. I request our chief guest, Professor R.K. Sharma, sir, our special guest, Professor P.K. Bajpai, sir, Professor Krishna Sarma, sir, Professor S.N. Upadhyay, sir, Professor M.L. Sharma, sir, our Pro-Chancellor, Engineer Anant Kumar Soni, sir, Vice-Chancellor, Professor B.A. Chopade, sir, Pro-Vice Chancellor Accreditation, Professor G.C. Mishra, sir, our Dean Academic, Dr. Shekhar Kumar Mishra, sir, and Convener and Dean Faculty of Basic Science, Professor Shailendra Yadav, sir, to take your respective seats on the dais. Goddess Ma Saraswati always enlightens our path by providing us the capacity to think, learn, and pursue knowledge with wisdom and clarity. So now I request our dignitaries seated on the dais to light the lamp, and this is the time to Vandana of Ma Saraswati. Our university is emerging in the Vindhya region of Madhya Pradesh, and in a very short time we have achieved many notable academic heights. So in the honor of university, I would like to request to play the University Kul Geet. Please stand up, everyone.
श्रद्धान की AKS शिक्षा देते कौशल और कल्याण की AKS शिक्षा देती कौशल और कल्याण की बात हो विश्व विधान की सर्व सुरक्षा जो दे पाए बात वही हो निदान की सारी धरती एक राष्ट्र हो बात हो विश्व विधान शिक्षक का स्वप्न यही है हर शिक्षक का स्वप्न यही है शिक्षा हो सद्ज्ञान की सब प्राणी को जीवन प्यारा रक्षा हो इंसान की AKS शिक्षा देते कौशल और कल्याण की AKS शिक्षा देती कौशल और कल्याण की
माँ शारदा मैं हर वाली कृपा बने वरदान सी माँ की
युग के निर्माण की हम बात करें उत्थान की। AKSU शिक्षा देती कौशल और कल्याण की।
AKSU शिक्षा देते कौशल और कल्याण की। AKSU शिक्षा देते कौशल और कल्याण की। AKSU शिक्षा देते कौशल और कल्याण की।
Now, I would like to invite our Pro-Chancellor to welcome our chief guest, Professor R.K. Sharma sir, by providing him bouquet. Professor Sharma is Honorary Secretary of Royal Society of Chemistry, London of North India Zone. Now I request our Vice Chancellor sir to welcome the special guest Professor P.K. Bajpai sir by providing him bouquet. Professor Bajpai is currently the Vice Chancellor of Jayaprakash University, Chhapra, Bihar. I request our Dean Faculty of Basic Science, Professor Shailendra Yadav, to welcome Professor Krishna Sharma sir by providing him bouquet. Dr. Sharma is a professor in pharmaceuticals chemistry of Kingston University. Now I would like to request Professor Dr. C.P. Singh, HOD Physics Department, to welcome Professor S.N. Upadhyay sir by providing him bouquet. Professor Upadhyay is Vice President of IAPS Prayagraj, and he has also served as IIT BHU as a director. Now I am requesting to our Dean Academic Dr. Shekhar Kumar Mishra sir to welcome our conference chair Professor M.L. Sharma sir by providing him bouquet. Professor Sharma is Professor of Chemistry in Tribhuvan University, Nepal, and he is also the chairperson of Service Commission, Nepal Academy of Science and Technology, NAST, Khumalta, Lalitpur, Nepal. Now I request Professor Shailendra Yadav, Dean Faculty of Basic Science, to welcome our Pro-Chancellor, Engineer Anant Kumar Soni sir by providing him bouquet. I request Dr. Dinesh Mishra sir to welcome our Vice Chancellor by providing him bouquet. Now I would like to request Dr. Sudha Agrawal, Head Department of Mathematics, to welcome our Pro Vice Chancellor Accreditation Professor G.C. Mishra sir by providing him bouquet. I request Dr. Saket Kumar sir, Physics Department, to welcome Dean Academic Professor Shekhar Mishra sir by providing him bouquet. I request Dr. O.P. Tripathi sir to welcome Dean Faculty of Basic Science, Dr. Shailendra Yadav sir by providing him bouquet. For further proceedings, I would like to invite Dr. Ekta Srivastava and Mr. Radhakrishna Shukla, Department of Mathematics, Faculty of Basic Science.
Thank you, sir. I, Dr. Ekta Srivastava,
And myself Radhakrishna Shukla.
from Faculty of Basic Science, once again welcome you all in this prestigious International Conference 2026 on Science, Technology, Mathematics and United Nations Sustainable Goal. Now we move forward.
To formally begins the session, I would like to invite Professor Shailendra Yadav sir, convener of this conference, to present the welcome address. Sir, please.
I request Shailendra Yadav sir to welcome R.S. Tripathi. I request Professor R.S. Tripathi sir, Honorable Pro Vice Chancellor, Academic, AKS University, Satna, please come on the dais. And welcome, sir.
To formally begins the session, I would like to invite Professor Shailendra Yadav, convener of this conference, to present the welcome address. Sir, please.
Thank you very much, sir. Respected chief guest, distinguished guest on the dais, eminent scientists, professors, researchers, dear scholars, and beloved students. A warm and cordial welcome to all of you. It's my great honor and privilege as a convener of this conference to welcome you all to the 32 International Conference of the Indian Academy of Physical Science, being organized at AKS University, Satna, Madhya Pradesh for 13 to 15 March 2026. First of all, I extend my heartfelt gratitude to our chief guests and distinguished dignitaries who have graciously accepted our invitation and have taken time from their busy schedules to the present with us today. Your presence truly enriches this academic gathering and inspires the entire scientific community present here. I warmly welcome all the invited speakers, experts, researchers, faculty members, research scholars, and students who have joined us from various universities, research institutions, and organizations across India and abroad. Your participation reflects the vibrant spirit of scientific collaboration and intellectual exchange. This three-day conference has been carefully designed to provide a dynamic platform for the scientific discussion, knowledge sharing, and interdisciplinary collaboration, especially in the field of the physical science and related disciplines. During the conference, we will have a series of invited lectures, oral presentations, poster session, and the Young Scientist Award presentation, which will highlight recent advances, innovative ideas, and emerging research trends. The conference activities are being conducted across multiple platforms, including session in the Central Auditorium, Vivekanand Hall, and dedicated online session, enabling participation from a broader academic community. This blended format allows us to bring together scientists and scholars from different parts of the world on a common platform of learning and interaction. I would also like to mention the poster presentation session where young researchers and students will present their innovative work. Such sessions are extremely valuable as they provide opportunity for the budding scientists to showcase their research and receive feedback from experienced academicians. The Young Scientist Award session is another important highlight of this conference. It aims to recognize and encourage outstanding research contributions by young researchers who represent the future of the scientific advancement. On this occasion, I would like to express my sincere gratitude to the Indian Academy of Physical Science, Prayagraj, for providing us the opportunity to host this prestigious conference. I am also thankful to the Honorable Chancellor, Pro-Chancellor, Vice Chancellor and entire management of the AKS University for their constant encouragement, guidance and support in organizing this event. My special thanks to organizing committee, faculty member, staff and student volunteers whose dedication and hard work have made this conference possible. Organizing an event of this scale require teamwork, commitment and enthusiasm, and I truly appreciate their efforts. I am confident that discussions and interaction during these 3 days will promote innovative thinking, strengthen academic network, and inspire new research collaborations. I hope that every participant will benefit from the scientific deliberations and take back valuable insight and ideas. With these words, once again I extend my warmest welcome to all of you and wish you a very fruitful, productive and memorable conference. Thank you very much to all.
Thank you, sir, for your warm and inspiring welcome and conducting this wonderful conference for encouraging new researchers and scholars. Now, it's my privilege to invite Professor B.A. Chopade, Honorable Vice Chancellor of AKS University, for the introductory address. Sir, we request you kindly share your thoughts.
The chief guest of today's function, Professor P.K. Sharma, Royal Society London Honorary Secretary of Chemistry at North India Section at the Delhi University, and who is also the coordinator of Green Chemistry Network Center in New Delhi. The special guest on the occasion, my friend Professor B.K. Bajpai, Vice Chancellor Jai Prakash University, Chhapra, Bihar, India. Professor I.P. Tripathi, Vice Chancellor of Raja Shankar Shah University, Chindwara, Madhya Pradesh. Professor S.N. Upadhyay, former Director of IIT, Banaras Hindu University, Varanasi. Professor Mishra, immense mathematician, scientist from Institute of Mathematical Sciences, Chennai, and number of foreign friends, particularly Dr. Krishna Sharma, Kingston University, London, all the participants and the friends. At the outset, I like to congratulate International Academy of Physical Sciences for collaborating with the AKS University, Satna, Madhya Pradesh. About 6 months back, Professor Bajpai called me and expressed his will that we would like to have our conference of CONIAPS, Conference on Science, Technology, Mathematics and United Nations Sustainable Development Goals, STM-UNSDGs-2026 at AKS University. I talked to our Honorable Pro-Chancellor, Engineer Anand Kumar Suniji, and we were surprised that, sir, give permission immediately, sir, go ahead. We will organize this conference. And on the same day, I sent message to I called Professor Bajpai and told him that, sir, certainly I think, I will be happy to host international conference on the campus of AKS University. This is how journey started about 6 months back, and today we are come together on this occasion. I want to thank our professors Professor Shailendra Yadav, and all the professors, faculty from basic sciences for taking efforts for organizing this important international conference on the campus of AKS University. Professor Shailendra Yadav is Dean of the Faculty of Basic Sciences, and his team has been working consistently over the last, I think, 6 months to organize this conference in the most effective way. Dear friends, I must tell you, I have given a warm welcome to you all on the campus of AKS University. Many of you must be coming for the first time on the campus of university. And I must tell you very briefly, AKS University is one of the fastest growing developing university in the Madhya Pradesh and probably in India. In a span of 12 years, this university achieved number of heights. At the moment, we have 12 faculties and 13 faculty of Dairy Science and Technology will be started in the month of the June. So there will be 13 faculties in the campus of university, starting from pharmacy, engineering, paramedical, and all other branches of pharmacy and engineering and management. We have all these faculty, and around 10,000 students across the country have been studying on the campus of university. I also must tell you on this occasion to you, we have been accredited by our agriculture program, BS and MS agriculture program, accredited by the Indian Council of Agriculture Research, ICAR, in 2023, which again is matter of pride. We also have been accredited by the minister by the program laboratory, I think, of the cement technology, by NABL accreditation of Government of India in 2022. And I am very happy to tell you that we also have been accredited by the NAC in 2024. I am so happy that in such a given time we are just close to A grade by 0.001 mark. Unfortunately, because of online assessment, we lost our A grade. We wanted A plus grade, but because of the online, the process, the thing were not very straight and straight, I think, in the operation, I think. But anyway, I believe and trust this university is able to achieve heights, I think, from time to time, every year. We achieved a number of landmarks. And friends, I must tell you, we are not waiting up to the NAC accreditation. We are also planning for the international accreditation. We are also preparing for an IRB accreditation, NBE accreditation, and soon we will be able to go international green accreditation of the university, because campus of AKS University is very, very beautiful. Coming back to the theme of the conference, I must tell you that when Professor Bajpayee, I think, and his colleagues called me for the organization CONIAPS 32 STM 2026, I think, I say that, yes, I mean, developing science and technology is a continuous process. There is no end to research, no end to innovation. But one of the burning problem across the world is, I think, United Nations Sustainable Development Goals, SDGs. So you may be, I think, a basic science researcher, or engineering, or pharmacy, or medical, whatever may be, or even social sciences. You must be able to focus your attention towards SDGs problems across the world, across the nation. And from that point of view, I instead say, Bajpayee sir, I think we must be able to put SDGs as one of the theme, similar theme, I think, in the conference. I am very happy to tell you, I convinced Professor Bajpayee, the committee, I think, of that Indian International Academy of Physical Sciences agreed with my vision. And I am very happy to tell you that, there is very good response, I think, across the country, I think. By the way, I must tell you, this university, as I said to you, has introduced 2 credit courses on sustainable development goals in all the faculties from 2022. And probably, this is the only university in the country, I am saying with confidence and with the proud, which has implemented SDGs program, Indian Knowledge System programs, and Human Values program right from first year in all the faculties of the university. We hope our students to be innovators, we hope our students to be researchers, and I must tell you, path of AKS University, which we have fostered as a research university. Friends, it's a long path. We have started our journey, and remember, I have full confidence with our speed and commitment and dedication and support of Honorable Chairman Engineer Anand Kumar Soniji, I have full confidence we will able to achieve the path of research university in the country. Friends, on this occasion, I must tell you that in this particular program, we have received a total registration 419. A very good response in the last 6 months. Research scholars offline are 42. Research scholars online are 70. Invited talks are 15. Keynote speakers are 70. Keynote speakers are 35. We have issued 170 abstracts so far until yesterday, and that we have issued 38 book chapters, and we are in the process of peer review of each book chapter like research paper, And total abstracts issued on United Nations Sustainable Development Goals are 46. And in case of SDGs, we have issued the 13 book chapters, which are in the process of peer review. And abstract in science and technology, we have issued 54. And here, number of abstracts in mathematics, as CONIAPS does consist of mathematics, which again is a physical sciences, consists of 70 abstracts, and 20 book chapters. And also, like this. The point what I want to say to you, understanding the whole, dynamics of the content, of the conference, will find that large number of researchers from across the country, maybe senior scientists, like Professor, S.N. Upadhyay, Professor Mishraji from, Indian Mathematical Institute, Chennai, and many more eminent scientists have come over here, Professor, Krishna Sharma from, Kingston University, London has also arrived. A number of new research scholars, postdoctoral scientists, and MSc students, and also undergraduate students have been participating into this, particular conference. My friends, I must tell you one thing. Research innovation is a continuous process. As eminent research in the country and international level, I can tell with confidently, there is no end to innovation. There is no end to research. Research is a continuous process. Innovation is a continuous process. From this point of view, I would like to enlighten you today some of my thoughts which are not in the textbook, which are not so far published, and which are not yet to be, considered by the humans, Over the last 1 month, I have been thinking about the Sustainable Development Goals. And you know that our country, great India, has committed for the Sustainable Development Goals, SDGs, to the United Nations. And by 2030, we are supposed to achieve the goal of SDGs. Now, I must tell you, why I am insisting on SDGs is this: the base or foundation of National Education Policy 2020 is based on United Nations Sustainable Development Goals. And therefore, it's not only research innovation, but even the pedagogy, even the content, of curriculum, content of pedagogy, research innovation, which are relevant, which are applicable to society, solving the problems. And therefore, I thought that, this theme will be, of paramount importance. Now, let me tell you, most of the researchers in India, we do traditional research, we do conventional research, maybe chemistry or maybe physics or mathematics. But see, I call upon all the young researchers from the universities across the country, also senior scientists in the country. We must think out of the box. We must do research which is unknown, which is not available, which is not known to science. In other words, we have to chart a new path of research and innovation by deep thinking and your commitment and perseverance. For example, if you see the goal number, say, for example, 13, 14, and 15th of United Nations, it talks about climate change. It talks of environmental sustainability. Goal number, 16 talks of economics. Goal number 70 talks, about collaborations. The question which comes to mind as a researcher, as a scientist, are we collaborating really within the university? Are we collaborating within the state? Are we collaborating within the research institutes or between the research institute? And are we collaborating at international level? See, now world has become a village. You cannot say I am from a remote place and I think I don't have research collaboration. Collaboration, new mantra for the 21st century for university professors and research scholars. So you have to come out of domain of your small niche of research. And then only new ideas will be able to come, I think, new will be develop. On this occasion, as I said to you, I'll give an example to you. STM Satna development goals, I think, from one example, I think, of the Maharashtra. Because that's a unique example in the history of the world. All of you know the climate change. And all of you are aware that how climatic change is disastrous across the world, not only in India, across the world. Large number of floods. Example of Chennai and Mumbai. They flooded. Entire city was flooded, I think, for almost, I think, a fortnight. Unusual rains across the country. Storms across the seashore. And on the top of that, a rise in temperature. All these things has affected human health and the economy. For example, let me tell you, for example, when you talk about a country like, for example, of India, and when you say our capital of India, Delhi and Uttar Pradesh, including Punjab, I think, and the Haryana region, you'll find that the level of the pollution is tremendous. We're talking people killing in the war or COVID-19. Let me tell you, 10.5 million people die because of environmental pollution. And the point I'm telling to you, this is all because of environmental problems, I think. And therefore, on the occasion, I call upon all young researchers. Can you do research on practicable solution, practicable problems which are associated with environment, I think. And then only we'll able to, I think, assist, I think, develop new technologies, new science. Let me tell you one example of America. In 70s, 80s, and 90s, one suburb of the New York was full of, like New Delhi, worse than New Delhi. But if you go to 2020, to Yale University, and the area around the Yale University, you'll find that, I think, is one of the cleanest area. AQI, air quality index, is 65. And remember, all this is done by research innovation per American university like Yale University. And they control the pollution. They created new policies, new solutions, new technologies through invention and through research. My dear friends, can you do something like this? Can you solve problems of our country, problems of our city, problems of state? And by that way, by doing it, I'm telling to you that I believe that students in universities must be innovators, must be thought leaders, must be creative, and then only we'll able to match, I think, challenges of, I think, environmental problems, I think, in the country. It's not only health, it's not only pure air, but it's also affect, I think, the India is a country, large number of metabolic diseases are in burden. And this all is going to affect the national health policy. Budget of the country is going to affect it, I think. And we as researchers, if you don't think like that, I think who is going to solve our problem? We cannot import the technology and solve a problem. So my point I am telling to you, even the conferences on science, technology and mathematics are UN development goals. I think the message from the conference we should take it, I think, and we must do interdisciplinary and transdisciplinary research in that. I have full confidence. During the 3 days time, I think, we will have, I think, great number of deliberations, interact with the scientists, interact with the scholars, encourage with them, have a great discussion, and I hope that at the end of this conference, 3 days, I think, you'll be able to carry with you large number of knowledge and new ideas, new concepts and innovations along with you. With this, my brief word, I congratulate all of you. I welcome you all of you on campus of AKS University. Jai Hind.
Thank you, sir, for inspiring words and highlighting the vision and objective of this conference. Now, we move ahead one of the most enriching segment of this conference, the addresses by our distinguished guest whose experience and academic contributions continue to inspire the global research community.
It's indeed a privilege for us to have such eminent personalities among us today. Their words of wisdom will certainly enlighten and motivate all of us who is present here. To begin this segment, it is my great honor to invite Professor M.L. Sarma sir, who is the conference chairperson, to kindly share his valuable thoughts and address the gathering. He is a professor of chemistry at the Central Department of Chemistry, Tribhuvan University, Kirtipur, Kathmandu, Nepal. Sir, we warmly welcome you to deliver your address. Thank you, sir.
Thank you, madam, for this nice introduction. Respected chair of this session, today's chief guest, all the eminent personalities on the dais, eminent scientists, scholars, faculty members, whole organizing committee, dear students, all the volunteers, and all, and ladies and gentlemen present in this beautiful hall. It took just 3 days for me to be here in this beautiful AKS campus, and I had started my journey 3 days ago from Kathmandu, Nepal. And today morning, till I reached here, I was feeling very tired, still physically maybe tired, but as soon as I entered into the campus, I felt very energetic. Thank you, sir, for this warm welcome and hospitality in your beautiful campus. Whatever I wanted to speak in this, you have already delivered, sir. You have highlighted so many things. That's why this 3 days conference, 13, 14, and 15 March 2026, you have covered a lot of topics. You have particularly you explained very beautifully about the sustainable development goals. When we are talking about the sustainable goals, it is, we said initially when it was proposed, it was targeted to achieve all the goals by 2030. But it seems very difficult right now. Since we are facing, at the same time we are trying to solve the environmental problems all over the world, but at the same time we are not being able to solve all the political problems. Because of all this, I think so many problems are raising in our universe. That's why we are facing the acid rain is falling in the area of the Iran particularly, and it is our just not a neighboring country, but it is our neighbor's neighbor, right? That's why it is, we may be affected from that also. That's why this is very, very problematic things. South Asian Association of Regional Cooperation, SAARC, is not doing well, though the Nepal is still the chair of this SAARC countries. Now the another organization emerged, that is Bay of Bengal Initiative for the Multiple Sectoral and this Technical Advancement, that is called the BIMSTEC. And of course, in this BIMSTEC organization, great India, Nepal, Sri Lanka, Bangladesh, Bhutan, Thailand are the member countries, and of course Myanmar. All these are the member countries, and this is our time to lead through to make this whole region prosperous by BIMSTEC, and India's role is, of course, obviously, it is at the top of all the countries, I guess. That's why I had requested the convener of the conference to put my lecture just in the next day, because I was not well prepared, because I just reached today, and tomorrow I have prepared my presentation in this hybrid model. This is particularly targeted to the students, and of course sustainable development goal, and about the ancient glory of this Indian subcontinent. That's all things I will try to speak in front of you, and tomorrow you will be here. And at the Last, what I would like to tell you is this: I'm very, very thankful to the whole organizing committee, this AKS University, for inviting me, uh, and I'm very fortunate enough to talk, to to be introduced with you all. And at present, I am not the very regular faculty of the Central Department of Chemistry, Tiruvandrum University, since I am leading the Nepal Academy of Science and Technology Service Commission as a chair of this organization. Its full duty is to recruit the administrators, particularly the scientists, technologists, and this organization is just like the CSIR in the CSIR model, and it has all the 8 laboratories all over Nepal, and that I have to do. And it's been just as more than 6 months since I've been leading this institute. And at last, not the least, I wish all the best for the grand success of this conference. Yeah, all 3 days we'll be together, we'll be talking, and we will have so many sideline talks for the development, for the mutual development of our both the societies. And one very important thing is, though I represent the Nepal in this conference, but Nepal and India is it's just inseparable, right? That's why we are very close to each other. We understand each other. Our languages, our religions, so many things are common. That's why I'm not very far away from you. That's with this much words, I'm taking my place. Thank you, sir. Thank you. Jai Hind, Jai Nepal. Thank you, sir.
Thank you, sir, for your inspiring and enlightful words.
As a token of our gratitude and respect, we request Professor B.H. Chopade, sir, Honorable Vice Chancellor, AKS University Satna, to kindly present a memento to Professor M.L. Sharma, sir.
Please provide the memento. I request organizing team, please provide the memento. In the next section, now it's our privilege to invite Professor Krishna Sharma sir, who is a professor in pharmaceutical chemistry at Kingston University, specializing in sustainable and green chemistry. Kindly address the conference and share his valuable insight with us, sir. Sir, we request you to please grace the podium.
First of all, good morning, everyone, and thank you, Dr. Shailendra, for having me, and greetings to all the dignitaries here today, especially after having had some long journeys from London to New Delhi, and then a couple of other journeys coming here, passing through the tiger reserves yesterday. It was thrilling, it was tiring, but it's great to see all of you energetic students here today. This morning, gathered here was such an important conference on sustainability. Much has been said already about the meeting, why is it important, and especially VC sir has mentioned a lot of important points surrounding about it. What I'm going to do is just add a few more things to it. I will take you back in time. So about 1800s, the pre-industrial times. And if we look at now, where we have come. So every 10 years, the temperature rise that VC sir was mentioning in his speech, it has been about 0.2 degrees every 10 years. And if we compare all together, since the pre-industrial times, we are at right now 1.2 degrees C above the pre-industrial times. And because of that, actually, Intergovernmental Panel on Climate Change, they sat together in a meeting and they projected the way that we are going, how much will it be by the end of the century. And they figured that by the end of the century, we'll be about 4.1 degrees C above the pre-industrial levels. And then they also said that in order to save this planet, the limit that we got to stick to is actually 1.5 by the end of the century. So you can imagine that Earth, like 4.1, the projected rise, the Earth has never seen that kind of temperature in about 3 million years. So 3 million years, that is like much before any human life existed. So right now there is a lot of urgency to save the climate, save the planet, because as you saw in the initial video that we had, it had one slide section where it was written, one Earth, one future, one family. So we got to know that we have one Earth. We got to know that we have to come together as one family. And we know that we have only one future for us. And we got to protect it all. And that is why suddenly what has happened around the world, everybody has woken up by that thought of what is... Are you able to hear me without? Okay. Is this better or? Okay, all right. So yeah, basically everybody has now woken up in the world and everybody wants to now take certain actions. Why? Because the way that we have been doing things, and again, I will refer back to what BC sir was mentioning, the traditional ways of doing things, how we have been creating things around us that we use. For example, the mobile phones that you're using right now, probably to take pictures, the iPads or the laptops that you're using right now to take your notes, anything and everything useful around us, the medicines that we take, the polymers that are there around us, everything is coming from petroleum, from fossil sources. Making all of those things costs the climate because we do carbon emissions from fossils. And that is leading to all of that temperature rise, global warming, climate change problems. So the question is, can we actually think differently? Can we change the ways that we make things around us? And can we challenge the very notion that we believe that exists at the moment, that we believe it to be, that is the only way of doing things starting from fossil fuels? So now what has happened is UN has gotten together and UN has come up with Sustainable Development Goals, 17 of them, that again VC sir mentioned. The target is to reach net zero emissions, reach those goals, again referring to the Paris Agreement, Conference of Parties that took place in 2015. They have come up with this agenda of net zero by 2050 for the world. India has their own goals, net zero by 2070, reduction of the greenhouse gases by a certain timeline. UK, where I'm presently, they also have their own targets, net zero. And the question is, how can we change things, the way we do things, and make it better? And just a reference to what I'm going to tell you in my talk, my own journey has been about that, thinking about how we have been doing things, all the very useful. And I had been doing that as a researcher as well. And I will be telling to you how I myself have changed the way that I now do chemistry and I follow sustainability in chemistry, and about some of the inspiring things that have happened with me. Hopefully they will inspire you as well in your own journeys of being a scholar, as it did for sure for me. And that's pretty much from me. So I just wanted to say a very important theme for the conference, sustainability, because we all have one future. We all have to come together as one family, especially for the SDGs 17 collaborations, partnerships, and we have only one Earth. And that's from me, thanks.
Thank you very much, sir, for your enlightening address. Definitely our youth, which is present in front of us, follow your words.
Now I request to Professor R.S. Tripathi, Honorable Pro Vice Chancellor, Academic, AKS University Satna, to kindly present a memento to Professor Krishna Sharma as a token of appreciation. Moving ahead, we are delighted to invite Professor P.K. Bajpai, sir, Vice Chancellor of Jai Prakash University, Chhapra, Bihar, to kindly address the conference. Sir, please.
इंटरनेशनल एकेडमी ऑफ फिजिकल साइंसेस के 32वें अंतर्राष्ट्रीय अधिवेशन के उद्घाटन सत्र में हमारे मुख्य अतिथि के रूप में उपस्थित दिल्ली विश्वविद्यालय के जाने माने रसायन शास्त्री प्रोफेसर आर के शर्मा जी, नेपाल से आए हमारे अतिथि प्रोफेसर एम एल शर्मा जी, इस नए किंतु तेजी से बढ़ते हुए विश्वविद्यालय के प्रो चांसलर इंजीनियर सोनी जी, मेरे अभिन्न मित्र एवं विश्वविद्यालय के कुलपति प्रोफेसर चौपड़े जी, मंच पर उपस्थित इंडियन एकेडमी ऑफ फिजिकल साइंसेस का प्रतिनिधित्व कर रहे प्रोफेसर एस एन उपाध्याय जी, इस कॉन्फ्रेंस के चेयर सचिव प्रोफेसर सैलन जी, प्रो वाइस चांसलर साहब, लंदन से आए हुए हमारे युवा साथी प्रोफेसर कृष्णा जी, आई डोंट रिमेंबर हिज नेम करेक्टली, एम आई करेक्ट? ओके। मेरे सामने बैठे हुए पूरे देश से आए इस कॉनिएप्स के 32वें अधिवेशन में सहभागिता करने आए पूरे देश के वैज्ञानिक गण, शिक्षक गण, शोधार्थी गण और इस विश्वविद्यालय के अंग्रेजी वैसे भी मेरी बहुत अच्छी नहीं है। कोनिएप्स का अधिवेशन एक कॉन्फ्रेंस नहीं है, कोनिएप्स कोई गतिविधि नहीं है, इट्स नॉट ए एकेडमिक इवेंट, इट्स एन एकेडमिक मूवमेंट which has started in 1994 to correct the processes, problems and challenges of Indian higher education. Long back, we had submitted the draft of NEP 2020 in 2020. But the whole process of changing the higher education in this country, we started in 1994 in terms of CONIAPS. And this was to start multidisciplinary, flexible and holistic higher education in this country on a pragmatic platform. And believe me, I am one of the living example, not to appreciate myself. We started the first engineering college in Madhya Pradesh, myself being the director at the age of 33 in Bilaspur as Institute of Technology. Just to repeat the ITBHU. We also started in 1997, the same year, Institute of Pharmacy. We also started the medical college, first of its kind in any university in Madhya Pradesh, and completed in 2000. We started, and many of you may not believe, the first particle accelerator on any university in this country in Madhya Pradesh in Bilaspur. Again, I got the opportunity of starting the 3 MB particle accelerator, still the only accelerator system in the country on any university system. So this is what we have to do. CONIAPS inspires you to go on a high risk taking researches on niche areas. Don't follow the West. They could not produce the science and technology that was required for the world for sustainability. And I am quoting the Antonio Guterres. I met him and he said that we will never achieve the sustainable development goal. It is not possible. I will tell you the logistic reason why it is not possible till you correct the scientific dogmas, scientific paradigm that exist in the modern science and technology. And the reason being, the one mistake the Indian civilization has done, भारतीय सभ्यता और संस्कृति में हमने एक गलती की थी, और वो गलती की थी जब हम वेद युग से दर्शन और दर्शन से उपनिषद और उपनिषद से पुराण काल ब्राह्मण ग्रंथों में आए, तो विष्णु पुराण में हमने एक श्लोक लिख दिया था। क्या श्लोक था? सा विद्या या विमुक्तये तत्कर्मे अन्य बंधाय सा विद्या या विमुक्तये आया साया परम करना विद्यान्या शिल्प नैपुण्य। हमने ये जो समष्टि का संतुलन था, ये जो बैलेंस था, कल मैं डिटेल में बताऊंगा, आज बहुत ज्यादा अंदर नहीं जाएंगे हम लोग। इसमें विद्या और अविद्या दो भाग में हमने ज्ञान को बांटा था। गोइंग इनटू द इंटरनल टू क्रिएट द कैपेसिटीज एंड कैपेबिलिटीज ऑफ द ह्यूमन पोटेंशियल टू कम आउट, and going to the external to understand the cosmic rules, the nature of cosmos, and to use it for our benefit in a precise manner. ये जो संतुलन था, हमने परा के रूप में भारत की संस्कृति और सभ्यता में जब ब्राह्मण युग में, जिसको हम पुराण युग कहते हैं, उस युग में हमने इस संतुलन को खो दिया था कि जो बाहर जो आज साइंस एंड टेक्नोलॉजी हम कर रहे हैं, ये करना कोई बड़ी बात नहीं है। इट इज शिल्प नैपुण्यम, ये सिर्फ जो है दिखावटी पने से कुछ नहीं होगा, बिकॉज दिस इज ऑल माया। एंड बिकॉज ऑफ दिस आई एम नॉट सेइंग, दिस इज द कोट ऑफ स्वामी विवेकानंद व्हेन ही वाज राइटिंग व्हाट एवर द रीजंस ऑफ द डिक्लाइन ऑफ इंडियन सिविलाइजेशन, देन ही रोट परा और अपरा के असंतुलन से ये विघटन पैदा हुआ है। और आज विज्ञान और तकनीकी पर आधारित जो यूरोप के पुनर्जागरण का मॉडल है, चाहे वो सोसाइटल डेवलपमेंट का मॉडल हो, चाहे वो इकोनॉमिक मॉडल हो, चाहे वो पॉलिटिकल मॉडल हो, चाहे कैपिटलिज्म हो, कम्युनिज्म हो, सोशलिज्म हो, चाहे आपके अर्थतंत्र के मॉडल हो, सारे मॉडल्स की यही कमी है कि एक विकसित अमेरिका के लिए 10 अविकसित अफ्रीकी देश चाहिए। आपको इनपुट चाहिए, आपको मजदूर चाहिए, आपको कच्चा माल चाहिए, नहीं तो ये डेवलप कंट्री पैदा नहीं हो सकते। हमारे भारत के विकसित भारत की डेफिनेशन वो नहीं है जो पश्चिम की डेफिनेशन है, इसलिए विकसित भारत का विज्ञान भी वो नहीं होगा जो पश्चिम का विज्ञान है। इसलिए कॉनिएप्स की स्थापना हुई थी। और इसको लेके, जैसे मैंने अभी कहा, हमने पूरे देश में सिर्फ इन कॉन्फ्रेंसेस के माध्यम से नहीं, वर्कशॉप्स के माध्यम से, आपसी विमर्श के माध्यम से एक इंटरडिसिप्लिनरी, एक मल्टीडिसिप्लिनरी हायर एजुकेशन के मॉडल को डेवलप करने का प्रयास किया है। और इस मॉडल को क्यों डेवलप करना? क्योंकि आज की जो विज्ञान और तकनीकी के आधार पर विकास का मॉडल है, उसके जो रिजल्ट्स आ रहे हैं, कृषि के क्षेत्र में हरित क्रांति का दशा देखिए, पंजाब को कैंसर राज्य बना दिया। मेडिकल के क्षेत्र में एलोपैथी ने इस पूरे शरीर में इतने बाई प्रोडक्ट्स पैदा किए हैं, इतने ज्यादा रिएक्शंस पैदा किए हैं कि अब हमको खुद समझ में नहीं आ रहा है कि हम ट्रीटमेंट की दिशा क्या रखें। सामाजिक स्थिति आप सब देख रहे हैं, वी हैव बिकम ए रिएक्शनरी वर्ल्ड। क्लाइमेट चेंज और एनवायरमेंटल जो प्रॉब्लम्स है उसका डिस्कशन इन सब लोगों ने किया है। और जो 17 सस्टेनेबल डेवलपमेंट गोल्स हैं, उनमें गोल नंबर 4 को आप फोकस करिए। इट इज द क्रक्स ऑफ द मैटर। कोई भी समाज, कोई भी देश, कोई भी विश्व की कोई भी व्यवस्था तब तक व्यवस्थित रूप से विकसित नहीं हो सकती है जब तक वो सनातन के मॉडल को अडॉप्ट नहीं करेगी। That is the most sustainable and green development model of the science and technology. And what is that? Science and technology has to be धर्म आधारित। अब आप लोग थोड़ा चौंकेंगे कि ये बीच में रिलीजन का, रिलीजन हैज नथिंग टू डू विद धर्म। द डेफिनेशन ऑफ धर्म इन हिंदू फिलॉसफी इज इति निश्रेयसा अभ्युदयानि सिद्धि सधर्म। जो निश्रेयस और अभ्युदय को एक साथ ठीक करता है वो धर्म है। वी हैव टू अडॉप्ट दो साइंटिफिक प्रोसेसेस, दो साइंटिफिक प्रोडक्ट्स दैट क्रिएट्स द इकोनॉमिक डेवलपमेंट as well as create sustainability. Nishreyas means sustainability. This was written long back, and I am quoting the Vaisheshik Darshan. The second sutra of Vaisheshik darshan says, इतनी श्रेयसी अभ्युज्ञानी सिद्धि सधर्म। धर्म की एक और व्याख्या फिर हमने की, या धारेति सधर्म। इसको सिर्फ कहने से नहीं होगा, इसको धारण करना पड़ेगा। यू हैव टू अडॉप्ट। ये नहीं होगा कि अमेरिका जो है लगातार ज्यादा से ज्यादा एनर्जी का उपयोग करता रहे, चाइना कहे मुझे तो अमेरिका बनना है, वो बेलगाम एनर्जी का उपयोग करता रहे, और जो विकासशील देश है उन पे आप सारी लगामें लगाएं, उनको आप गैर समझौतों में इधर उधर बांटें और कहें कि तब विश्व ठीक से डेवलप होगा। हमने देखा है कि विश्व की आर्थिकी किस तरह से ट्रंप के ट्रैफिक कार्ड से बदल जाती है। हमने देखा है कि नॉर्थ कोरिया का जो उतावलापन है वो पूरे दुनिया के एग्जिस्टेंस के लिए खतरा बन जाता है। आखिर क्यों इस तरह का विज्ञान और तकनीकी का हम विकास ना करें जो न सिर्फ सतत विकास को सुनिश्चित करे बल्कि समग्र विकास को सुनिश्चित करे। इस दुनिया में कुछ लोगों के विकास के लिए हम विज्ञान और तकनीकी का उपयोग नहीं कर सकते हैं, और इस विज्ञान और तकनीकी में कुछ डिफेक्ट्स हैं। एक आखिरी उदाहरण देके मैं अपनी बात खत्म करूंगा, बाद में जब मौका मिलेगा तो हम लोग बात करेंगे। इस देश को बांटने के लिए भारतीय उपमहाद्वीप को साजिश के तहत दुनिया के दो बड़े वैज्ञानिकों ने एक षड्यंत्र किया था, विलियम जोन्स एंड मैक्स मुलर। इन दोनों ने एक हाइपोथेटिकल मॉडल क्रिएट किया जिसमें भाषा विज्ञान का प्रयोग किया, जिसमें एंथ्रोपोलॉजी का प्रयोग किया, जिसमें मॉडर्न साइंस एंड टेक्नोलॉजी का प्रयोग किया, और हमको बताया कि भारत में आर्य आए थे। भारत में आर्यों के आक्रमण का सिद्धांत पूरे पौने 200 साल तक विश्व की पश्चिम की 6 बड़ी यूनिवर्सिटीज ने उसमें अपना जोर लगा दिया। और आज मैं सीना ठोक के कहता हूं, मैक्स मुलर $1 लाख उस समय ब्रिटेन से लिया करते थे। ब्रिटेन को माफी मांगना चाहिए भारत से, भारत में एक गलत सिद्धांत प्रतिपादित करने के लिए, भारत को आर्य और द्रविड़ के बीच में बांटने के लिए। आज हमारे वैज्ञानिकों ने 2016-2018 में 2 पेपर पब्लिश किए हैं सेल में। उन पेपर्स को पढ़िए आप लोग। उन पेपर्स में हमने राखी गढ़ी में जो महिलाओं के शवों से डीएनए पाया है, जो सब 7000 वर्ष पुराने थे, उस डीएनए में G8 जीन्स पूरी तरह से निरूपित हुई है, और जो सिद्ध करती है कि भारतीय उपमहाद्वीप के लोग एक ही रेस से विकसित हुए हैं। फिर ये आर्यन और द्रविड़ियन में हमको बांटा क्यों? एक दूसरा हमारे साथ छल किया गया कि संस्कृत प्रोटो यूरोपियन लैंग्वेज से निकली है, और उसके लिए भी साइंस एंड टेक्नोलॉजी का उपयोग किया, जिसको आप माइग्रेशन थ्योरी कहते हैं, कि स्टेपी के मैदान से लोग आए, उनके पास पहिए की खोज थी। अरे सर, जिस संस्कृति ने साइक्लिक वर्ल्ड को दिया है, आप तो गलत विज्ञान पढ़ा रहे हैं। मैथमेटिक्स के बड़े विद्वान यहां बैठे होंगे। फोरियर थ्योरम क्या कहती है? एवरी कर्व कैन बी रिप्रेजेंटेड बाय 2 साइक्लिक फंक्शन साइन एंड कोसाइन। यही तो है ना? हमने इसको 5000 साल पहले कहा है। रित, if you want to have the buddhi into vivek and vivek into pragya, then sat has to be synchronized with rit and rit has to be synchronized with mahat. This is Sankhya, and Sankhya says the complete evolutionary theory of cosmos. इन चीजों को पुनर्भाषित करके दुनिया में जो विज्ञान और तकनीकी की अंधी दौड़ में हम भागे जा रहे हैं, आज सब AI चिल्ला रहे हैं। 90% लोगों को पता नहीं है कि AI इज ए मिसनोमर। There cannot be any intelligence. There can be manipulation. हम सब जानते हैं, extrapolation, interpolation, सब लोग करते हैं। यही आप नॉलेज को, this is not knowledge, this is information. You are manipulating information, and whenever we do the manipulation, it may be correct, it may be incorrect. So the predictability of any AI model based on the ML, it can never be 100% correct. These are all approximations because the basic mathematics is approximate. There is nothing like no linear motion exists in the world. All motions are cyclic. Their frequencies may be small, their frequencies may be high. So we are approximating a cyclic system into a linear system. For how long it will sustain, it will deviate from the reality. And to check this deviation in 500 years, the development of science and technology has deviated so much from the reality that in order to correct it, We have to create a new science and technology based on the cyclic processes. भारत में चाहे वो पुनर्जन्म की कल्पना हो, चाहे वो कार्मिक थ्योरी हो, चाहे वो वर्णाश्रम व्यवस्था हो, हमने उसको डिस्टॉर्ट किया है। इसलिए कि अपने कंसेप्ट को ठीक रखने के लिए हम लोग बाद में बात करेंगे, लेकिन कोनिएप्स का उद्देश्य भारतीय विज्ञान की परंपरा को पुनर्स्थापित करके इस विश्व में बढ़ती हुई विद्वेष और हिंसा की प्रवृत्ति को रोकना, फिर से उदार चरित्र बनना, आचरण के आधार पर दुनिया के समाजों को उनकी विभिन्नताओं का सम्मान करते हुए उनको एक रस करना सिखाना, उनको समरस बनाना और इस दुनिया में फिर से एम निजा परावेती गगना लघुचेत साम उदार चरता नाम तू वसुधैव कुटुंबकम, इस कुटुंब का पुनर्स्थापना कोनिएप्स का उद्देश्य है। मुझे लगता है इन 3 दिनों में हम सब इस पर विचार करते हुए ज्यादा से ज्यादा कोलैबोरेट करेंगे, ज्यादा से ज्यादा नेटवर्क करेंगे और जो हमारी उपनिषद की परंपरा है, ओम सहनावतु सहनौ भुनक्तु सह वीर्यं करवावहे तेजस्विनावधीतमस्तु मां विद्विषावहे, ओम सहनावतु सहनौ भुनक्तु सह वीर्यं करवावहे। इसका मतलब सिर्फ ये नहीं है कि हम एक साथ बीतवा के काम करें, इसका मतलब है एक साथ मिलके अपनी अपनी एक्सपर्टाइज का उपयोग करते हुए भारत के सामने जो चुनौतियां हैं, हमारे जो विकास के संदर्भ हैं, उनको सामने रखते हुए अपनी सोच को, अपने नवोन्मेष को, अपनी शिक्षा को रिओरिएंट करेंगे और उन चुनौतियों के लिए समय के थल निकालेंगे। और जब हम इस पोजीशन में पहुंच जाएंगे, फिर हम दुनिया को संदेश देंगे कि भारत की आध्यात्मिकता, भारत की वैज्ञानिकता का संतुलन ही दुनिया की समस्याओं का समाधान है। हम इस ओर आगे बढ़ सकें। शुभक्षु सर्वे लोका सुखना भवन्तु।
Thank you, sir, for sharing your valuable knowledge, thoughts, and perspectives with us, and tell us the objective of CONIAPS. Now, I request Dr. Dinesh Mishra, sir, Coordinator of Faculty of Basic Science, AKS University, Satna, to kindly present a memento to Professor B.K. Bajpai, sir. Dr. Dinesh Kumar Mishra.
Now it's privilege to invite Professor S.M. Upadhyay, sir, distinguished Indian academician in chemical engineering and former director of the Institute of Technology, BHU, to kindly address the conference. Sir, we request you to please share your thoughts with us.
Dhanyavad. While sitting on the dais and listening to earlier speakers, I was deliberating whether to speak in Hindi or to speak in English. But Professor Bajpai made the job for me very simple, and he encouraged me also to deliver something in Hindi, because through mother tongue, through our own language, we can connect with each other more closely than through a foreign language like English. Therefore, I shall be talking more in Hindi with some input in English for which I don't have Hindi words, क्योंकि ये भी जरूरी है कि हम अपना कहा हम आप ही समझे तो क्या समझे, मजा कहने का तब है जब एक कहे और दूसरा समझे। मैं इस विश्वविद्यालय में कई साल पहले भी आने का एक मौका मिला था, लेकिन मैं उस समय में नहीं आ पाया, कुछ कंफ्यूजन था आयोजकों के बीच में और मुझे जो ईमेल से यहाँ से जाता था उसके बीच में, तो मैं आ नहीं पाया। केवल मैंने अपना जो वक्तव्य था ईमेल से भेज दिया था। उसका मेरे ही विभाग, मेरे ही सहयोगी डिपार्टमेंट बायोकेमिस्ट्री विभाग के एक विशाल मिश्रा आए थे, वो शायद यहाँ लेके आए थे और उन्होंने प्रेजेंट किया था। मैं वाजपेयी जी भी हमारी कोनियाप से जुड़े हुए हैं, एकेडमी से जुड़े हुए हैं, मेरे से पहले से जुड़े हुए होंगे, और उन्होंने बड़ी विशद विवरण दिया आपका एकेडमी के उद्देश्यों के बारे में, कैसे वो हमारी संस्कृति से जुड़ी है, कि सनातन जीवन पद्धति से जुड़ी है, उसका उद्देश्य क्या है। विश्वविद्यालय अब हमारे देश में शिक्षा के प्रचार प्रसार के लिए और जो नई शिक्षा नीति है भारत सरकार की 2020 की, उसको विकसित करने में एकेडमी के सदस्यों ने क्या योगदान किया, उस पर चर्चा की। मैं हमारे जो अध्यक्ष वर्तमान हैं प्रोफेसर होशियार सिंह धामी, वो विदेश यात्रा पर है, उनके स्थान पर कार्यभारी अध्यक्ष के रूप में आपके बीच उपस्थित हूँ। तो सबसे पहले मैं एकेडमी की ओर से इस विश्वविद्यालय को, इसके चांसलर को, इसके वाइस चांसलर को, इसके जो अन्य पदाधिकारी हैं, आयोजन प्रबंध समिति के प्रोफेसर शैलेंद्र यादव जी को, जो कन्वीनर हैं इस संगोष्ठी के, और उनके सभी सहयोगी अध्यापक हैं, सभी वॉलंटियर्स और अन्य जो कर्मचारी जुड़े हुए हैं, जो छात्र जुड़े हुए हैं, उन सबके प्रति एकेडमी की ओर से आभार प्रकट करना चाहूँगा, उनको हार्दिक धन्यवाद देना चाहूँगा कि उन्होंने एकेडमी से जुड़ने के लिए समय निकाला। वाइस चांसलर ने सहमति दी, चांसलर ने सहमति दी, आर्थिक व्यवस्था की, स्थान की व्यवस्था की, और एकेडमी इसके लिए उनका हृदय से ऋणी है। साइंटिफिक विषयों के साथ साथ फिजिक्स, केमिस्ट्री, मैथमेटिक्स और टेक्नोलॉजी के विषयों पर चर्चा के साथ साथ सस्टेनेबल डेवलपमेंट गोल्स जो 17 हैं, उसका भी इसमें कुछ चर्चा होगी, जैसा वाजपेयी जी बता रहे थे और कुलपति महोदय बता रहे थे आपके। तो जो 17वां गोल है कोलैबोरेशन एंड कोऑपरेशन, वो तो शुरू हो चुका है। ये जो समारोह हम लोग कर रहे हैं कॉन्फ्रेंस का, ये उसी का जीता जागता उदाहरण है। उस कोलैबोरेशन एंड कोऑपरेशन वाले गोल के तहत ही एकेडमी, विश्वविद्यालय, इतने सारे लोग जो आयोजन समिति से जुड़े हुए हैं, जो बाहर से पार्टिसिपेट करने आए हैं, देश से, विदेश से, नेपाल से, यूके से, ये सब एक तरह का सहयोगी है। तो एक गोल जो सस्टेनेबल डेवलपमेंट गोल का है, हम लोग पूरी तरह से सिद्ध कर रहे हैं कि हम उस दिशा में काम कर रहे हैं। चौथा गोल के बारे में वाजपेयी जी ने बड़ी विशद चर्चा की, कुछ अपनी बात आगे भी रखेंगे जब उनका वक्तव्य होगा। सनातनी जीवन पद्धति तो पूरा प्रकृति के अनुकूल काम करने की ही पद्धति है, और वो सस्टेनेबल डेवलपमेंट गोल को पूरा केवल चौथे को ही नहीं, बाकी उद्देश्यों को, बाकी जो उसके ऑब्जेक्टिव्स हैं, उनको भी पूरा करती है। और यही इस तरह की संगोष्ठी का जो निष्कर्ष निकलेगा अंतिम दिन, जब कंक्लूसिव सेशन होगा, इसका समापन समारोह होगा, उसमें उसका निष्कर्ष निकलेगा, उसमें निकल कर बाहर आएगा। ये इस संगोष्ठी के समापन का एक बड़ी अच्छा योगदान होगा। और उसको जो भारत सरकार की नियामक संस्थाएं हैं, चाहे वो जलवायु परिवर्तन के बारे में सोचती हैं, या प्रदूषण के बारे में सोचती हैं, या जनसंख्या नियंत्रण के बारे में सोचती हैं, या गरीबी हटाने के बारे में सोचती हैं, या महिला शिक्षा और उनको कुशल बनाने के बारे में सोचती हैं, उन सब के लिए एक दिशा निर्देश का काम करेगा। इन्हीं शब्दों के साथ मैं आप एक बार पुनः आप सभी को प्रणाम करते हुए, मंचासीन व्यक्तियों को प्रणाम करते हुए, मुझे जो मौका शैलेंद्र जी ने आपके बीच उपस्थित होने का दिया, और साथ ही साथ दक्षिणा के रूप में हम लोग मेहर देवी का दर्शन भी करते हुए निकल जाएंगे, अगर संभव हुआ और रोड पे चल रहा हो तो। ये अप्रत्यक्ष दूसरा लाभ देने का उन्होंने सहयोग दिया है, उसके लिए मैं बहुत शैलेंद्र जी का आभारी हूँ, इस विश्वविद्यालय का आभारी हूँ, और पूरा एकेडमी का जो परिवार है उसकी ओर से मैं आप सबके प्रति आभार प्रकट करता हूँ, और स्वयं अपनी ओर से आभार प्रकट करता हूँ। धन्यवाद। जय हिंद।
Thank you so much, sir, for your inspiring words. Definitely, माँ शारदा हम सब पर अपनी कृपा बनाएंगी. In this sequence, I would like to invite Professor G.C. Mishra, Pro Vice Chancellor, Quality Assurance and Accreditation, to kindly present a memento to Professor S.N. Upadhyay, sir. Thank you, sir. Now, to move forward, it's my great pleasure to invite our Honorable Engineer Anil Kumar Soni, sir, Honorable Pro-Chancellor, AKS University, Satna, to kindly address this conference.
मंच पर उपस्थित इस इंटरनेशनल कॉन्फ्रेंस के चीफ गेस्ट श्री आर.के. शर्मा सर, नेपाल से आए हुए प्रोफेसर एम.एल. शर्मा सर, वाजपेयी जी, उपाध्याय जी, कृष्णा जी, विश्वविद्यालय के वाइस चांसलर चौपाड़े जी, प्रो वाइस चांसलर जी.सी. मिश्रा जी एंड त्रिपाठी जी, फैकल्टी ऑफ लाइफ साइंस के डीन प्रोफेसर यादव जी, सामने बैठे हुए देश भर के और बाहर से आए हुए सभी वैज्ञानिक, रिसर्चर्स और बच्चों, यद्यपि मेरे पहले वाजपेयी जी ने, उपाध्याय जी ने, सभी लोगों ने जो बात कही वह सस्टेनेबल डेवलपमेंट, साइंस, टेक्नोलॉजी, मैथमेटिक्स, इन सब पर आप लोग भी अभी डिस्कशन करेंगे, तो मैं अपनी बात को बहुत छोटा रखते हुए एक बात ऐड करना चाहता हूं कि ये पूरी पृथ्वी, सारा सस्टेनेबल डेवलपमेंट, सब कुछ हम इसलिए कर रहे हैं कि हम लोग अच्छी तरीके से रह पाएं, जीवित रह पाएं, स्वस्थ रह पाएं, और ये तब संभव है जब मानवता सुरक्षित हो। सारा ध्यान हमारी मानवता पे है, पूरा एग्जिस्टेंस पे है। अभी जब हम लोग बैठे थे तो मैंने एक किताब यहाँ पर मंगाई थी और सर लोगों को डिस्ट्रीब्यूट की थी, वो आपको भी मैं देना चाहूँगा। इस विश्वविद्यालय के चांसलर और मेरे पिताजी श्री बी.पी. सोनी जी ने एक कॉन्सेप्ट इंट्रोड्यूस किया जो भारतीय दर्शन पर ही है। आज स्थिति यह है कि मध्य पूर्व में, मिडिल ईस्ट में जो चल रहा है, हम सब उससे प्रभावित हो चुके हैं और बहुत जल्दी पूरी दुनिया प्रभावित होने वाली है। यूक्रेन और रशिया का जो युद्ध पिछले 3 साल से ज्यादा हो गया, वो चल रहा है और वो कभी भी खतरनाक मोड़ ले सकता था, लेकिन वो तो नहीं ले पाए। लेकिन हमारे अमेरिका के जो प्राइम प्रेसिडेंट हैं डोनाल्ड ट्रंप, वो भी सन की इंसान है, इसमें कोई दो मत नहीं है। जो आपने कहा कि एक अमेरिका को विकसित रखने के लिए कई अफ्रीका चाहिए होते हैं बिल्कुल सही बात है। उपभोक्तावादी जो संस्कृति है उसमें उसकी पूर्ति करने के लिए बाकी इनपुट बहुत आवश्यक होते हैं, लेकिन ये भारतीय दर्शन है कि हम लोग सबका विकास चाहते हैं और वह इस तरह से चाहते हैं कि पूरी धरती सुरक्षित हो। हमारे यदि पूजा पद्धति में देखें तो हम भारत की स्तुति नहीं करते हैं, हम पृथ्वी की स्तुति करते हैं। हम आह्वान पृथ्वी का करते हैं, पंडित जी आह्वान करते हैं तो पृथ्वी का आह्वान करते हैं, वो भारत का आह्वान नहीं करते, वो नेपाल का आह्वान नहीं करते। तो इस बात को ध्यान में रखते हुए मेरे पिताजी, एक दिन बहुत बड़ी टेंशन चल रही थी रशिया और ट्रंप के पुराने काल का, रशिया बोल रहा सॉरी, साउथ कोरिया और अमेरिका के बीच में। वो कहता था कि मैं परमाणु बम का एक बटन दबाऊंगा तो व्हाइट हाउस उड़ जाएगा, और व्हाइट हाउस वाले कहते थे कि हम चाहेंगे तो पूरी पृथ्वी, तुम्हारे पूरे साउथ कोरिया, नॉर्थ कोरिया को नष्ट कर देंगे। तो एक दिन मेरे पिताजी ऐसे सोचते सोचते सो गए और 2-2:30 बजे के आसपास उनकी नींद खुली कि यदि ऐसा हो ही गया, कोई सन की राष्ट्राध्यक्ष यदि चाह ले तो पूरी पृथ्वी को 5 मिनट में नष्ट कर सकता है। ये कैपेबिलिटी रशिया के पास भी है और ये कैपेबिलिटी अमेरिका के पास भी है। तो इस परमाणु युद्ध में यदि ऐसा हो ही गया, खुदा ना खास्ता, और डोनाल्ड ट्रंप बोल भी चुके थे कि हमारे पास में इतना परमाणु हथियार है कि हम 150 बार पूरी पृथ्वी को नष्ट कर सकते हैं, एक ही बार नष्ट करने के बाद में दूसरी बार देखने के लिए कौन रहेगा? और यदि पृथ्वी को बचाना है तो उन्होंने एक कॉन्सेप्ट लिखा है, वो मैं आपको किताब दूंगा, विश्व सरकार। कि विश्व सरकार ही एक माध्यम है जिसके माध्यम से हम पूरी पृथ्वी को हमेशा के लिए जंग से मुक्त कर सकते हैं। और इसको मैं 1 मिनट में एक्सप्लेन करके अपनी बात को खत्म करूंगा कि जैसे हमारे हिंदुस्तान में भी एक समय में बहुत राजा हुआ करते थे और वो आपस में लड़ते थे, लेकिन उससे पब्लिक को बहुत ज्यादा नुकसान नहीं होता था। राजा बदल जाते थे, सत्ता बदल जाती थी, क्योंकि उस समय परमाणु हथियार नहीं थे, इतना डिस्ट्रक्शन के पावर सरकारों के पास नहीं था, देशों के पास नहीं था। कालांतर में आज स्थिति ये है कि पहले हमारे रीवा महाराज और पन्ना महाराज लड़ते थे। जब ये सारे महाराज मीन्स सारे देश की सेनाएं, छोटे छोटे देश की सेनाएं एक देश की सेना में कन्वर्ट हो गई, तो आज उत्तर प्रदेश का मध्य प्रदेश से कोई झगड़ा नहीं है, मध्य प्रदेश का महाराष्ट्र से कोई झगड़ा नहीं है, और हम लोग शांति से कन्याकुमारी से लेकर के कश्मीर तक जा सकते हैं, व्यापार कर सकते हैं, शांति से रह सकते हैं। मीन्स यदि कोई एक ऐसी व्यवस्था जो आज हमारे पास में है जिससे कि सारी की मिलिट्री पावर सेंट्रलाइज हो गई, तो उससे हम सुरक्षित हो गए। ऐसे ही यदि सभी देशों की सेनाएं एक विश्व सेना में आ जाए और एक विश्व राष्ट्रपति हो, एक विश्व प्रधानमंत्री हो, एक विश्व संसद हो जो पावरफुल हो, तो फिर हमारी आपसी लड़ाइयां खत्म हो जाएंगी। और उसी को एग्जीक्यूटिबल फॉर्मेट में कैसे एग्जीक्यूशन में आ सकता है, ये डॉक्यूमेंट किया है उन्होंने कि अभी हाइपोथेटिकल लगता है कि हम कोई विश्व सरकार हो सकती है। ये सारा सस्टेनेबल डेवलपमेंट गोल्स वो उस सरकार के थ्रू हो सकता है कि यदि कोई एक सत्ता हो, लेकिन वह कैसी हो और कैसे बने, कैसे चले, कैसे रेवेन्यू मॉडल हो, ये सारी चीजें उसमें दी हुई हैं। एक राज्य, एक देश एक राज्य जैसा ही हो, उसकी खुद की आंतरिक सुरक्षा के लिए सिस्टम हो, लेकिन यदि दो देशों की सीमाओं के बीच की रक्षा के लिए विश्व सरकार हो, तो न मिसाइल की जरूरत है, न परमाणु बम की जरूरत है, न कोई टैंक की जरूरत है, और न बड़ी बड़ी सेनाएं रखने की जरूरत है। और वो जो जितना खर्च लगेगा उसका, वो सारा डेवलपमेंट में खर्च होगा। एक गोला बारूद, एक मिसाइल जितने में जाती है उतने में तो एक मेडिकल कॉलेज खड़ा हो जाता है, और पता नहीं कितनी मिसाइलें अभी इन्होंने निपटा दी। तो कहने का आशय यह है कि हम लोग इस पर चर्चा करते हैं, और चर्चा करने में इस बिंदु को भी हमेशा ध्यान रखें। मैं आप सबके सामने इसलिए रख रहा हूं इस बात को कि एक ये कॉन्सेप्ट है जो आपके माध्यम से आपकी जगह पर जा सकता है। हो सकता है 3 दिन में मेरे पापा जी भी आपसे आके मिलेंगे और एक बातचीत रखेंगे, वो उनकी भी एक चिंता है। और वो लगातार 87 ईयर्स की एज के हैं, 88 ईयर्स हो गए। 88 ईयर्स की एज में वो आज इस चिंता में रहते हैं कि विश्व को कैसे सुरक्षित किया जा सकता है। तो मैं उनको सलाम करता हूं कि इतना उम्र में और इतने विजनरी व्यक्ति हमारे विश्वविद्यालय के लगभग सभी लोग जानते हैं। आप यहां से गए होंगे तो बी ब्लॉक के सामने एक फोटोग्राफ लगा हुआ बहुत बड़ा, और उसमें लिखा हुआ है विश्व सरकार, ऊपर के लिखा हुआ है कि डोनाल्ड ट्रंप का वक्तव्य है कि पूरी दुनिया को यदि सुरक्षित रखा जा सकता है तो विश्व सरकार के माध्यम से रखा जा सकता है। यह हमने मोदी जी को भी दिया है, मोहन भागवत जी को भी दिया है, और विश्व के तमाम राष्ट्रों के राष्ट्राध्यक्षों तक पहुंचाने की कोशिश की है, पहुंचा भी है। कब होगा एग्जीक्यूट वी डोंट नो, लेकिन हम एक जागरूक कम्युनिटी हैं, पढ़े लिखे लोग हैं। एक विश्वविद्यालय को यदि नेपाल से शर्मा जी प्रेजेंट करने आते हैं, तो जब वो अपने बीच में अपने लोगों के बीच बात करेंगे तो यह विचार कहीं ना कहीं आगे बढ़ेगा। मैं इन्हीं शब्दों के साथ अपनी वाणी को विराम देता हूं, और इसके लिए हमने एक वेबसाइट भी बनाई है, वो है www.worldgovt.org, और उसमें सारी चीजें पड़ी हुई हैं। थैंक यू।
Thank you, sir, to telling the objective of Vishwa Sarkar, and we definitely promote this and sparing your precious time and making this conference more meaningful and with your presence. Thank you once again. Now, I request Professor R.K. Sharma, Honorary Secretary, Royal Society of Chemistry, London, North India Section, Faculty Advisor of International Student Chapter of ACS at the University of Delhi, Institute GC Coordinator, Green Chemistry Network Center, New Delhi, to kindly address the conference and share your valuable insight with us. R.K. Sharma, sir.
So first of all, I would like to welcome all of you on behalf of Royal Society of Chemistry, London. You know, the Royal Society of Chemistry is the world's largest chemical society, and this is working a lot for chemistry. All the high impact factor journals are published by Royal Society of Chemistry. For the students especially, they are giving grants to organize activity, to go for attending conferences. There are so many things they are supporting. If you go to the site of Royal Society of Chemistry, you will find so many things. And even the membership fee is very less for students. So they want to inspire students. Another thing is this, that we are, as our Vice Chancellor AKS University also emphasized, that we are developing technologies, but we are ignoring the effect of those technologies on environment and human health. And that's why green chemistry came into the play. Green chemistry is that chemistry which is good for human health and environment. So we have a Green Chemistry Network Center at University of Delhi, and we are working very hard to popularize green chemistry in India. You know the importance of chemistry. If you go to the lifespan, previously it was 47 years, but this was the chemistry that increased the lifespan, the age to 75 years. So this is all because of chemistry, and there are so many things in which chemistry is involved. So we chemists actually are making world worth living. But there is another side of chemistry, which is creating toxic world or the things. So the Green Chemistry Network Center is working to popularize green chemistry in India. And for this, we are doing green chemistry networking all over India. We are developing green chemistry educational material, especially for the students. We have introduced green chemistry paper in Delhi University syllabi. There are 3 papers in undergraduate syllabi in Delhi University. So like we are inspiring students to show them that whatever the experiments, traditional experiments you are doing, the same experiment you can do. You are using hazardous solvents, but you can do the same experiment either without using solvent or with using water as solvent. So we have developed even a green chemistry experiment monograph, and in that monograph we have taken the experiments, traditional experiments, and we have shown to the students that how can you modify these. Even for this developing the monograph, we got the grant from Department of Science and Technology, Government of India. Even DST requested me also to make a monograph for PG and UG students. And we have developed, and this is available, that monograph is also available on DST website as PDF file. So I'm giving few copies to Dr. Shailendra so that your university can also go through and see that whether this is good or not, or this is alternate for the experiment or not. So with these words, because it's already so much time is taken, I would like to thank Professor B.H. Chapade, the Vice Chancellor of AKS University, Professor Anant Kumar Soni, Dr. Shailendra Yadav, for inviting me to act as a chief guest. And you know, this conference is, especially for the students, is to attend because there are so many speakers from outside AKS University, and they are very good speakers. So I request all the students that you should attend the lectures and interact with them to see what is happening in sustainability. Even, you know, if you go to the world's top-ranking universities, Oxford University, Cambridge University, these are the, in UK, top-ranking university. And you have the speaker, even Krishna Sharma did MSc from Oxford University and PhD from Cambridge University. So you can interact with them, with him, and can see what is good for all of you. So with these words, I'm again grateful to AKS University for inviting me, and I wish that all the students and other participants, distinguished participants, will benefit from this conference. Thank you. Thank you very much.
Thank you, sir. Definitely these 3 days become more memorable and knowledgeable. Thank you, sir, for inspiring address and tell us about importance of the green chemistry. Now, we request Engineer Anand Kumar Soni, Honorable Pro Vice Chancellor, AKS University, to kindly present memento to Professor R.K. Sharma, sir, as a token of our gratitude. We sincerely Thank you, sir. We sincerely thank all the dignitaries, speakers for their enlightening thoughts and valuable guidance. Your words have truly enriched this conference and inspired us.
Every conference leaves behind a legacy of ideas and scholar contributions, and that legacy is beautifully captured in the conference Souvenir, which reflects the collective intellectual efforts of our researchers and scholars. So I would like to invite all the dignitaries, please come forward on the dais for release the conference Souvenir. May I request everyone to put your hands together for this wonderful moment.
After this, I would like to invite to Professor A.K. Mishra sir over here to announce IAPS Fellowship Award and proceedings. Professor A.K. Mishra sir.
IAPS के बारे में काफ़ी चीज़ें प्रोफेसर वाजपेयी जी और प्रोफेसर उपाध्याय जी ने बताया है लोगों को। तो अब जो है IAPS के जितने एक्टिविटीज़ हैं उसमें एक बहुत इम्पॉर्टेंट स्टेप ये है कि हम लोग IAPS के फेलोशिप की माने सेलेक्ट करके उनको ऑनर करते हैं। तो इस पे जो है ये IAPS फेलोशिप जो है ये IAPS का सेकंड मोस्ट इम्पॉर्टेंट और ऑनरेबल अवार्ड है और ये काफ़ी जो उन लोगों को दिया जाता है कि जो कि बहुत इमिनेंट है, अच्छे रिसर्चर हैं और अपने काम से रिसर्च और सोसाइटी को हरदम आगे बढ़ाया है। तो इस वर्ष हम लोग 2 लोगों को IAPS फेलो अवार्ड देंगे, जिसमें कि प्रोफेसर प्रभाकर सिंह ये डिपार्टमेंट ऑफ फिजिक्स IIT BHU के हैं और दूसरे हैं प्रोफेसर रंजीत कुमार उपाध्याय ये डिपार्टमेंट ऑफ मैथमेटिक्स IIT धनबाद के हैं। ये अवार्ड इन लोगों को उनके आउटस्टैंडिंग एकेडमिक अचीवमेंट, रिसर्च कंट्रीब्यूशन और उनके डेडिकेटेड सर्विस टू द साइंटिफिक कम्युनिटी को बढ़ाने के लिए दिया जा रहा है। तो मैं इन लोगों को IAPS कम्युनिटी में वेलकम करता हूं और वी आर लुकिंग फॉरवर्ड टू देयर स्पेशल एफर्ट टुवर्ड्स फर्दरिंग द काज ऑफ एकेडमी। सो सबसे पहले मैं इन लोगों को पहले एक साइटेशन पढ़ा जाएगा और उसके बाद इनको मोमेंटो और साल से और साइटेशन दे करके ऑनर किया जाएगा। तो पहले जो है प्रोफेसर रंजीत कुमार उपाध्याय जी जो कि मैथमेटिक्स के फेलो चुने गए हैं, इनके साइटेशन को पढ़ने के लिए मैं विजय त्रिपाठी जी को मंच पे बुला रहा हूँ।
Thank you, sir. Fellow of IAPS Award 2026 in Mathematics, Professor Dr. Ranjit Kumar Upadhyay. Professor Ranjit Kumar Upadhyay is currently Professor in the Department of Mathematics and Computing, Indian Institute of Technology, Indian School of Mines, Dhanbad. Professor Upadhyay is a distinguished scholar with an exceptional academic background. He earned his Doctor of Philosophy in Mathematics from the Indian Institute of Technology, New Delhi. He completed his postgraduate studies at the Indian Institute of Technology, Kanpur. His strong academic foundation reflects his deep commitment to academic excellence from the early stage of his career. Professor Upadhyay is an internationally acknowledged scholar whose pioneering work spans applied mathematics, mathematical modeling, and nonlinear dynamics. His research has significantly enriched the understanding of complex systems through rigorous mathematical frameworks. With an exceptional research record, Professor Upadhyay has published more than 200 research papers in reputed international journals. His scholarly contribution reflects originally depth and sustained relevance to contemporary scientific and technological challenges. Professor Upadhyay has also made significant contribution to academic literature through his co-authorship of internationally acclaimed textbooks on mathematical modeling and biological dynamics. These works continue to serve as essential references for students, researchers, and academicians worldwide. In recognition of his exceptional scholarly achievements, distinguished leadership, international standing, and enduring contributions to mathematical sciences, the International Academy of Physical Sciences, Prayagraj, is very humbly submitting this citation today on the 13th day of March 2026 and feel honored to confer the Fellow of IAPS Award upon Professor Dr. Ranjit Upadhyay for his outstanding contribution in mathematics. Thank you, sir. Please come on the stage.
अब मैं प्रोफेसर नरसिंह मूर्ति जी को मंच पर आमंत्रित करता हूं कि वो प्रोफेसर प्रभाकर सिंह का फेलोशिप का साइटेशन जो है यहाँ पर पढ़े।
Good afternoon. I am very happy to read about the citation of Professor Dr. Prabhakar Singh ji, and on behalf of IAPS, first of all, I congratulate you to getting this award. This is the very brief citation. Professor Dr. Prabhakar Singh is currently a professor in the Department of Physics, Indian Institute of Technology, Banaras Hindu University, Varanasi. Professor Singh is a distinguished scholar with an exceptional academic background, having earned his Doctor of Philosophy PhD degree in Natural Sciences with magna cum laude from the University of Münster, Germany. His strong foundation in material science and physics was developed through his postgraduate and undergraduate studies in Banaras Hindu University and Uday Pratap Autonomous College, Varanasi. With an impressive portfolio of over 200 research publications in reputed national and international journals, conference proceedings and editorial volumes, Professor Singh has established himself as a leading authority in his field. In recognition of his exceptional scholarly achievements, distinguished service, and enduring contribution to science and society, the International Academy of Physical Science, Prayagraj, is very humbly submitted his citation today on the 13th day of March 2026 and feels honored to confirm the Fellow of Indian Academy of Physical Sciences Award upon Professor Dr. Prabhakar Singh for his outstanding contribution in physics. Thank you, Vandal. Prabhakar Singh ji, please. बता रहे
Thank you, sir. For information, the poster presentation will begin on today. Participants are requested to contact Dr. C.P. Singh and Dr. Manoj Kumar Sharma, who will coordinate the session. All posters will be displayed on the C floor of A block, and the organizing team along with the volunteers will assist participants and support the evaluation process. The poster presentation will conclude on the same day. Awards will be given to the first to fifth position in UG and PG categories and first to third position among research scholars. The winners will receive their awards during the variety session of the conference. And with this, we come to the conclusion of the inaugural session. Now we will proceed to technical session of the conference, which will be conducted on three platforms. The one will take place here in Central Hall. The online presentation will be held in room C11 located behind the Central Hall, and the parallel offline presentation will be conducted in Vivekanand Hall situated between A block and B block. Participants are requested to proceed to their respective venue accordingly.
Thank you.
I request all the dignitaries present on the dais, please come forward on the stage.
बस थैंक यू भैया.
The true essence of any academic conference lies in its technical deliberation. With this, we now proceed towards technical session 1, where keynote speaker or invited speaker will present their valuable findings. We wish all the participants have a very successful and engaging session. It's now my great honor to invite our respected session chair, Professor C.K. Mishra sir, from the Department of Mathematics at Dr. Ram Manohar Lohia, Awadh University, Faizabad, Uttar Pradesh. Professor Mishra is a distinguished academician and researcher who has made valuable contribution to the field of mathematical science through his research, publications and academic leadership. He is widely respected for his dedication to teaching and his active participation in national and international conferences. His vast experience and scholarly insight greatly enrich academic discussions and research activities. May I now respectfully invite Professor C.K. Mishra sir to kindly take the chair and guide this technical session. Please join me in welcoming him with a warm round of applause. May I attention audience?
There is no tea time. We directly move for the technical session. For the technical session, I would like to invite chairperson of the session, Professor C.K. Mishra sir, kindly take the chair and guide the technical session. Without any delay, we start this technical session. As we see, our chairperson already present here, so let me start the technical session of this conference. For this, first up, I would like to invite Dr. Krishna Sharma is the first speaker, who is the professor in pharmaceutical chemistry in Kingston University, specializing in sustainable and green chemistry. He received his PhD from the University of Cambridge and previously conducted research at the University of York, University of Leeds and Imperial College, London on the environmentally sustainable chemical process. He has been recognized internationally through the programs such as CAS Future Leaders 2025 and American Chemical Society Leads Courts 2024. Dr. Krishna Sharma has published several research articles in high-impact international journals in the field of जी
मैम एक मिनट सभी स्टूडेंट्स ध्यान दें. इट्स माय हम्बल रिक्वेस्ट टू ऑल. पहले तो अपनी अपनी चेयर्स में बैठ जाइए. कोई कियोस नहीं होना चाहिए. पोस्टर्स प्रेजेंटेशन में जिन लोगों के शॉर्ट लिस्ट हुआ था वो लोग सिर्फ यहां से जाएंगे. रिमेनिंग स्टूडेंट्स अपनी जगह पे बैठेंगे. ठीक है. एमिनेंट साइंटिस्ट एंड डिफरेंट इंस्टीट्यूट से जो भी लोग आए हुए हैं वो उनके कीनोट स्पीकर्स होंगे जिनको आपको सुनना है, एंड 1:45 पे लंच होगा, ठीक है। उसके पहले आप सभी लोग यहीं पे बैठेंगे, कहीं मूव नहीं करेंगे। अगर इंस्ट्रक्शंस दिया जाता है तो उसको फॉलो करेंगे। अब प्लीज मेंटेन द साइलेंस। मैम प्लीज कंटिन्यू।
I request Dr. Dinesh Kumar Mishra sir, please call the Krishna Sharma sir, whose first lecture is here. We are waiting for them.
सिर्फ जिनके पोस्टर्स शॉर्ट लिस्ट हुए थे वो बस जाएंगे अपने अपने पोस्टर्स के पास, रिमेनिंग स्टूडेंट्स यहीं पे बैठेंगे। अब बेसिक साइंस के कितने स्टूडेंट्स हैं? यूजी एंड पीजी, बेसिक साइंस यूजी एंड पीजी, बीएससी यूजी एंड पीजी, वो सब लोग C11 में चले जाइए। बेसिक साइंस यूजी एंड पीजी स्टूडेंट्स सब C11 में चले जाइए।
Okay, let me start our technical session with our first speaker. Dr. Krishna Sharma sir is a professor in pharmaceutical chemistry and Kingston University, specializing in sustainable and green chemistry. He received his PhD from the University of Cambridge and previously conducted research at the University of York, University of Leeds and Imperial College London on the environmental sustainable chemical process. He has been recognized internationally through the programs such as CAS Future Leaders 2025 and American Chemical Society Leads Court 2024. Dr. Krishna Sharma has published several research articles in high-impact international journals in the field of green chemistry, sustainable synthesis and pharmaceutical chemistry. I would like to invite Dr. Krishna Sharma sir on the stage. I request our technical team, please help the sir.
check. Okay. Good afternoon, everyone. So, what I'm going to talk to you about today is going to be a journey. And as you can see on the cover slide, you can see a person rowing on the boat and navigating his way in this river, which has several different turns, unexpected pathways. And this is exactly what I'm going to take you through, the pathway towards sustainability, which is the theme of the conference. And in order for me to do that, I'll take you back in time, where I come from. So I grew up in Delhi, and then I was studying at University of Delhi at a college called St. Stephen's College. I'm not sure how many of you have come across this, but it was like a wonderful experience. I've had some amazing teachers. I'm sure you also have your own favorite teachers here. And I was very inspired by my organic chemistry teachers. The way they taught made me more interested. And then I thought where I could do some more of organic chemistry, some more research in the field of organic chemistry. And I thought the best place in the world would be University of Oxford to do that. So I applied without knowing whether I have a chance or not. And then I happened to be lucky that I had the opportunity to move to University of Oxford to study for a master's by research in organic chemistry. And I'm just going to briefly tell you what I was doing back in Oxford. You've probably come across enantiomers in your chemistry lectures. This is the same molecule where atoms, when connected differently, can have two different structures, two different forms. So you can have one form, same atoms, and then you can take a mirror image, and you can have another form of that molecule, which will be the mirror image form. And these two mirror images, they are entirely different in their properties. However, the same atoms, the same formula, but entirely different properties. One, for example, here is a sedative and anti-nausea agent. The other one causes a disease. It causes fetal damage, and it is harmful to human beings. And the entire point about this chemistry is how we can make molecules in a selective way and make only that which is useful for us. So that's what I was doing back in Oxford. I'm not going to go into the details of what this research was about, but it was basically about using environmentally benign techniques to be able to make such molecules in a selective way, so that we can only make one enantiomer. And the molecules that I was working on were these indoline molecules. They are very pharmaceutically important. They are found in several medicines. And the question was, can we make them selectively? So we used a special technique, this thing called phase transfer catalysis. It's a very environmentally benign technique. And we managed to make these molecules in high selectivity, so like in about 99% enantiomeric excess, 99% distereoselectivity. And the next thing for us was to figure out what is the mechanism of this reaction. What happens when we put all our starting materials in? How do they react? How do they form the product? And we were really interested in finding that out. So when I took my starting materials, you can see there would be no reaction for about 1,000 seconds, and immediately they start reacting, and the reaction is really, really fast, and it happens in like 30 seconds. And we wanted to figure out why we get this induction period, why the reaction doesn't happen for a particular time. And I still remember I presented this work in Oxford in my lab to my supervisors and the rest of the research group, and I had like a senior member of my group who told me, Krishna, this doesn't make any sense. It shouldn't be doing this, and you should change your project. And then I was speaking to my supervisor, and my supervisor, as always, a great mentor, he said, Krishna, it is doing that for a reason, and we have to figure out why it is doing so. This is science that we do. So we stick by it, and we spoke to some other inspiring people at Oxford, like John Brown, a really famous scientist, and we figured out why there is an induction period, what's going on in this reaction, and we discovered that, and we published this in the article. If you're interested in finding more about it, what we discovered, you can come to me later and ask me what we found about this. So the next thing before I move on to the next step, I just wanted to show you how the university is. These are our university buildings. You may have come across this in Harry Potter movies. They have been taken from Oxford. That's where a lot of these places is where they have been shot. This was our department here, and this is where I used to do these experiments in this laboratory. You may know that some of the foundational discoveries like glucose sensor, lithium-ion batteries that we all use in our mobile phones, devices, structure of penicillin, vitamin B12, X-ray crystallography, all of that happened here. And if you do visit it in future, I would definitely recommend having a look at this place, visiting this place, and be inspired where these ideas came up. So the next thing for me was I was interested in applying chemistry, organic chemistry to biology. And I thought which would be the best university in the world where I could do that. And I thought, what about applying to University of Cambridge and having a chance that whether I can do a PhD in chemistry there. So that's where I went to next. I was lucky. I got a PhD offer with scholarships. And I was there doing chemical biology. And my project was about, can I make molecules to target cancer? So this is, I'm not going to go into the details about it, but we have this protein in our body called P53. And it's functioning normally right now. What it does is it is killing any cancer cells. So cancer is basically excess growth of cells in our body, uncontrolled division of cells. And this protein checks that uncontrolled division of cells. It makes sure that this doesn't happen. When this protein becomes low in quantity, that's when you have uncontrolled division of cells, and that's when cancer happens. So what we could do as a chemist is that we can design molecules that can make sure that this protein is in the right amount. When it becomes low, when there is cancer, we can make such molecules that can target those problems, and they can make sure that we have enough of this protein to kill the cancerous cells. And that's what my PhD research was about. Again, I wouldn't go into the very much details because I have some more exciting things to talk about, what happens after this. But just to give you a glimpse of what we published, what we found out, we figured out molecules that were effective, and we used to do studies in mouse cells and in vitro test. And this basically talks about that. So I would just like give you a glimpse about the environment that I was in back there. So this was we all have a collegiate system. I'm not sure at this university how it is, but for example, when I was in University of Delhi, I was part of a college, St. Stephen's. Here, also at Oxford and Cambridge, they follow the same system, and we become part of a college. And this college was a changing experience for me, Trinity College. I will come to why. For that, I would like to tell you these parts, like, for example, this road or these courtyards. This is where some of the most sort of breakthrough scientists have worked, and they have actually done their discoveries. And I will next come to who are those people we are talking about. It is Isaac Newton, who was here, who was studying here and discovered gravity, laws of motions. We have his Newton's apple tree outside our college, which I will show you later on. But then all the other chemistry people that we talk about, for example, J.J. Thomson, Rutherford, from the atoms model, about Niels Bohr actually as well, James Maxwell, electromagnetism, John Rayleigh, who figured out why the sky is blue, the Rayleigh scattering effect, John Kendrick, and then we have some Indian Nobel laureates as well from there, for example, Venki Ramakrishnan. And then I'm not sure how many of you have watched this movie, The Man Who Knew Infinity. Has anyone watched it yet? I don't see any hands up. I would highly recommend, okay, one hand up there. I would highly recommend watching this movie, The Man Who Knew Infinity. It is the only movie that has been allowed to be shot in our college, and it is about the life of Srinivas Ramanujan, how brilliant mathematician he was, and how he ends up doing some remarkable work at our college, Trinity College, and we still are working on the problems that he solved or he hasn't solved completely, and we are still trying to figure out what's going on there. So fundamental discovery which has changed the world. Then we have some other people like Amartya Sen, Chandrasekhar, and many others. And it is the home to the maximum number of Nobel laureates in a college in the world. So it's a very inspiring environment where we get to speak to people, Nobel laureates, and we get to talk to them about our ideas. And this is something which has been very important, coming back to what the Vice Chancellor sir was saying, that how we can challenge what we do. And it is these people who make you think in different ways about what you are doing. Even though Amartya Sen is from economics, or Professor Gregory Winter won a Nobel Prize in his work about cancer discovery, different from what I'm doing, they would be very interested in what I'm doing, and they'll ask me questions about my work, and they will make me think in a different way, in a unique way. So to give you an example of how this unique thinking was, I want to turn your attention to a quote, to this quote. It's a courtyard called Neville's Court. This is where Isaac Newton was one day standing, and what he did was he clapped in this courtyard, and what you heard, which you can't hear right now, you heard an echo. You would hear an echo in this courtyard, and he thought this is a great place for an experiment. And what he did was he figured the time that the echo of the clap takes to come back, and he noted the distance from the point from where he was standing and to the end of the courtyard. Does anyone know what he could figure out by that, or what he discovered? Okay, I see some of the students already telling me speed of sound. Nobody knew the speed of sound back then, and he, just by using that, and many of us actually would probably do this and leave, but it's about thinking outside the box that we heard back in the introductions, how we could actually find something useful among all the inspiring things that exist around us in nature. This is a slide demo which will hopefully, I'm not sure if the volume will come up, but basically it's okay, fine, that's fine, don't worry about it. Yeah, basically you would have heard the echo of the sound coming back, and you should do that. When you visit there next, you should do that yourself. Just to refer to you some of the original Ramanujan's papers. So one day I was in my library and I took out all the Ramanujan's original papers where he solved these theorems, all the letters, and it was like a thrilling experience for me to go through that. It was like one of the most inspiring days for me actually back then. But not just that, you can have a look at Newton's Principia Mathematica, which has the laws of motion, because it was discovered here. You can have a look at many other things. The original copies are kept in this library called Wren Library. And then I just want to, coming upon that, I'm sure many of you would know about Stephen Hawking. I was fortunate while I was there, Stephen Hawking was alive, and we had an opportunity to attend his talk. And he was also very inspiring every time. As from the quote, as you can see, he said, be curious and try to make sense of what you see and wonder about what makes the universe exist. And however difficult life may seem, there is always something you can do and succeed at. It matters that you just don't give up. And it's very inspiring in very different ways, that thinking about things in different ways, not giving up with failures, and trying to solve a problem that is important for us, for the world. So on that note, I want to now fast forward. In the final year of my PhD at Cambridge, I had a chance to attend a workshop. So sort of a meeting like this, but a smaller meeting where 20 people from UK and 20 people from India were selected, and we met in Delhi. And the whole point of this meeting was we talk about the way that we are doing chemistry right now. And we found that the way that we are making useful molecules, very useful things around us, but the way we are doing it is very damaging to the planet and to the human beings as well, to us. Why? Because we know that everything comes from fossil fuels, petroleum sources, almost everything, and that leads to carbon emissions, leading to all of these problems, global warming, and then all of these repercussion problems. But not just that, it is also leading to human health and well-being impact, because many of these chemicals that we use, the solvents that we use, for example, dichloromethane, causes cancer. So so this solvent, I'm sure you have used in chemistry lab, the solvent is not even part of the final product actually. And the amount of solvent that is used is just enormous. Like it would fill up 100,000 of these rooms. The solvent that is generated for just 1 year would fill up like 100,000 of these rooms. So you can imagine how much damage we are doing to the planet by making them from fossil fuels and then discarding by incinerating it, again carbon emissions for the planet, the damage to the planet. And then also they are leading to diseases as well. So why are we doing chemistry in this way? So now follow up on that. This is just an article to tell you, if you write on Google dichloromethane bans, you will see about all the articles that have come up recently. Dichloromethane, which was being used for not just like making pharmaceuticals, not just doing chemistry, but like removing paints from the walls, decaffeinating coffee, and many other applications. And it's being banned because of its carcinogenic nature. So what happened in the final year of my PhD? I had an inspiring moment where I was in a lecture where Frances Arnold, so she was the advisor to the US president, science advisor to Joe Biden, and she had just won the Nobel Prize in chemistry, and she was visiting Cambridge, and she gave a talk. And one of the slides, the starting slides of her talk, was nature is the best chemist. And what she said was nature is already doing chemistry much, much better than us. It's making these molecules that we figured out from nature, for example, Taxol that treats cancer, and then many others, like for example, quinine that we use for anti-malarial treatment for a long time. All of these have come from nature. And nature doesn't do all of this damage to the planet and to human beings. It makes these molecules in a very sustainable way. What we do is we go into the lab and we make the same molecules in a very different way. We start from fossil fuels, we make all of that environmental impact, the human health and well-being impact. So the question is, why are we still doing things in the way that we are doing right now? Why we are damaging the environment? Can we be more like nature? Can we do chemistry in a sustainable way like how nature does it? And that chemistry is referred to as something called green chemistry, a word that you may have come across. So doing chemistry in a way that nature does, being safe for the environment and safe for living organisms. And in the interest of time, I'm not sure if I should, even if you will be able to hear it. It's a video by Frances Arnold. It's one of her lecture videos. It's on YouTube. And you should go watch it. It's just the same thing that I told you. That's what she emphasized in her lecture, Nobel laureate prize-winning lecture, basically. So coming back to green chemistry, what I referred to you about the solvents, dichloromethane, and many other harmful solvents. Which solvent do you think that nature is using? Any clue? So nature uses something called water that we all drink on a daily basis. We use in several applications, and this is what nature uses. It uses photosynthesis for the energy. This is where it gets energy, and it makes these amazing molecules that have changed the way of our life. So the next thing for me was, can I actually take all of this inspiration and change the way that I've been doing chemistry? Because the master's work that I showed you, the PhD chemistry work, however important it was, I was still using these harmful, toxic solvents coming from petroleum, doing all of that damage. And the question was, can I move away from these solvents? And can I do the same chemistry, useful chemistry, in a safer way, safer for the planet, safer for us? And the solution was to replace these toxic solvents with water, something which is safe, renewable, economical, sustainable, and environmentally benign. And that's what I did. So I was on my first postdoc at University of Leeds. It was funded by the government, the project. And in the project, what we did was we replaced the solvents with water as a medium. And we thought, what would be that chemistry that we would want to apply this on? So we thought, let's pick that most impactful chemistry. So about 1/4 of our medicines, about 1/4 of our medicines have fluorine atoms in them. So this fluorination chemistry, attaching fluorine to molecule, is really, really important for us. And this chemistry is being done in dichloromethane solvent, very toxic reagents, very toxic conditions. And we thought this is a great way for us to start. If we can replace these toxic solvents and reagents for fluorination, we impact about quarter of the pharmaceutical chemistry sector. So we picked this chemistry, and we thought, let's solve these problems by using water instead as a solvent. Now, just to give you an example, that one of the drugs, one of the fluorine-containing molecules is methyl sulfonyl fluoride, and it's been investigated for potential Alzheimer treatment. I mean, there are several other molecules with high therapeutic values containing fluorines. But just to start with an example, I'll give you that. And we thought, can we make this in water? Now, the problem with doing fluorination chemistry in water is that when we take fluorine in water, it really loves water because it's the highest electronegative element in the periodic table. So what it does is it forms very strong hydrogen bonds in water, and it will be totally unreactive. So the notion of doing fluorine chemistry in water, attaching fluorine to molecules in water, it's not going to work. And people have long believed that you have to remove even traces of water. There shouldn't be even traces of water in your mixture, because even if you have 1% or 0.1%, the reaction will not happen. And we were, you can probably say we were sort of bunch of fools back then. We said, no, we will do this in water, which people believe that this is not possible. So we actually did it in water. And why? Because we took inspiration from nature. There is an enzyme in nature that exists called fluorinase. And this enzyme is able to attach fluorine atoms to molecules in water. We thought, let's take this inspiration and let's try anyway. So we thought, there are these molecules called surfactants, and you have come across these in your soaps, detergents. What these molecules do is they are able to collect the dirt from your clothes in the water, and they're able to take it away. Same thing can happen in reactions in water. These soaps, detergents, these surfactants can form micelles, and these micelles can take away these molecules and form a layer around them, and they can act sort of these organic medium for these reactions to occur. They can concentrate these molecules, and the same chemistry can happen in water. So we thought, let's try that. And to try that, there are more than 100 different surfactants that exist. We thought which one we should try. So that was a major question. Now for that, what we did was we used data science. Can we use data science, computational science to make it faster? And that's what we did. So with AstraZeneca, we collaborated and we made the first ever surfactant map, which we can use to find out the best surfactant for even your reaction. If you want to do any chemistry in water next, just go to this map that we have developed and find out the best surfactant for you. And I can help you figure out how to use this map if you want to know the details. But basically, initially it was a complete failure. We got 1% yield. Nobody believed that this was going to work. But we kept on it, and finally we figured out the best way to do it, which was we managed to make it work in water. And not just make it worked very, very well. And the way it worked, it would give you the product, and it would precipitate it out as white solid from water, because water is aqueous, the product is organic, and there was no purification required. So it was like an excellent system to deal with in water without any damage to the environment. And we even managed to replace the reagents that we use, so the toxic cesium fluoride with much cheaper, much economical, reducing the cost by about 10 times for the industries, and making it much safer as well. So I'm not going to go into the details of what are the molecules that we made, but we tested it in a lot of different kinds of substrates. And then we did some mechanistic investigations. We wanted to figure out what was going on, why this reaction still works in water. So we figured that out by doing some microscopy studies. We observed what was going on in a magnifying glass. And then I won't go into the details about biological applications. We managed to implement it in biology as well, this chemistry, because now this chemistry happens in water. So biology, our entire biology is all water. So now we could use that under biological conditions as well. If you are interested in finding out more about this work, you can have a look at this article that we published about this work. And I just want to tell you that this work got a lot of attention, and I had the opportunity to go to the Parliament, UK Parliament, and present all of this green chemistry work to the parliamentarians. because they are really interested in how we can achieve net zero targets for the UK by implementing green chemistry. And I got some amazing discussion, amazing feedback from the parliamentarians. This was in House of Commons, and we had House of Lords members, all the MPs coming in, and my local MP at the time, Hilary Benn. So he's been a minister for the UK, and he's still the shadow minister. Very senior politician. He was very supportive, has always been, and he was there as well, supporting in this mission of sustainability in chemistry. So now we have also turned many other reactions to greener ways, and unfortunately, because of the time constraints, I cannot talk to you about all of those different reactions, but I will just briefly mention about Henry. This is another reaction that is used for making several different medicines. And some of the examples are right here: blood pressure, treatment, antibiotic, anti-HIV. And this reaction again uses very deadly conditions, very deadly solvents, very harmful things. So we managed to change this and make it more sustainable by using water. And not just that, like this reaction worked much, much better in water. It was like 10 times faster than it would happen in dichloromethane or organic solvent. So the next thing again for us as curious minds was to figure out why it is faster in water. And we figured that out, why it is faster in water, by doing some calculations and doing some experimental investigations. And we reached to the point that why this was even faster. Now there is something called flow chemistry. We are using solvent, we are using water, but why don't we save water as well? So one thing we wanted to do was we want to recycle water and use it again for the reaction. And this is something we managed to do. We managed to recycle the water and then use it again multiple times to do the same chemistry and make more of the product. And that was very impactful as well, because it reduced so much of the waste. Most of the waste, 80% of the waste, is solvent, which is not even part of the final pharmaceutical drug molecule. So after this, I had an opportunity to move to a center, very specialized center in New York called Green Chemistry Center of Excellence. And this is where someone called James Clark, my postdoc supervisor, second supervisor was, he started this field in the UK, he started this center. He thinks in a very different way, and I had the opportunity to spend time with him and think in the way that he has thought, and he has changed the world. And it was a very learning experience for me, and I can also share what I learned from him later on if any of the students are interested in finding out more. I managed to learn how we can get solvents from nature, not just water. Can we have other solvents, like coming from biomass, for example? And one example is the solvent called styrene. It's completely safe, biorenewable, and biodegradable, and it can be used for pharmaceutical applications, paint removals, and other things. So after that, I've started my independent academic journey as assistant professor at Kingston University, London. This university is within the nature, as you can see. It's in this royal place called Richmond Park. Next to that, it's in a place called Kingston, where kings used to be crowned in England. The first king was crowned in this place where the university is situated. It's very green, so it inspires you to do sustainable chemistry in that place. And the building itself has won several prizes, several awards for the architecture. Just wanted to highlight for the students one of the conferences that you can attend to get to know about green chemistry. It's 5 minutes I have.
Okay.
So yeah, you can know about green chemistry. World leaders come to this conference and come to this meeting, and this will be very useful for masters and PhD students. We also have a mentorship session in this conference to train the future leaders, and people from India come and they get trained and they go back to India and they do things innovatively, sustainably. I wanted to tell you that this is a society I started at Cambridge University, and I have been helping Indian students with their admissions in Cambridge, before they arrive in Cambridge and after they arrive in Cambridge. And we have been mentoring them, welcoming them, creating a homely atmosphere for them. And I'm happy to tell you many of them are now back in India, serving the country in various high positions. They are doing something incredible for the country. So if you are interested in being mentored, or in future, if you are coming to Cambridge, you can sign up for that society. as well. I am also a mentor at University of Oxford and University of Cambridge, and what we do is we mentor students to get scholarships, to apply, to find out their career paths, and some of the great things are happening in terms of helping the community. The collaborations goal, SDG 17, and it is really important. I highly encourage all of you as well to help one another, help someone to get education in your university who doesn't have the resources. And just this week I heard that one of my mentees has cleared the civil services exam and has received a top rank, and he comes from a village actually from India, and he studied at Cambridge, was my junior who I was helping, and then another student has just received a scholarship to go to Oxford University, and it feels very nice when we hear these people about others doing great things. So I will skip that, but I just wanted to say that another one of our missions has been about spreading sustainability in the world. And this is what I have been on. So I've been visiting a lot of different colleges and universities across India. These are some pictures from different villages, schools, cities across India where I went, and it was very inspiring, all of these sessions. And it's being featured in the news article if you want to know more. But just wanted to highlight these sustainable development goals that we stand by, and the UK's industrial strategy, and then we have the India net zero strategy as well. What we are doing here is basically trying to meet the goals that have been set by the world, including India, UK, and other countries, to reach our net zero emissions, reach sustainability in the world. And with that, I would like to say thanks to actually thanks to first the organizer for having me here. And then I would just like to thank all of my mentors for enabling me to where I am today, because I wouldn't be here without them, the mentors. And I would encourage you to find good mentors for you as well, so that you can be inspired, you can be motivated to achieve things and solve the big problems that we have currently in the world. Finally, I just wanted to thank also my parents, who actually happen to be here today with us, and their support has been very incredible for me. It has made it possible to be where I am today. Finally, I just wanted to say my contact details are there. If you want to contact for anything at all, feel free. And that's it, and thanks everyone.
Thank you. Thank you, Professor Krishna.
Any questions, by the way? I just wanted to ask, sorry. I'm very open to the questions. I'm sure you have loads of questions.
No. Thank you.
Okay. You can ask me later if you want.
Thank you, sir, for that incredible and insightful, thoughtful, thought-provoking presentation. Definitely, we take help in future for the new research and resource. Now, may I request our respected session chair, Professor C.K. Mishra, to kindly present the memento as a token of gratitude and appreciation. Professor Krishna Sarma, please come on the stage for the memento. Thank you, sir.
Now to move our next keynote speaker, it's my great honor to introduce Professor Upadhyay, sir. Professor S.N. Upadhyay, sir. A distinguished academician in the field of chemical engineering. He completed his graduation and PhD from BHU, Banaras Hindu University. Served for many years in the Department of Chemical Engineering at IIT BHU, Varanasi, where he later became professor. Also served as a director of the Institute of Technology, BHU. During his remarkable academic career, he has guided over 100 postgraduate dissertations, 33 PhD scholars. His research area includes heat and mass transfer, heterogeneous catalyst, industrial pollution control, and biodegradable polymer, with more than 220 research publications to his credit. He is a fellow of several prestigious academies, including the Indian National Academy of Engineering and Royal Society of Chemistry, UK, and has received many honors such as Sir C.V. Raman Award and Lifetime Achievement Award. We are truly privileged to have such eminent scholar among us today. Sir, please.
मैं कर सकता हूँ कि वो लोग करेंगे? कहाँ से, किससे? ये अच्छा। नमस्कार। I have not been educated formally as a biology student. When I was a student in school, from 9th class onwards, mathematics and biology group were being separated. Those who were willing to go to medical, they were studying biology. Those who were willing to go to basic sciences and engineering, they were studying mathematics, physics, chemistry or science up to 9th and 10th, and then after that physics, chemistry, mathematics in 11th and 12th classes. So I had not been formally educated in the field of biology. My biology background is only up to 8th class. But when I became a faculty in the Department of Chemical Engineering at Banaras Hindu University, after I joined the Department of Chemical Engineering as a lecturer, at those days it was not assistant professor, it was lecturer. I went on study leave to USA in Chicago, and after 2 years I returned back from that place to join back my duties at the Banaras Hindu University in the month of September. All the courses were assigned to other faculties. Only one course on biochemical engineering was left, for which most of the students have opted already as an elective. And the head of the department who was there at that time heading the department asked me that this is the only course which is available and you will have to teach it. I pleaded, sir, I have never studied biology, I cannot teach biology and I don't know microbiology and biochemistry. But he said that no, you have to do it and you can study and do it. So I obeyed his orders and I studied biochemistry and biology using a book which those students who are studying here in biotechnology, Fundamentals of Biochemical Engineering by Bailey and Ollis. And from that book I studied biochemistry, microbiology, and then the processes which are very similar to chemical process which chemical engineers study and use using the mass transfer operations, heat transfer operations, chemical reaction engineering, and other related activities which in an industry a chemical engineer is required to do. So I shall be focusing my experience on defining techniques, tools, types and contributions in the area of biotechnology, because I got an opportunity to develop a course in the Faculty of Science in biotechnology, MSc program in biotechnology, and in my department in the Institute of Technology, School of Biochemical Engineering. So that gave me an opportunity to study this discipline and prepare some slides for educating and informing students coming to the first year in the induction program. So these slides are not based on my research, unlike Professor Sharma. These are the slides which I prepared for first year students coming to biochemical engineering, coming to chemical engineering, and also to other engineering branches which are now required to study biology, to introduce them the biotechnology field, its types, its limitations, and its advantages. Who is an engineer? One who can use physics, chemistry, mathematics with biology in the modern time to do something on a large scale for the benefit of human society. So that person is an engineer. Engineering is a fascinating word, so other disciplines have also opted it. Politicians, the social scientists, social engineering, political engineering, etc. Three circles which are intersecting with each other: physics, chemistry, mathematics, and in the center it is engineering sciences. The activities of an engineer, whether chemical, mechanical, or civil, is influenced by the society, ethical, biological sciences, economic factors, political factors, and social science, social factors. If we include biology also in the circles, we get the discipline in the center which is shown as bioengineering, which is a combination of all four basic science disciplines: biology, physics, chemistry, and mathematics, coupled with engineering sciences. Biotechnology involves using live organisms or enzymes to create products useful to humans, fundamentally based on genetic engineering, altering DNA chemistry, and bioprocess engineering, maintaining the sterile conditions for microbial growth, etc. क्या हो रहा है भाई?
वो ऐसे बता दीजिए कुछ.
मेरी आवाज तो सुन रहे हैं ना आप?
आवाज आ रही सर.
अच्छा, इसीलिए जब हमने पढ़ाना शुरू किया था तो चाक एंड बोर्ड का इस्तेमाल होता था. मुझे पीरियोडिक टेबल पूरी की पूरी याद थी, ऑल बेसिक 92 एलिमेंट्स, लेंथेनाइड और एक्टिनाइड सीरीज को छोड़ के. लेकिन धीरे धीरे जब पावर पॉइंट का इस्तेमाल होना शुरू हो गया तो वो धीरे धीरे दिमाग से गायब होने लग गया, और एज के साथ साथ कुछ बैड सेक्टर भी दिमाग में बनने लग गए, जिसको कंप्यूटर से तो आप क्लीन कर सकते हैं, मेरे दिमाग से तो क्लीन नहीं हो सकता. शायद मरने के बाद ही क्लीन होगा तो होगा. तो लेक्चर शुरू होने के पहले हम लोगों को इनको भी प्रार्थना करनी चाहिए सरस्वती देवी के स्थान पर. दर्द सिर के वास्ते चंदन लगाना है मुफीद, पर उसको घिसना और लगाना ये भी दर्द सिर ही तो है. तो ये गजेट्स यूजफुल भी हैं और हेडेक भी हैं. The core principles of biotechnology include these subjects: genetic engineering, bioprocess engineering, recombinant DNA technology. The key tools of DNA technology, RDNA technology, includes restriction enzymes, ligases, vectors, host cells. These terms biotechnology students will study. Then tools and techniques include, besides bioreactors, gel electrophoresis, and other advanced techniques and characterization techniques. Key processes involved are isolation of DNA, fragmentation of DNA, isolation of desired fragment, ligation, transformation, culturing host cells. Biotechnology can be classified into several subheads based on the field for which it is being developed or used, or on the basis of the color coding also. Medical biotechnology or red biotechnology, agricultural biotechnology or green biotechnology, industrial biotechnology or white biotechnology, marine biotechnology or blue biotechnology, food and nutrition biotechnology or yellow biotechnology, environmental biotechnology or grey biotechnology, bioinformatics gold biotechnology, arid land biotechnology, or brown biotechnology, bioethics, violet biotechnology, and bioterrorism, or dark or black biotechnology. So these are branches which overlap. The characterization or the types is not limited, the overlap. In biotechnology, products and processes are also often classified by the relationship between the production volume, low volume, high technology, high volume, low technology, low volume and high value products like biopharmaceuticals and like biofuels or methane or alcohol. High volume, low value technology, some examples are given here. Bioenergy such as biodiesel, bioethanol, biogas. Production scale requires massive biorefinery facilities to ensure economic feasibility, as these products must compete with the conventional fossil fuels and their alternatives. Purpose is that these high volume products are often used to lower the internal energy cost for industrial plants and to provide consistent revenue through mass marketing distribution to the owner of the industry. And challenges are large scale production is necessary because profit with smaller amounts becomes slim. Some examples of low volume and high volume technology, primary examples include biopharmaceuticals, some vaccines, insulin, etc. Production scale data information is often given 100 liters to 2000 liters. Purpose is also listed here. Key characteristics are complexity, intellectual property right. So any person who is working in this area can get IPR or the patent more easily than working in the conventional engineering areas. The high volume, low volume value technologies and the low value, high value technologies, low volume, high value technologies. The characteristics are listed here. I will not read it. Application across biotech colors, as I told you that this is variable and they can overlap. Some techniques I have listed in these slides. The basic steps which are involved in the principles of tissue culture, the steps involved in the formation of recombinant DNA by action of recombinant endonuclease enzyme and E. coli, diagrammatic representation of rDNA technology. I will not go into the step-by-step details to save time. The electrophoresis figure is given here, how the separation takes place. The wells are there, then the largest, then the smallest branches of the DNA bands, how do they separate, and how genetically engineered E. coli cell will look like with the different additives which have come to its DNA. rDNA after coagulation and can be separated as shown in this figure. Polymerase chain reaction to characterize the enzyme and to characterize the modified organism. Build, break and rise. These 3-4 slides I will probably in the end. You have to build the problem, build a concept, break into steps, and then rise to the demands of the market and demands of the society. Build, break, overcome barriers and disruption are listed here. Break encompasses both the scientific breakthrough that solve unsolvable problems and the act of breaking into the industry. Scientific breakthroughs include technologies like CRISPR-Cas9 have allowed scientists to break into the genetic code to repair double-strand breaks or treat previously incurable diseases like sickle cell disease. Industry in that entry includes example of companies like GenSpecs break into biotech, non-traditional learners with the mentorship and hands-on training program into the rapidly growing sector. Then use of artificial intelligence is now also possible, and it is accelerating the drug delivery about which Dr. Sharma was talking about. Then the economic issues, the economic growth. Examples are from India. The Indian bioeconomy is projected to rise to $300 billion by 2030, up from just $10 billion in 2014. Market leaderships in our country and Asia Pacific. Some companies are there which developed the vaccine for the COVID, located in Bangalore. Career demand is employment in the sector is expected to see a sharp rise, with projections from 30 to 40 lakhs total jobs by 2030, particularly in the leadership and the business facing roles as an entrepreneur. And this is a good news for the students who are studying biotechnology here. Bioreactor technology, only few slides I will show, low volume, high volume, etc. These can be made from stainless steel as a stir tank bioreactor, continuous bioreactor, or airlift bubble column bioreactors, aseptic stainless steel fermenters, and mass transfer work which I have done have some relation to the airlift and bubble column bioreactors which I used for wastewater treatment. The single-use bioreactors, rocker wave bioreactors, hollow fiber bioreactors, glass stir tank bioreactors, and micro bioreactors. These are the recent developments which are happening in this industry, with different volumes from few liters to 100 liters. Again, similar comparison for the reactor types and their size and the capabilities. The sketches of the reactor, the stir tank reactor and the sponge reactor is shown on the right hand side. These slides I will skip. The traditional roles of a biochemical engineer, a chemical engineer and biochemical engineer is listed in this slide. Petrochemical, petroleum, natural gas, extraction and processing, plastics and polymers, pulp and paper, instrumentation and process control, energy conversion and utilization, and environment control. These are the opportunities for the biochemical engineers and biotechnologists in the field of general field of biotechnology and biopharmaceuticals, in the food and drink sector, water sector, water remediation or wastewater treatment, biomedical aids and pharmaceuticals, cosmetics, bulk chemicals, specialty chemicals, consultancy as design and operation expert, energy, health, safety, etc., etc. I can skip this. If you want to become an entrepreneur, you should have these factors affect the activity of a person who wants to become an entrepreneur: economic environment, political environment, legal environment, technological environment, and socio-cultural factors, and the person's aptitude itself. So all these are support needed to support the activities of an entrepreneur. Personal traits and characteristics, it is a teamwork. A single individual can do research in the lab on small scale in the reactors or beakers and flasks, etc. But for a large scale biotechnological operation, one requires teamwork, innovation, a vision, a leadership, inspiration, and motivation. We need people of this kind for our country so that our biotechnology area can develop. And this quotation I have listed from our own scripture: Prarabhyate nakhalu vigna bhayan nichai prarabhya vigna vita virmanti madhya vignai punah punarapi pratyahanyamana prarabhya chottam jana na parityajanti. We need three types of person. We have three types of person in our society. The निम्न कोटि के व्यक्ति जो काम नहीं, कोई भी काम प्रारंभ करने में डरते हैं और कोई भी काम नहीं कर पाते हैं. देन मध्यम कोटि के व्यक्ति जो काम तो शुरू कर देते हैं लेकिन बाधा आने पर उसको छोड़कर दूसरा काम शुरू कर देते हैं. लेकिन उत्तम कोटि का जो व्यक्ति है वो कोई भी बाधा, एक काम जो हाथ में ले लेता है उसको लक्ष्य तक ले जाता है. तो हमें हमारे देश को 21वीं सदी में ऐसे ही व्यक्तियों की आवश्यकता है. और जो इटालियन भाषा में नीचे कोट मैंने दिया हुआ है ओविड का, वो भी इनकरेज करता है कष्ट उठाने को और उससे क्या फ़ायदा मिलेगा बच्चों को या स्टूडेंट्स को. बी पेशेंट एंड टफ, someday this pain will be useful to you. The green ones which are listed here are that I have taken from the sustainable goals of the UN, and the green ones are listed here. Green ones are shown here. Biotechnology is required. In other areas, chemistry or chemical engineering or physics is required. I will not show these slides. These slides are examples of industries or the areas in which chemical engineering and biotechnology have helped the society quickly rush through. In the field of energy, in the field of aluminum industry, cement industry, in the field of chemical drugs like aspirin, in the field of large scale production from lab scale to full scale in the chemical industry, brewing as a product of biotechnology, not biotechnology at that time, it was a brewery, and this requires basic of biotechnology and biochemistry to produce on large scale. Fueling the world's economics, creating cleaner energy, products from growing populations, clean water through reverse membrane separation system, removing harmful lead and sulfur from fuel gas using directly through biofiltration or through bioremediation, or cleaning the polluted air, or producing biodiesel. Better living through chemistry and biochemistry, producing plastic or biodegradable plastics, stretching natural resources, bioplastics for example, and the other things, the synthetic rubber, Kevlar, etc. Large scale production engineering, penicillin for example, an example of this large scale production engineering which was studied at the lab scale, then the industry grew. And some photographs relating to that industry are shown here. Convenient and abundant food can be provided through the use of biotechnology and chemical engineering. These slides I have taken from a report prepared by the American Institute of Chemical Engineers in 2010. Healing diseases and extending life. The artificial dialysis system through which based on membrane technology or artificial kidney is a biotechnology product. Novel medical aids, site-specific and skin-specific diseases which can be introduced in the body without chewing, taking a syrup or swallowing a pill. Biopharmaceutical sector has several applications of biotechnology which I will skip. These examples biotechnology opportunities for top 10 problems for next 50 years. Energy, water, food, idam sarvam yatkin jagatyam jagat ten taktena bhunjita mahagrida kasyasvi dhanam. We should not try to hoard something because nature provides us for all of us, and in our mythology or in our social systems, the people worship banyan tree, peepal tree, and there is a sloka, Moolam Brahma Tucha Vishnum Sakha Rudra Maheswara Patre Patre Tu Devanam Vriksharajo Namastate, और द्रौपदी का अक्षय पात्र, नरसिंहावतार, गणेश, रक्तबीज की जो कथाएं हैं, that can be easily linked to products which we can get from through the biotechnology. Thank you. और मूवी दिखा दीजिए. I will show you a small 3 minutes movie on Samudra Manthan. It's a music and it has also a message for all of you. You might be knowing the story that the gods were defeated by demons and they approached Lord Vishnu, sir मदद करिए हमारी, दानव हमको हरा देते हैं. तो लॉर्ड विष्णु तंग हो गए थे उनका अनुरोध सुनते सुनते, तो उन्होंने कहा इनको कुछ शिक्षा देनी चाहिए. चाहते थे उनको कह सकते थे कि एवं मस्तु विजयी भव, लेकिन उन्होंने कहा इनको सीख भी देनी चाहिए. तो उन्होंने कहा कि जाकर समुद्र का मंथन करो. उसी के ये चित्र है.
The ocean that sustains life on this blue planet. Eons have passed since the Devas and the Asuras the gods and the demons were engaged in a mortal combat for supremacy. The king of gods, Indra, went to Vishnu, the lord of creation, and prayed for a boon, Amrit, the nectar of immortality. And Lord Vishnu advised Indra to seek the friendship of the Asuras because it will need the united strength of the Devas and the Asuras to churn the ocean, seeking the prize for immortality. Thus began the epic of Samudra Manthan, the quest to the ocean. So the Devas and the Asuras joined hands in peace. Mount Mandala became the churning stick, while Snake Vasuki offered himself as the ring. And so began the churning.
अमृत मंथन हो रहा है.
The great endeavor nearly failed when the Mount Mandala began.
तो मैं बनारस में रहते हैं सर.
वहीं घर बना लिया है.
In that crisis, Lord Vishnu became Kurma, the great tortoise, to carry the Mount Mandala on his back.
आंटी जी और आप.
बड़ी बेटी नोएडा दिल्ली में अपने परिवार के साथ, छोटी बेटी बम्बई में अपने परिवार के साथ, बीच का बेटा है. हाँ जी. कहाँ रहने दीजिए, अभी कर दीजिए.
Dashed out from the abyss, threatening to destroy all life, heralding chaos. So Lord Shiva, the Lord of Destruction, came forth and imbibed the deadly alarm.
नहीं अभी 1 मिनट का.
His throat turned blue with the poison, but all living beings were saved. The Samudra Manthan went on, and soon the ocean yielded the precious treasures. Lakshmi Kaustubha Parijat Sura Dhanvantari Chandrama Gavakamadhen Sureshwaragajo Rambhadi Devangana Ashvah Saptamukho Vishama Haridano Shankaham Rityam Cha Ambodehu Ratnaniha Chaturdasham Pratidinam Kurya Sada Mangalam Kurya Sada Mangalam.
तीन तरह के संदेश इससे मिलते हैं आपको इस मूवी से. पहला तो समुद्र मंथन या उस जैसा कोई बड़ा काम करने के लिए अकेले नहीं हो सकता है. एक चना भाड़ नहीं फोड़ सकता, ढेर सारे चने जब फटफटाएंगे तभी भाड़ फटता है. इसलिए विष्णु भगवान ने दानवों और देवताओं से कहा मिलकर जाकर समुद्र का मंथन करे. कोऑपरेटिव एक्शन जो सस्टेनेबल डेवलपमेंट के एक गोल में से भी है. दूसरा संदेश ये मिलता है जब तक डिज़ाइन रिएक्टर की प्रॉपर नहीं होगी तब तक कोई मंथन, कोई फेज सेपरेशन नहीं होगा. समुद्र को अगर मान लें कि मिक्सचर ऑफ सो मेनी फेजेस, जो 13 रत्न काम के निकले वो मिक्स्ड उसमें थे. उस समय की कल्पना है, आज भी हम उसको निकालते हैं दूसरे नामों से इंडस्ट्री के जरिए. तो इतना पदार्थ निकालने के लिए जब कुछ बड़ा काम आप करेंगे बायोटेक्नोलॉजी का इस्तेमाल करके तो पोल्यूशन भी निकलेगा. पोल्यूशन का इसमें जो दिखाया था कि शिव जी सृष्टि का नाश होने लगा, शिव जी ने इसको गले में धारण कर लिया, उनका शरीर नीला पड़ गया, नीलकंठ हो गया. अब शिव जी तो रहे नहीं, मंदिर में हमने बंद कर दिया है, पहरा भी लगा दिया है. बिना इसकी जांच पड़ताल के ना हम अंदर दर्शन जा सकते हैं, ना वो त्रिशूल और डमरू लेके बाहर आ सकते हैं. तो आपको और हमको शिव बनना होगा. आज की जो प्रदूषण की समस्या है उसको दूर करने के लिए, चाहे बायोटेक्नोलॉजी से करें या चाहे केमिकल इंजीनियरिंग का इस्तेमाल करके करें। जब तक वो पहाड़ डंडे की तरह था, कोई फेस सेपरेशन नहीं हुआ, लेकिन जब कछुआ बन के विष्णु भगवान ने उसको उठा लिया थोड़ा ऊंचा, तो फेस सेपरेशन शुरू हुआ और काम के पदार्थ निकले। आपका जो ग्राइंडर या मिक्सर है घर में जिसमें चटनी बनती है या लस्सी बनती है, वो भी इसी सिद्धांत पर आधारित है। जब विष्णु भगवान ने समुद्री कछुआ का रूप ले लिया, पहाड़ को उन्होंने थोड़ा ऊंचा उठा दिया, तब टर्बुलेंस होना शुरू हुआ समुद्र के जल में और फेस सेपरेशन होना शुरू हुआ। उसके पहले कोई फेस सेपरेशन नहीं हो रहा था। तो चाहे मिक्सचर बनाना हो, मिक्स करना हो, इमल्सन बनाना हो, तब भी मिक्सिंग करनी पड़ेगी, और सेपरेट करना है तब भी मिक्सिंग करनी पड़ेगी। काम अलग अलग है, लेकिन रिएक्टर की डिज़ाइन ठीक होनी चाहिए। और इसीलिए कछुआ, चूँकि समुद्री कछुआ बहुत बड़ा होता है, गोलाकार होता है, 2 पैर इधर 2 पैर इधर, एक पूंछ और एक मुंह, तो वो 6 ब्लेडेड टरबाइन की तरह काम करता है। और आपके जो घरेलू मिक्सर है उसमें भी थोड़ा ब्लेड ऊपर रहते हैं, नीचे एकदम पेंदी से चिपके नहीं रहते हैं। तो ये संदेश मिलता है कोऑपरेटिव एक्शन, प्रॉपर डिज़ाइन और प्रदूषण की समस्या के लिए शिव जी के शरण में जाकर हमको आपको सबको शिव बन के प्रदूषण से युद्ध करना होगा, तभी हम सृष्टि को बचा सकते हैं या पृथ्वी को बचा सकते हैं और सस्टेनेबल डेवलपमेंट गोल के हिसाब से कार्य कर सकते हैं, क्लाइमेट चेंज को रोक सकते हैं। धन्यवाद। जय हिंद।
धन्यवाद सर। एनी क्वेश्चन?
प्रश्न जरूरी होता है भाई, शंका समाधान। आ जाओ सामने, आ जाओ। हाँ आइए, आप हैं? हाँ आइए। हाँ जी, हाँ
या आ जाओ आ जाओ आ जाओ, ले यार भाई।
Good afternoon, sir. My name is Shresh Singh Tumar and I am the student of BTech Mechanical. So, sir, as you have showed one page of RO purification, okay? So, I have a question that actually I also have a RO purifier in my home, okay? And it was one disturbed sometimes, and when our salesman came to make it to improve it, I have asked one question to him that Sir, on the box on which the RO water get purifies has charcoal and other substances like mud, charcoal, etc. So I have a question to you that is foreign world and other countries actually first I want to say that we have find this on our past generations, okay? We have find this that we can purify our water through charcoal very fast. We have find it very fast, okay?
question
okay sir. So I have only one question, that do you think that the foreign companies are using our science so to make it improve their industry? Because sir, we have find very fast that how can we purify water, and now the foreign industries are doing same here, okay? So I have a question, that is foreign industry are doing the same, that they are copying our knowledge?
No, they are not copying our knowledge, because membrane technology was not known at that time in the sense they are using at the moment.
Okay.
But charcoal and filtration through sedimentation, this is already being used.
Yeah.
Adivasis in the Chhattisgarh area, Bastar area, they clarify their water. निर्मली का एक पौधा होता है जिसको डाल के वो पानी को साफ कर लेते हैं,
yes, sir.
पीते हैं। तो ऐसा नहीं है कि रिवर्स ऑस्मोसिस सिस्टम जो मैंने दिखाया आपको, वो यहाँ विदेशी वाले बेचते हैं, तो मार्केटिंग गिमिक है। सब पानी जरूरत नहीं है उसको, उससे मड नहीं साफ हो सकता जी। क्लीन वाटर में जो कुछ टॉक्सिक मेटल्स हैं, कुछ बैक्टीरिया हैं, उसके लिए यूवी सिस्टम लगाना पड़ेगा या कुछ ओजोन सिस्टम लगाना पड़ेगा। मेम्ब्रेन प्रोसेस बैक्टीरिया को नहीं सेपरेट कर पाएगा, वो छोटे छोटे होते हैं, पैथोजेंस को नहीं सेपरेट कर पाएगा।
Yes.
लेकिन बहुत से एक्वा गार्ड का जो सिस्टम है उसमें मेम्ब्रेन भी है, उसके बाद उसमें फिल्टर भी है,
Yeah.
तो यूवी लैम्प भी है।
Okay.
तो अलग अलग इंडस्ट्री के अलग अलग गजेट्स हैं।
Yeah.
उसमें एक टेक्नोलॉजी से नहीं होता, 2-3 टेक्नोलॉजी मिला के उसका
Okay.
इस्तेमाल करते हैं।
Okay, thank you so much, sir, for clearing my doubt. Have a nice day. Thank you.
Thank you.
Thank you, sir.
Any question or?
Good.
हाँ नहीं,
समय तो कम है सर।
Actually, sir, the overall purpose of this conference lies in this lecture. Sir has summarized almost all kinds of processes that comes under the domain of biotechnology. All right. So all kind of engineering processes. However, my suggestion is that they become more important if we do them in a different manner. Recently, we started these experiments from Hyderabad. I was the director of Technology Enabling Center, one of the 12 center in India, and there we are providing the opportunity to the local industries. Suppose we are holding the conference in Satna. So we give this notification that the local industries of Madhya Pradesh, maybe MSME or the medium scale industries, we have lot of cement industries here. They can come and provide some problems that they are facing, so that our students are getting the input of how to solve the problem. And one example, sir, I give you, we held this conference in Punjab. So Chima Boiler was a company, they came to us that we are having, कुछ उनके पास वेस्ट था, वो लोग शराब बनाते थे और उसका जो वेस्ट बच जाता था इनपुट का, उस वेस्ट का उपयोग वो करना चाह रहे थे। एंड सर डिटेल में नहीं जाऊंगा, बट वी प्रोवाइडेड द सॉल्यूशन. नाउ दे आर प्रोड्यूसिंग द हाइड्रोजन फ्रॉम दैट प्लांट and at a scale 10,000 metric ton hydrogen every year using the local technology produced by our chemical engineering students. So this is the suggestion that we can do something like that.
I did not talk about my research, but there are examples where little biotechnology is there, chemical engineering is there more. From rice husk you can separate silica, you can get activated carbon which can be used for filtering water which is coming out from the membrane system to remove those toxic metals and which cannot be removed through the membrane. The student has set up a industry in Ahmedabad, Gujarat. He is taking rice husk, converting it into silica and microfine silica, which is being used as a filler in the tire and tubes of the trucks and motorcycles, etc. Carbon he is selling to industry as an absorbent. So such examples are there where either only mechanical chemical is there or mixed with biotechnology knowledge is required. Thank you.
धन्यवाद दीजिए। आइए सर।
Thank you, sir.
Thank you, sir, for the incredible insight and thoughtful provoking presentation in sustainable development goals related with Samudra Manthan. Now I request our respected session chair, Professor C.K. Mishra, sir, kindly present the memento as a token of our gratitude and appreciation. Sir, please.
मैम अभी चलेगा कि ब्रेक? नहीं बचा एक नहीं।
Only one lecture is remaining before the lunch. After this, we have a lunch. I would like to invite Professor
Prabhakar.
I would like to invite Professor Prabhakar Singh sir. He is a professor of physics at the Indian Institute of Technology, BHU, Varanasi, and former head of the Department of Physics. He obtained his PhD from the University of Germany and has published 175 plus international research papers and authored several book chapters and monograph and supervised 70 plus PhDs and several master's students. Sir, please start your presentation.
So, thank you very much for kind introduction, and actually I am told to finish my talk in 15-20 minutes because of course I could see that the students who are sitting here for a long time and they are of course hungry like me. So, and delegates also. So, thank you so much, and I am really thankful to IAPS and especially to Professor S.N. Upadhyay sir, who is my mentor in fact, and when I was appointed as assistant as a reader at that time in BHU, IT BHU, so sir was the director, so I'm really thankful to him for opting me and bringing me up to this stage, and I'm also thankful to the organizers, especially Dr. Shailendra Yadav ji, who invited me to give a talk on in this conference. So thank you very much. So the talk, actually I was told to give a talk on the research output. So this is my recent research output which I would like to present here, and that is the Syria carbonate heterostructure reinforced polybenzimidazole, that is PBI basically, composite membrane for high temperature proton exchange membrane fuel cells. So before I go, this is my laboratory basically, that is known as Green Energy Physics and Solid State Ionics Lab, where we work on an ion exchange membrane. It is, I always take opportunity to speak about my group so that students can inspire and I can have some collaborations from colleagues who are attending this, the conferences. So we are working on the ion exchange membrane water electrolyzers. With of course we are designing different types of polymer electrolytes. We also work on SOFC and proton exchange membrane fuel cells. Some of the students are working on the solar cells. We have also started recently working on the redox flow battery, basically on the vanadium redox flow battery. And दिखाइए वो छूट गया है देखिए. And also some work on is going on the supercapacitors. So with this, again chalk and board was sometimes better than the these PPT models. So we are advanced but dependent on something, and if you are dependent on something, that is really horrible sometimes. So okay, so I can go ahead with this. क्या हुआ? And how do we achieve this? We synthesize the samples. How do we achieve this task? Basically, this is we do synthesis, processing. We study microstructure, applications, and the structural design. So these are the things which we are doing. And we also started recently the theoretical modeling and simulations. We do DFT and also where we calculate the density of states and on the 2D materials, and we also do DRT, that is the distribution of relaxation times. Basically we model our electrical conductivity through this using the DRT. So with this, this is my group actually, research scholars, PhD students only. These 4 are working on the fuel cells, the Akash and Dipti flow battery, these 3 students on solar cells, and these 5 students on anion exchange membrane fuel cells. And I am going to present the work done by Gargi. Nowadays there is no need to say about the global motivation, of course, why should we shift to the kind of energy which is green in nature, and that is the fuel cell basically, and that depends on the energy consumption, energy resources. And nowadays the clear example we can see nowadays because of the Gulf crisis, the war. Of course, we can see that in India, LPG gases, there is a crisis, whether it is shown or not, but of course there is a crisis. Mostly the carbon dioxide which is emitted, and this is the reason why we want to switch from the fossil fuels to the clean and green energy. So now fuel cell technology is one of the ways where we can understand the green technology, and this is the simple example which I used to show to the students what is fuel cells. And you see that 200 years ago, more than 200 years ago, the electrolysis of water is known. When you take some, let us say, acidic liquid and you connect some test tube, this simple experiment you can do, and take some wire, let us say platinum wire or anything, and then you connect with the battery. If you analyze, you will find that at the top hydrogen and oxygen gas is there. Most of the physics innovations have come when we think in a opposite direction. Is it possible, for example, Faraday's law, electricity and magnetism, an opposite direction, dual nature of wave and the light, and the particle, of course. So you see that what is happening when you do the reverse operation. You put hydrogen and oxygen at the top, try to arrange to put, of course, and then try to connect with the ammeter. You will certainly see some current in this. So this is simply a kind of the reverse effect of this, where you use hydrogen and oxygen, and the output is H2O, and this is simply a fuel cell. This is the functioning of a fuel cell. Simply here you are connecting battery, and here you are getting a kind of energy from chemical energy into the electrical energy. But of course in this condition the current would be very low. Why? Because the area of the electrodes are very low, very small, and they are separated away. So we can make an arrangement where we have more area and they are less separated. And then when you do it, you put hydrogen as a fuel and oxygen as a fuel, you will be getting a kind of current in this. So what modification we can make if it is very simple? If it is so simple, why should we be worried about that? So you see that of course we need to make a continuous flow of the fuels as well as the oxygen ion or the hydrogen ion which is flowing. This is a simple example of a kind of polymer electrolyte membrane fuel cell or hydrogen fuel cell where hydrogen ions is moving. So these are the chemical reaction which is taking place, and these electrons are flowing, and when they are coming to this one, oxygen where we are supplying oxygen, this is connecting with the electrons, and then hydrogen is coming from this side and they are making simple byproduct as a water. This is an example where the anode and cathode reactions are taking place, and in our lab we are trying to optimize this part which is the electrolyte, and this is what we do. And the electrolytes should have basically the high proton conductivity, low electronic conductivity, low fuel and oxidant, and these are important. Basically we can speak on hours and hours just to explain these 6-7 points, but of course the time is limited and I am in between lunch and you, so I just skip this point. And in a polymer electrolyte fuel cells, Nephion is the trademark, and it is being used nowadays, and it has captured about more than 90% of market, and this is the American product. We are completely dependent on this, but Of course, there are options where nowadays people are working on the hydrocarbon membranes, that is peak, and the high temperature membrane, that is the PBI membrane. And we started working on the PBI membrane, and Nephron has a problem that it cannot work beyond 100 degrees Celsius because it needs to work in a hydrated condition. And when you go beyond 100, it is not hydrated basically. So this is, we are working, why PBI? Because of course it has a high the phosphoric acid uptake. Why phosphoric acid? Because you need to have a transport of proton, proton means hydrogen ion, through that membrane, and therefore you need to have phosphoric acid uptake. Of course, this mechanical and chemical degradation, it has good cross-linking binding, and this is the some properties which we focused on, and then we started working on this. Of course, the electrolyte we are working, then they have different degradation when we work on the voltage and current density, and it has a losses, different losses associated, and each losses has a different physical phenomena, physical origin, which we can go through, but of course I will not. So this is the kinetic losses, ohmic losses, and mass transport losses, and they are here given here. And we choose basically the ceria carbonate heterostructure. We took ceria. Ceria is a very well known of oxygen ion conductor, and which is used in a solid oxide fuel cells, but it is working at high temperature, and there is a degradation of the ceria which is not desired basically. Now if you want to make it below lower temperature, we added actually the carbonate shell, carbonates basically, the lithium carbonate, sodium carbonate in this, and then potassium carbonate of course, and then we make a kind of heterostructure. So at you go beyond, let us say 400 degrees Celsius, these carbonates are melted, and then they become a part of source of the ion conductors, and the ion conductors are basically oxygen, hydrogen, as well as carbonate ions, and they give a good path for the hydrogen ion conduction. And this is what we do, and we did ceria carbonate heterostructure in PBI we added, so that we can have a oxygen ion conduction and the carbonate ion conduction, as well as the hydrogen ion. You can see here the hydrogen, oxygen, and this. So these ions are basically, when they are able to move through the electrolytes, they will certainly be enhance the ionic conductivity, and certainly the performance of the fuel cell. This is what we prepare, the ceria carbonate heterostructure synthesis, a simple kind of let us say solid oxide route, and then we just crushed them and then ball milled them, and then just heated them. And this is basically the eutectic temperature, eutectic composition which we obtained from this composition 52 to 48. Now over? Khatam ho gaya? Rukiye bhai. And these are some results which we verified through the XRD, through the peaks from just try to see the peaks from the carbonates. Here we don't see any carbonate peaks, only the ceria, pure ceria, which cause CLNC, that is the L stands for the lithium and N stands for the sodium, and they are dissolved basically, they are consumed in the ceria oxide, and therefore to see these peaks whether they are there, we just see the FTIR and where we found the peaks of those two, and this is the energy, the band gap we calculated through the UV visual measurement. And this is the conductivity which we measured, and we found the conductivity has a very high increase of the conductivity, about 3-4 order of magnitude of increase of the conductivity when we added this lithium and sodium carbonate in this. You can see this, and this is we calculated at, and it is of course observed at above 300 degrees Celsius. These are some characterizations which the elemental characterization, and then we synthesize the membrane with this method, and then the membrane was incorporated with the CLNC, that is the ceria incorporated with the lithium and the potassium, and lithium and sodium, and we measured its property with the this one, and here we can see the PBI membrane. It has some crystalline part also which is not desired, but it cannot be avoided basically. And then we put the phosphoric acid uptakes, which is lowered in this case, which is desired lower, because if you have higher uptake, it has a chances of leakage also. So this is what we did, and this is the TZA curve, and then this is basically the, again, just to see whether carbonate has entered inside. This is the cross-sectional, and we could see that it is there. And this is the peaks, this is the flags which we can see the carbonates here. And this is the real measurement we did in a fuel cell operation test. And then this is the basically the whole assembly which is shown here. This is the whole assembly, and this is the schematic diagram. And then we measured the conductivity and the performance of the fuel cells, and we found that the result for the you can see that C graph is the PA-doped PBI membrane. So with the membrane, we have found that the open circuit voltage is increased in this case, you can see, and then also the peak power density is also increased. So in that way we could show, and this actually this paper is published, I did not mention, and also we have applied for the patent for this, and this is why we did not show the paper. And this is the conclusion that shows that our results are more suitable for a proton conductor membrane, and I think this is all because of the shortage of time, and thank you very much for you. And this project was, this work was supported by DRDO, and of course I can understand this.
Thank you.
So this is supported by the DRDO, and of one DST project which is through the global initiative between India and Taiwan. So this is the project of those two, and thank you very much.
Thank you, Professor Singh. बहुत अच्छा आपका लेक्चर था.
Thank you, sir, but it was very short, and I requested to the physics department and the dean, I can come to the talk to the students later on in any time. Thank you very much.
Thank you, sir. We are deeply grateful for your wonderful presentation. To express our heartfelt appreciation, I invite our session chair, Professor Mishra, to kindly present the memento of our speakers. Thank you, sir. I extend my sincerely gratitude to our respected chairperson, Professor C.K. Mishra, sir, for gracefully proceeding over this session and for sharing his valuable insights and gratitude. I would like also thanks to our esteemed keynote speakers for their enlightening and thought-provoking presentation. And I would like to give thanks to the student who is listening very peacefully and sitting here very disciplined. Now, for conclusion of this program, I would like to call Dr. Sudha Agrawal, Head of the Department of Mathematics, Faculty of Basic Science, kindly present the vote of thanks here. After the vote of thanks, we have a lunch in the C block parking. First, our delegates will go for the lunch. After 20 or 30 minutes, the student will go for the lunch and enjoy the lunch. Thank you.
Good afternoon to respected chairperson, honorable chief guest, esteemed speakers, eminent delegates and dear participants. As we come to end of the session of this conference, it is the great privilege to me for stand before you to provide the vote of thanks. This is the first session of this evening conference, has been truly insightful and intellectually enriching, providing us with the valuable ideas and perspectives. I feel provide to express gratitude towards our chief guest, Professor R.K. Sharma sir, for his continuous presence in this complete session and valuable ideas to make successful this session. Thank you, sir. And I express my gratitude for our special guest, Professor M.L. Sharma sir from Nepal, to providing this valuable time for this conference. So thank you, sir. I would like to acknowledge with gratitude the chairperson of this session, Professor C.K. Sharma sir from RML Awadh University, Faizabad, for skillfully chairing this session and guiding the discussions. My special thanks go to Dr. Upadhyay sir, S.N. Upadhyay sir, for his valuable presentation on biotechnology, and also for I grateful for this academic contribution to this session. Have I feel there is no sufficient words to express thanks for his presence and sharing his more valuable experience. Also, I would like to, my appreciation goes to Professor Prabhakar Singh sir, Department of Physics from IIT BHU, Varanasi, for his presence and academic contribution to this conference. And also on the behalf of our all team, I congratulate once again to achieving this fellowship award today from IPS Academy. I would like to express my gratitude to Dr. Engineer Anand Kumar Soni, our Pro-Chancellor of AKS University and Vice-Chancellor of AKS University, to continuous encouragement and support for organizing such meaningful academic sessions. Special thanks to Dr. Shailendra Yadav sir, convener of this conference, to whose dedication and efforts made this event possible. Also, I want to appreciate their session coordinators, Dr. Dinesh Kumar Mishra and Mr. Manish Agrawal, for their excellent coordination and smooth conduction of the program. My heartfelt thanks to our anchors, Mr. Radha Krishna Shukla and Dr. Ekta Srivastava, for conducting the program so gracefully. I also would like to acknowledge the efforts of the poster presentation coordinator, Dr. C.P. Singh and Mr. Manoj Kumar Sharma, for successfully organizing the poster sessions. Finally, as I extend my sincere thanks to IT support team, volunteers, participants, and organizing committee members, whose cooperation and hard work contributed to the success of this session. Thank you to all of you. Once again, thank you.
Now we have a short break for the lunch. I request all the dignitaries, please have a lunch in the seat lock parking, and I request all of them, please reassemble here in the same place at 2:45 p.m. for the technical session 2. Thank you everyone.
and virus dynamics. I proposed one model that is popularly known as Upadhyay-Rai model in 1997 to handle many of the ecological challenges like why chaos is rarely observed in natural population, how do the ecosystems respond to the external perturbation, and the species extinction problem. All these things can be addressed with the help of those models. And as you know, today there are many ecological challenges like air pollution, deforestation, soil degradation, species extinction, overpopulation. All these things comes under the ecological challenges. So how the mathematical model can address this issue? We will discuss that one. And on the other side, if you go for the neurological disorder means it is a medical condition which has major impact on the central and peripheral nervous system. Central nervous system involves the neurons, brains, spinal cord, and peripheral systems involves all the nerves. So this all impacted by the neurological disorder, and it has smallest to the life-threatening effect like Alzheimer, AD, PD, all these, migraine, all these things are related, and all this problem can be addressed with the help of the mathematical model. So first I will address what is mathematical model, then we go for the ecological challenges, how the pattern formation, what are the mechanism of pattern formation, then go for neurological disorder. So I start with the three questions. What is modeling? Why we do the modeling and how we do the modeling? If you answer this first question, what is modeling? Modeling is the discipline which helps us in shaping the real life problem into mathematical term and solving them. We can say like this, you catch hold the real life problem with your teeth, dive into the mathematical ocean, swim there for some time and come out to the surface with the solution of the real life problem. This whole process is called mathematical modeling. If you are not satisfied with this, you again dive into the mathematical ocean. You either change the model or change the analysis and go for the generating the new model till you get the perfect model. So these are the process. Then why we go for mathematical modeling? Where direct experimental evidence is not obtained, then there we go for the modeling things. For example, if you have the space program, we cannot plan the trajectory, fight the simulation, there we go for the mathematical modeling. If I want how many liters of blood we have a healthy man, so we cannot take all the blood and measure that. So mathematical model will help you there. And what are the, how to do the modeling? So there are the 7 steps which follow and gives you the best model, like identify the problem, figure out the data needs to be collected, decide the number of variables, analytical method or numerical method, you choose the validity of the model and implement a model. So these are the 7 steps will give you the complete modeling scenario. And all these things are nicely addressed in my book, Introduction to Mathematical Modeling and Chaotic Dynamics, appears in 2013 in CRC Press. Now I give you the example. So how we judge the which one is the best model? So if we say the model appears on your t-shirt or back of your t-shirt, then that will be the popular model, like E equal to mc square, and it should be understandable by the common man. What is that common things? Common man don't know about the energy. He know only about the 100-watt bulb. So how much energy is generated so that the common man can understand that this is useful for me or not, this formula. So if you take E equal to mc square, if you take 1 kg of any material, multiply with 3 into 10 to the power 8 meter per second square, it will give you 9 into 10 to the power 16 joule. 100 watt means 100 joule per second, and if you convert this one in times, that energy is used up to 3 into 10 to the power 14 second. If you convert in today, in 1 year, we have this much second, and if you divide this, so this much year, the bulb, 100-watt bulb can give the light. So this is the power of the mathematical model. The common people can understand this. So I addressed many ecological challenges. like why chaos is rarely observed in natural population, chaos and ecological reality, how do ecosystems respond to external perturbation, species extinction problem, genetic versus ecological factor. All these ecological challenges have been addressed with the help of the model. And in 2001, there is a special issue appears, chaos in ecology. There we wrote a nice paper that is crisis limited chaotic dynamics in ecological system. So early 2000, there was a dispute in two type of ecologists. One is called theoretical ecologist, other is called field ecologist. Field ecologists say that there is no chaos in the field, but theoretical ecologists say that we have very much chaos in that. So we have addressed that issue with the help of the mathematical model. So that is the paper. First paper appears in 1991 by Hastings and Powell model in Ecology Journal, and that is also known as 3 species Rosenwick-MacArthur model. So this model have speciality. We have 3 species. One is prey, other is specialist predator, and top predator is also the specialist predator. So all the 3 are specialist predator. And if you go for the dynamics, it addresses the paradox of enrichment by Rosenwick-MacArthur model. If you take the 2 control parameter R and K, if you plot K on x-axis, R on this, you will get different dynamics. This one is the stationary dynamics, red one is the chaotic dynamics, this is cyclic, this is high cyclic, and this one is the super predator evidence. If you take, this is the one cycle, this is the one cycle, chaos, this thing. So this will address the about this one. If you go for homoclinic attractor, defining the homoclinic attractor with R or K value, for different value of R and K, it gives you the screw type homoclinic attractor. This will be a funnel type homoclinic attractor. This is multi funnel homoclinic. So why this appears? Due to fast slow dynamics of the model. So this was addressed in European Journal of Physics in 2018. And this is the maximum Lyapunov exponent, which is also one of the signature for measuring the chaos in dynamical system theory. So this is the plot for maximum Lyapunov exponent. The blue color gives you the periodic orbit, and yellow and red color will give you the chaotic dynamics. And this point A, B, C, D all are corresponding to different type of bursting phenomena. Bursting appears due to the fast slow motion, and this point is called non-chaotic homoclinic, regular bursting, chaotic dynamics, regular near homoclinic, and this C is the multi-funnel director, and C is the stable limit cycle dynamics. So this is about this model. Now this is the model we designed first time in 1997 to address that issue, why chaos is not rarely observed in natural population. So we have taken 3 populations. X is the prey, Y is the specialist predator, but Z is the generalist predator. If you go for the real system, it represents rodent, snake and mongoose, and A is the intrinsic growth rate, B is the intra-specific competition, W is the consumption rate of X by Y, D is called half saturation constant, A2 is the death rate of Y population, and Y1, W1 and D1 is corresponding to W and D. This is by mass balance law. W2 and D2 are same as this one, and CZ square. If you drop the last term, this will give you the generalist predator is higher life form, and this is proportional to Z for male and Z for female. That's why CZ square will come, and this will give you the blow up phenomena. That is one of the major phenomena in dynamical system. So how to capture the blow up, I will show you later on. So this is about the model. And about this model, when I communicated this paper in IJBC, International Journal of Bifurcation and Chaos, our results were totally against the result of Professor Ismail. So editor shows that your result is contradicting the view of Ismail, so you address this issue. Then I corrected the model, taken 4 different situations and tested the model, tested the results. In all the 4 models coming the same thing. Then I sent this result to Professor Ismail. He is a big guy in differential equation theory. He said these things and he recommended, then that paper got published and accepted and published in that journal. So this is the paper he wrote. This result is against the result of this one. So about this model, this is the attractor, different type of attractor. This is the 6th equilibrium point we are getting. This is the Lyapunov dimension. It is coming out to be 2.051. This is the fractal dimension showing that it is the chaotic dynamics, and this is the one of the Lyapunov exponent is positive. So it again says that it is the chaotic dynamics. So this is the first return map. This is the different phase diagram, Poincare map. All these things we have plotted. And Professor Leterrier from France, he did the topological characterization of this one. Here they used the knot theory for finding this one. Here we had taken the 2 even and 1 odd strip for the defining the attractor, the characterization of that attractor. So this is the blow up phenomena only due to the third equation. This is the blow up in large time scale for t equal to 24. This is for temporal model, and this is for t equal to 41 for spatial model, if you add the space in that direction. And this satisfies C is greater than W3 D3 by this, then this is valid. Otherwise, no blow up will appear. This is the time of blow up we have also calculated for the OD model. And again, I revisited the paradox of generalist predator, which says that theory says that generalist predator are poor agent of biological control, primarily due to mutual interference, but field affiliates show that it is actually quite effective in regulating the pest density. So here what we have done, here we have added the interference by taking the Beddington-D'English type functional response, and other part is same, added the diffusion term. So this is the paper I wrote in 2018 in the CNS, they have published this result. So this is the just showing the Turing instability in this model. Now this is the just the bifurcation diagram. Lyapunov exponent is positive, confirming that chaos exists, and here we try to see the effect of delay on the chaotic dynamics. The general hypothesis is delay stabilize the system. So here we have shown that without delay, the chaotic attractor, once we introduce the delay tau equal to 1.9, it makes the system stable. So this result has been confirmed, and this, if you change the delay, length of delay t equal to 0.09, both will be the chaos. No delay, again chaotic, with delay it is also the same structure we get it. If you change the position of delay here, you will get the no delay case chaotic attractor, with delay of length 10.1, it gives you the limit cycle. So there is no blow up in that case if you introduce delay in this. So this is also one of the important result. So this is the result related with this one. Here this is the interesting paradox where field concern the release of generalist of predator, control the pest may or may not be invasive. So this damage caused the excessive of $120 billion in a year in the US alone. So this result might be explain the population explosion of the species cane toad. This species is introduced in Australia for controlling the biological control species. So this is the real application of that result. Now recently you have heard that one of our biologists, he got expired, and I compared his work with the Professor J.H. Lawton. He is the conservation biologist in UK, and both works are same. Now I want to introduce the diffusion here, pattern here. So he says that, Lawton has says that, I believe passionately that pattern detection is the first step in ecological work prior to the development of experimental and manipulative work. So pattern is important to understand the mechanism of the dynamics. And Madhav Gadgil had recently in 2024 got the United Nations Award, Champion of the Earth. He also got many awards, Japan Award for Observational, all these things. So what is the pattern? If you go for actual definition of pattern, it is the regular structure in space and time, which repeating structure often called pattern, which describe the changes in space and time called spatiotemporal pattern. Two main patterns are well-known pattern, one given by Robert MacArthur in the Introduction to Geographical Ecology in 1972. He says that to do science is to search for repeated pattern. The best person to do this in ecology is the naturalist who loves to note the changes in bird life, to mountain, changes in plant life, to mainland to island, changes in butterfly from temperate to tropical. Other is the species area relation given by Rosenwick MacArthur in his book. So these two patterns are very well known pattern in ecology. If you go for real pattern, so this is the pattern in aquatic system, spatial process where some kind of heterogeneity is observed. Small fishes covers the big fishes, and if you go for aquatic system, these are the different pattern: spot pattern, strip pattern, and this is the simulation version of that model. Here we got this type of pattern in simulation. If you go for terrestrial ecosystem, you will get this type of pattern. And based on this, we can design a theorem because we are a mathematician. So everywhere we look for the theorem. A spotted animal can have a striped tail, but the striped animal cannot have the spotted tail. The proof is based on the stability theory. So we can prove how it has happened. Another theorem is there is no animal on this world, in this earth, with a striped body and spotted tail, but there is an animal with a spotted body and striped tail. Proof is also based on the Turing-Murray theory. This is the reaction diffusion mechanism, defines all these things. And in 2012, I visited to Cambridge University. There we met with the Murray, Professor Murray and his wife, and this is the picture for this. And in pattern formation, this is the guy, A.M. Turing, who had done a lot of work. He has written only 6 papers in his life, and he is the computer scientist. His one paper is sold in auction in $19,500, and all 6 papers is sold in $465,000. 6 papers. So he is a great mind of Europe during that period. He worked on this population and this. Now we come to chemical system. If you take 3 chemical reactant, substrate, activator and product, and related with this one, this equation, it gives you the Gary-Scott equation. The model is this, and this is the on the torus surface. This is the pattern is formatting, and this is just like how the disease is spread on your screen. So this is this way the pattern is formulated and goes by this chemical reaction. If you go for another pattern, dance pattern on the prole, real pattern, everyone knows about the Ed Sheeran, who wrote a very nice song, Shape of You. And if you see this is the pattern. You just focus on the foot step. Just give the sound. Just looking for the pattern. Just focus on the foot step.
I want your love was handmade for somebody like me. Come on now, follow my lead. I may be crazy, don't mind me. Say, boy, let's not talk too much. Grab on my waist and put that body on me. Come on now, follow my lead. Come on now, follow my lead.
Just foot step, if you follow the foot step, and if you plot this, you will get this type of pattern. 1 go to 2, 2 go to 3, 3, 4, 4, 5, 6, 7, 8, 9, 10, all this thing, this goes this way. So full one salsa dance. This is the very famous in New York. So this is the full pattern, geographical graphic of this. And if you calculate the dimension, it will give you 1.28 dimension, the fractal dimension for this. So this is the chaotic dance, chaotic pattern. And if you go for, in 2010, I was working on the spatio-temporal model of whole population in Europe and America. There we got a new type of pattern. We named it CTRS. CTRS means chaotic in time and regular in space. So this is the new type of dynamics we observe in this. And if you go for simulation 1, this is the temporal spatial pattern, temporal pattern, this is spatio-temporal pattern. Behind this, diffusion is the main things working behind this. So if you go for modeling the diffusion, there are 3 hypotheses. One is called fixed law, that is for constant type of diffusion. Other is Viridi and Chapman law, and this is the steady state for this law. And if you take the diffusion coefficient constant, all the 3 are identical. And Turing pattern published in early 90s, and after 40 years, people got the experimental verification of this. one of the Professor Kondo in Japan, recently I met with him, he gave the first experimental verification of the Turing pattern, and he published the paper in Science. And later we addressed one of the open question, propagation of Turing pattern, where the bifurcation theory fails and this crosses the imaginary axis. So if you take the spatial version of the Upadhyay model, you will get many things. It is a semi-linear parabolic system. It has finite time blow up in LP norm. If this is greater than this, it gives you the Turing instability, Turing and non-Turing, constructed the low dimension chaotic attractor. So this is the constructed limit cycle in spatial model, strange chaotic attractor, co-dimensional relation, and for t equal to 24 it gives the strange chaotic attractor with dimension 2.4, and its largest Lyapunov exponent is 0.6. So this is the chaotic things. This is the region of chaotic, different. Non-Turing, brown is the non-Turing space, blue is the Turing space, and green is the planar stability in different parameter space, A1, A2, B1, B2, like this. And this is called wave of chaos phenomena. Ahead, this is the mechanism working in this way. So this is the wave of chaos. So wave of chaos first time observed in 2001 by Petrovsky, and we observed first time in the 3 species model. He observed in 2 species model and extended it for different system. Like recently 2025 we worked for rabbit lynx dynamics and got this one. So other pattern is like this. For this initial condition, strip pattern, stop pattern, labyrinth pattern, and how to select the pattern. So this is the conjecture. If you take the stationary solution of the Fokker-Planck equation, which has 2 global maxima of different and equal height. If it is different height, it gives you the spot-like pattern. If it is equal height, it will give you the strip-like pattern. Here the energy is associated with this one. So this way. Now recently in 2025, I coined a new word that is called memory chaos. So, and we apply this for control and synchronization of real system. So this is the fractional order system, same Upadhyay model for different value of fractional order, 0.95, 0.97, 0.99. We published this in Journal of Franklin Institute, and this is the controlling memory chaos and synchronization of nonlinear system. So this is the definition of memory chaos, which go newer and newer places but never go beyond the region specified by the vector field. It has 3 degrees of freedom and all are related with this. So this we take master system, here we take slave system. This is the attractor for master system, for slave system for different value of theta. Here we define the synchronization theorem, 2 theorem for synchronization. Full mathematics is there in the paper, and this is the attractor, and this is showing the complete synchronization. And if you go for real one, and if you just see this one, give the sound.
The time is on.
There is sound.
Professor Upadhyay.
This is same Satna. Just see the foot step, how it is synchronized.
I've had enough of this nonsense! You two, out! No, Jake, I've had enough of your bullying.
See the synchronization.
Go!
Just foot step. So these 2 model just show the complete synchronization of the model. And if you go for neural system, in 2015 I was visiting to Cambridge, there we got the idea how to apply this model to this one.
So Upadhyay, the time is up already, you advanced 5 minutes.
Yeah, 2 minutes.
Could you please curtail it fast now?
So this is the just spikes in the neural systems, and based on the resistor character circuit, Here if you see the different type of spike and bursting pattern, and if you, these are the challenges. What are the challenges? Epilepsy, seizure and Parkinson. And if you remember, generally people think that human behavior is unpredictable, but this is not the right things. It is very much predictable, but you have to know how it is predictable. We have to calculate the, here you see, we have to calculate the bursting law and add with the power law at each time, and by calculating this we can monitor the human behavior. If you just compare with blinking with thinking, this is the neuronal communication about the two person, how the idea communicate. This you might remember the one Keralite heroine, that is Priya Prakash Warrior, just famous for the winking phenomena, and Professor APJ Abdul Kalam for thinking. If you compare this is totally related with the neural system and all these things, and it is very much predictable, all these things. And this is the picture of the mind, where it just looks like the galaxy. Galaxy has 100 billion stars, but in mind we have 100 trillions of neurons which is connected with this one. So this is the model we worked on this. We have no time. We have simulated all these things. These are the application, and all these things are given in my book, this one. And recently we worked on the obesity-induced Alzheimer's disease and published in good journal. Alzheimer's work is already going on, calcium hypothesis, and everybody is talking about the sustainable development, other things. In 2020 we started one journal, and title of the journal is Journal of Innovation Science and Sustainable Technology. I am the editor-in-chief of this journal. If you are working in that direction, your article is welcome. You can communicate to us. We are ready to publish. It comes under Make in India creation and known to the government of India. And this is my team working with me in different direction. And thank you.
Thank you, Professor Upadhyay, for a very informative lecture on how the mathematical modeling can help understand the ecological disturbances. But one thing I am unable to comprehend about your mathematical modeling try to help understand the neurological or neurodegenerative diseases.
Yes.
One thing, because as I understand, my understanding is that all the biological events, they are triggered by the interplay of the metabolic pathways, and which involves all the key biological molecules, and of course when they interact by the click chemistry, and of course that's how we understand. But how mathematical modeling would help understand that is, I cannot make it, so
take time to understand.
And the second thing is, I already have published one edit one volume on neurological, in fact neurodegenerative diseases, as editor of this what you call Frontiers Journal in last year. So there is quite interesting one. You might have a look at it.
Sure, sir, I will.
So with these, it's just only comments. I don't want any, because it's a very informative lecture you're given. But I would like to invite the distinguished audience if they have any questions, and especially the students. The students can, they are not looking at.
Yes.
Yeah, Professor Upadhyay, yeah.
Yes, sir.
You to you.
Yeah, it is chaotic phenomena, but it lies to the fluid dynamics area. People are working, those who are fluid dynamics, they are dealing with this one. These are just simple pattern and other things. Reaction diffusion equation I have covered. Yeah, dance. It is the pattern I want to show.
New York dance pattern.
Yeah, dance pattern.
Can you show similar pattern for Bharatnatyam, Kuchipudi,
Yeah, it is possible. It is possible, sir. That's why that Desi dance. It is the Indian dance. Last one I have shown it got the.
That is copied from a cinema.
Yeah.
But classical, Indian classical dance forms.
Yeah.
Kathakali, Kuchipudi, Bharatnatyam.
No, my motive is to show, because if you are to try for the that level, you have to go for these things, checking this thing. It should synchronize. This is the level of energy you should have so that you can compete for the world level. Yeah.
Just a comment, you have a special interest in the movies. So as we see the salsa dance and also the nacho dance, and besides Priya Prakash Varkis, who was a wing girl, she made a sensation. Interesting, science.
For many dance I have calculated the fractal dimension, but due to lack of time I just presented one. Yeah.
All right.
Yeah.
Any questions from the audience, especially the students? Boys and girls, any questions?
असल ये सब बीएससी के लेवल के हैं सर, रिसर्च लेवल पे आए नहीं है, इसलिए इन लोगों को उतना भी एक्सपोजर नहीं होगा.
If none, then we thank you, Professor Upadhyay.
Thank you.
Very, very nice lecture.
Thank you, sir, for such an engaging and interesting presentation, and tell us about the mathematical modeling in a very interesting way. I think now a student cannot think that math is very tough. It's very easy. See, it's used in the salsa and Bharatnatyam dance also. Anyway, we move forward. To express our heartfelt appreciation, I invite our session chair, Professor Gupta, to present the memento to our respected speaker.
Thank you. Thank you. Yeah. Thank you.
Thank you, sir. Now, to move our next speaker, it's my great pleasure to introduce Professor Mukut Mani Tripathi, a distinguished scholar known for his valuable contribution to the field of mathematics. His research expertise include differential geometry, Riemannian geometry, contact geometry, Hermitian geometry, and submanifold theory. Professor Tripathi has made significant contribution to mathematical research, particularly in curvature tensor, geometric structure, and his work has been widely published and recognized by prestigious academic bodies. With over 2200 citation and H index of 26, his research has had a strong impact on mathematical community. I also feel personally privileged to share that Professor Tripathi was my teacher during my MSc at University of Lucknow in 2007, and it is truly an honor to welcome him today. Sir, please.
Thank you. Thank you so much.
A request, Professor Tripathi, before we begin, time, we have to be disciplined in that.
I will be always in time.
Wonderful. I'll expect
Yes.
that. Okay, thank you.
Even if you give me 5 minutes, it's enough.
Okay, okay. That's versatility.
So, thank you everybody present in the hall.
Excuse me, sir. This is the T. Pathi Memorial Lecture.
Yes.
Professor Mukut Mani Tripathi is going to deliver the Professor T. Pathi Memorial Lecture. Thank you.
Professor T. Pathi has a connection from Madhya Pradesh as well. He was chairman of the Department of Mathematics at Jabalpur University, and he was chairman of the Mathematics Department at Allahabad University, and then also Vice Chancellor. He was supposed to solve the Riemann hypothesis, and many people have tried to solve this challenge, and it is still a challenge. It's remaining challenging. और उनके बारे में ज़्यादा क्या कहना है, कॉम्प्लेक्स एनालिसिस में उनका काफ़ी योगदान था, और इन्हीं शब्दों के साथ मैं अपना वक्तव्य शुरू करता हूँ इस दुनिया में हर कोई बिना तनाव के एक सुंदर विश्व में रहना चाहता है. Everybody wants to live without tension in a best world. And how to speak this problem in the terms of geometry? I delivered a talk in Baltimore American Mathematical Society meeting and explored this idea in terms of pure differential geometric modeling. So, everybody means a kind of submanifold, and in the best world, so these are the symmetric spaces or manifolds of highest order of symmetries like real space forms. And without tension means the mean curvature vector field becomes 0. So, even if it is not 0, then we try to limit and we try to minimize this issue. So, unlike the previous talk, this talk is in a different way, because I tried to work on this problem for last 25 years. There were many invariants known so far. Classical invariants like Ricci curvature, scalar curvature came out from the Riemann curvature tensor. It was the birth of the Riemann curvature tensor is due to Bernhard Riemann, due to his very nice lecture in 1854, and his work was published in Nature in 1866. And then after 100 years of 1866, so it was 1966-67, a person from India, Ravindra Sripad Kulkarni, working with Sternberg, he gave the idea of some sort of geometric structure or curvature structure, and but he took the definition in the framework of an inner product space. While I was working, I relaxed those conditions. In any vector space, now I can define a tensor field, and I have coined the name Kulkarni Namju tensor field. And then a lot of differential geometry, what was done in terms of Riemannian curvature tensor field, can be reframed in terms of Kulkarni Namju tensor field. And this work I published in 1925 in Contemporary Mathematics, American Mathematical Society. Here the issue is that how to give the ultimate goal of an invariant for a submanifold. So, in the process, surfing over thousands of papers here and there, working for 25 years, I was able to present my work in a research monograph. This monograph will come this year, will be published by World Scientific London, and it is a sort of handbook of differential geometry of space forms, and it was all done so far. So, why it was needed, why this new invariant was needed? Because I was still struggling with certain geometric abstractions which I was not able to deal with the generalized delta invariant given by Bang-Yan Chen. He is also one of the finest geometer of all the times. So, he wrote his first book on submanifold theory at the age of 23. So, he is a genius, he is a prodigy. So, why I am telling all these things? Because here the young minds are sitting in this hall, and look, my friends, in geometry you will find many geometers who lived more than 100 years. Even my research guide, Professor Kamala Devi Singh, she lives in Lucknow. She is at the age of 96, hale and hearty, and she can walk faster than anyone. Professor R.S. Misra, who is very much well known in the area of differential geometry, he also lived more than 90 years. Professor Manindra Chandra Chaki from West Bengal, he gave the idea of quasi-Einstein structure. It is quite related with GTR theory at the age of 94. Professor Krishna Amur from Karnataka, Dharwad, he lived more than 85 years, and he published many papers in Journal of Differential Geometry, even at being at university level. Why I am telling all these things? In my personal opinion, working in geometry is a good tonic for health. So if one is looking for a good health and a long life, so please work in geometry. So I was struggling with certain ideas. Those were I was not able to do with the generalized delta invariant given by Wang-Yan Chen in 1997. So ultimately we got a breakthrough with the help of several other people. It's a joint work. Ayush Chaubey is present in this hall. He is a young mind from your state, and now at present he is in Chhattisgarh. Yang Jinsu is the expert in the theory of complex two-plane Grassmannians. This idea is not sparkled in Indian minds. I think even at IISc and TIFR this area of research is not being done. Complex two-plane Grassmannians. It's really very difficult area. So we have some results as applications in those things, and this theory what we have created now, with help of this, even I was able to obtain the lower bound for the Laplacian of the warping function of any Watt products of manifold. So without this technique it was not it was not possible to do all these things. So let us quickly proceed further. These are contents, please. This is, yes, you can see the colored figure of Bernhard Riemann. It was created with help of AI. Nowadays it is available. So he gave the most fundamental theory of Riemann curvature tensor. So, and this idea was given in his lecture in 1854 before the all-time great Carl Friedrich Gauss. सो गॉसियन कर्वेचर वो अपने ज़माने का जो थेरी थी उनकी वो वहाँ से काफ़ी सालों आगे थी. ऑफ कोर्स उसके बाद में फेलिक्स कैसरॉती ने भी एक आइडिया दिया जिसको कैसरॉती कर्वेचर के नाम से जाना जाता है. इट वाज गिवन इन 1889 बिफोर हिज डेथ. कैसरॉती कर्वेचर हैज मेनी एप्लीकेशंस इवन इन मैकेनिकल इंजीनियरिंग एज वेल, एंड वी हैव सॉल्व एन ओपन प्रॉब्लम रिलेटेड विद कैसरॉती कर्वेचर रिसेंटली. ये कहाँ से दबाना है भैया? ये दब तो रहा है, आगे जा रहा नहीं. यस, Schlafly 1814 to 1895. In 1871 he gave the idea of when a two-dimensional Riemannian manifold can be immersed in three-dimensional Euclidean space. So with the help of a set of partial differential equations he tried to give his idea, but then it was proved by Janne and Cartan and Burstein in 1932 to 1930s. Yes, Schlafly. यही तो दबाना है. ये इमर्जिबिलिटी का इसी को तो दबा रहे हैं, दब नहीं रहा है. अरे मैं तो बहुत जल्दी आगे जाना है. You have one more? आयुष लाए नहीं हो ये? भैया हमारा इसी टाइम निकल जाएगा. इसको यहीं पर रख देते यार अपना. It's not working. So अल्टीमेटली वर्स्टिन ने ये आइडिया सेटल किया और उन्होंने इसको प्रूव किया. सो नाउअडेज इट इज कॉल्ड जाने कार्ता वर्स्टिन थ्योरम. नेक्स्ट प्लीज. Hassler Whitney, he is also responsible for giving the immersion theory of a differentiable manifold. So differentiable manifold is a kind of generalization of Euclidean space. So an entity, a geometric entity which locally looks like Euclidean space, vaguely speaking, it is called a differentiable manifold. वास्तव में इस ब्रह्मांड का पहला जो भी शोध कार्य था वो गणित ने ही दिया और ज्योमेट्री ने ही दिया. मेरे मत के अनुसार सबसे पहले हमारे पूर्वजों में से किसी एक ने जब भी चेतना का विकास हुआ होगा उगता हुआ सूरज पहली बार देखा. उगता हुआ सूरज, वहां से हमको सर्कल दिखा और उससे निकलती हुई किरणें जो ऊर्जा के स्रोत थी वो हमें स्ट्रेट लाइन के रूप में दिखी. तो अगर हमको सूरज नहीं दिखता तो जिसको लोग पहला आविष्कार कहते हैं पहिया, वो भी गोल नहीं होता. तो ये जो सूरज का आकार था, निकलती हुई किरणें थी, ये सर्कल एंड स्ट्रेट लाइंस व्हिच आर द ओनली कर्व्स ऑफ कांस्टेंट कर्वेचर इन यूक्लिडियन प्लेन. यूक्लिडियन ज्योमेट्री के जो पोस्टुलेट्स हैं ये उनकी रीढ़ की हड्डी थी. इसीलिए सबसे पहले ज्योमेट्री का ही अध्ययन करना चाहिए, ऐसा मेरा मत है. I may be biased, but it is my way of advocating for our subject. तो और ये जो आपका सर्कल है, ये अगर और इसको दूसरी डायमेंशन, एक और हायर डायमेंशन में देखते हैं, ये काम कर जाएगा? नहीं करेगा, वो फाइल की प्रॉब्लम है. हाँ, यस प्लीज. सो हैसलर व्हिटनी, नाउ माइकल ग्रोमोफ. ये आप जल्दी जल्दी आगे बढ़ते हैं. ग्रोमोफ, Mike Gromov, he is also a very well known name in the area of differential geometry. He is still alive and working hard. Gromov and Perelman, these are the two giant pillars in the Russian geometry. And one more, I must take his name, and he is Arnold, Vladimir Arnold. Vladimir Arnold is was a very nice player of cross country race, and he used to visit IISc Bangalore many times. So then S.T. Yao, yes, I have some conversation with S.T. Yao face to face but online, and he has also given many things. NAS result in 1954, a couple of papers in Annals of Mathematics for embedding issues. John F. Nass, he is the only person who got Nobel Prize in economics and Abel Prize in mathematics. And we all as teachers think, at least it's my perception, that I want to make my students as a Nobel and Abel personalities for our country, and so that if they are from mathematics or science, they can get Abel Prize and Nobel Prize. S.S. Chern, yes, so from here, so S.S. Chern in 1968, he gave some immersibility issues, and he gave some obstructions that for the minimal submanifold in a Riemannian manifold. So those obstructions were further studied by Bang-Yan Chen, and then we are working on the same line. Bang-Yan Chen is my hero. So he gave the idea of a delta invariant, now known as delta 2, and then again in 1997 generalized delta invariant. And then this is an inequality, a sharp inequality for an n-dimensional submanifold of an m-dimensional real space form of constant sectional curvature C. Then this delta invariant is always bounded above by this beautiful part on the right hand side, H square is the squared mean curvature, and n is the dimension of the submanifold, C is the constant sectional curvature. And the equality case was true when the shape operator took some specific form. Next slide please. In 1997 he gave the idea of generalized delta invariant, and this inequality C1 was present there, and then in the case of equality this C2 and C3 conditions were necessary to be held. Next please. Here I have given the definition of Kulkarni-Namju product, and here it is theta 1 star theta 2. Theta 1 and theta 2 are any two co-tensor fields or covariant tensor fields, and then their Kulkarni-Namju product, it becomes in fact a 0,4 tensor field like this. And if the theta 1 theta 2 are symmetric, then their Kulkarni-Namju product, it becomes Kulkarni-Namju tensor field. And this is the idea of symmetric product given by 2.1 please. And here is the idea of Kulkarni-Namju tensor field. So we have taken a 0,4 type tensor field, and it satisfies two symmetric identities and one Bianchi identity. So in this case, and we have not taken any inner product on the vector space or on the manifold, and still it works. So it was in his thesis, and I have a copy of his thesis. It is from Harvard. He was not given any lecturership in any University of India because he was not MSc. So he directly entered to Harvard after his bachelor's program, and we feel proud of him nowadays as a living Indian geometric legend. Ravi Kulkarni is still on the top. Yes, previous slide please. Previous slide. Yes. So suppose that T is a Kulkarni-Namju tensor field. So for this we have defined T sectional curvature, T Ricci curvature, and T K scalar curvature. Next slide please. And then in case if this T becomes Riemann curvature tensor field, then all these things reduce to sectional curvature, Ricci curvature, scalar curvature, K Ricci scalar curvature, etc. Here is the idea what we propagated. So we have worked in the framework of Riemann vector bundle. So our theory becomes more applicable in many different situations for the submanifolds in real differential geometry, I mean in the Riemannian manifold, for the different kinds of submanifolds in complex manifolds, and for different kinds of submanifolds in contact manifolds, different classes of contact manifolds, also for submanifolds of quaternionic space forms or for complex two-plane Grassmannians, even for submanifolds affinely given in Euclidean spaces. And also it could be applicable for one more place. Yes, that is the two co-dimensional affine subspaces in real Euclidean spaces. So all these places we could apply this theory very easily. So here this is an n-dimensional Riemannian manifold MG, BGB a Riemann vector bundle over M, zeta is a b-valued symmetric 1-2 tensor field, and then this 2.6, this equation we have coined this diamond GB diamond zeta, and so this T is GB diamond zeta, it becomes algebraic Gauss equation, and in this case T must be a Kulkarni-Namju tensor field. Next slide please. So these are some things we have defined in terms of this zeta and KT, etc. Next. Here we have algebraic Gauss equation 2.7 given by R is R tilde plus G tilde diamond sigma, where sigma is the second fundamental form of the immersion for the submanifold, G tilde is the Riemannian metric over the ambient manifold, R tilde is the Riemann curvature tensor of the ambient manifold. So this simple classical Gauss equation can be written by 2.14, and we don't need any x, y, z, w to write as components. And then these are some more concepts here. Next please, next. Okay, so here is one basic lemma we have taken into account. It was given in 1993 paper in Arc Math Basel by Chen. This lemma is crucial at many places. Here is the definition given by Bang and Chen, but we have a little bit. I mean, we didn't restrict ourselves n to be the dimension of the submanifold. Rather, this n bar is any number. So n1 into nr. Previous slide, please. Previous slide. Yes, this 3.19, and then next slide 3.20. And then related with these definitions, we have some sharp relationship when we go for asymptotic relation, and it has some relations with Mach theta functions and other things in number theory as well. Now come to this main theorem here. Mg is an n-dimensional Riemannian manifold. Bgb is a Riemannian vector bundle over M, and zeta is a b-valued symmetric 1-2 tensor field. T is a Kulkarni-Namju tensor field satisfying algebraic Gauss equation. Pi n bar is an n bar dimensional smooth distribution on M, and then this left hand side is bounded above by this right hand side. This is, and the equality is true if and only if this equation 3.22 is true. And not only this, in other conditions we have this equation 3.23. Please. Please. Yes. So here we need one more result, and this result we could get with the help of a concept given in a paper in 2015. And without this to 3.24, it was almost impossible. I mean, we were wondering here and there how to solve the problem, but ultimately we got this paper, and with the help of this paper we proved that if M is an n-dimensional Riemannian manifold, T is a Kulkarni-Namju tensor field, then for each R tuple, this O n1 into nr TPM given by this expression in 3.25. Suppose that this is the set of all R tuples mutually orthogonal subspecies of TPM, then this set is a compact subset of G n1 into nr TPM. And consequently, the real valued functions on this set given by this attains both supremum and infimum. So this is in fact related. This is in fact needed to prove our result. Next, here we give a definition. M is an n-dimensional Riemannian manifold. Pi n bar is an n bar dimensional smooth distribution on M. T is a Kulkarni-Namju tensor field on M. And for each n1 into nr to given in this set S n bar, we define this delta T pi n bar P n1 into nr given by this right hand side. This is in fact the new invariant we created here. And then this new invariant, in fact, it reduces to delta invariant when n bar is n. And when n1 is 2, and this becomes a delta T2 given by Bolton et al. So it is a paper presented in 2009. Here is the theorem. Mg is an n-dimensional Riemannian manifold, and all those things are as before. Pi n bar is an n bar dimensional smooth distribution. Then this new invariant is always bounded above by this right hand side, and this is a very beautiful expression. And then in the equality case, we have the form 3.22 and 3.23. When n bar is n, then this theorem reduces to modified version of the theorem given by Chen. In the Chen's theory, the condition for equality case, it was corrected in our results. So the paper of Chen was published in Japanese Journal of Mathematics. It is one of the very fine journals. Then here are some obstructions probably. So for the minimality, we have one more nice idea given by Gregory Ramsay. Gregory Ramsay is very less known mathematician in the area of this submanifold theory. Although he published his thesis was awarded in 1985, he published a couple of papers, but his ideas were not very well known. But we have taken those ideas of minimality and then we prove certain more results. Here is one result. Mg is an n-dimensional Riemannian submanifold of an m-dimensional Riemannian manifold. Pi n bar is an n-dimensional smooth distribution on M. Then this it is not exactly new invariant, but a similar kind of thing is bounded above by this expression. And for the equality case, these shape operators must be of this kind, 4.32 and next slide please, 4.33. So it is natural to ask whether a Riemannian submanifold that satisfies equality in 4.31 continues to do so when both the submanifolds and the ambient manifolds are extended via a product with the same Riemannian manifold. In other words, does the equality in the curvature inequality is preserved under product? Just I will take 1 minute. Under product constructions, and this motivates the following result. Sir, we are working on this problem for more than 25 years. So just 1 minute, please. With your kind permission, sir.
Please.
So we gave this definition. So like this. So this is delta pi n bar p and this delta hat pi n bar p. So these are the invariants given in this format. And then we got this beautiful inequality 4.36. The proofs are very lengthy and this paper itself is more than 60 pages. So but here this delta pi n bar p is bounded above by this expression on the right hand side when the submanifold is sitting inside a real space form. And here is the equality case for R tuple if and only if these things are given. And here we have given some examples. Here is the example of, here is the definition of Ramsay of minimality, and in the next result, please, next. In these next results, we have some obstructions for the pi n bar minimality. Next, please. And then here is a particular case. So chains invariant, delta invariant, those that we have recovered as an application. Next, please. Next. And where is the, yes, so here we have applied the theory for some manifolds of complex two-plane Grassmannians, but it's really a very difficult and delicate theory, and it's not, I think we are running out of the time, but we have applied those results and those theories here with the help of certain examples, and these are the slides. One can see the results. Yes, some more slides are here. Yes, please. Yes. And for the hypersurfaces, some people wrote the inequality and they got a very long terminology, long expression. But we discovered that for the hypersurfaces, those things were not necessary, and our results are very interesting. Here one can see the inequality 7.95. Next. And these are the references: Marshall Berger, Alexeevsky, Jürgen Berndt. Next, Arthur Bass, John Bolton, Burstein, Cartan, Bangyan Chen, and Bangyan Chen. Yes, previous slide, please. Yes, Bangyan Chen, a general. This is the paper in 2005, but we have modified this result, and this is a monograph by Bangyan Chen, Pseudo-Riemannian Geometry, 2011 probably. Yes. Next, Sebastian Klein, he worked in complex and quaternionic two-plane Grassmannians, and here is the Kulkarni's paper in Bulletin of American Mathematical Society and also in Annals of Mathematics, Curvature and Metric. And next, these are some papers by me. And I should stop here. Next slide, please. Thank you for your kindness. He is my companion. He is Snowbell, and I live with him. In fact, he does not live with me because he is the owner of the whole house. So he must have access to each and every place. And whenever I am under stress, and he is really, and when I say he is Sundar, and he always
makes a paw.
Yes, so his tail, he always
wags the tail. So.
Yes.
So thank you, Professor Tripathi, for a very, very nice lecture on this thing, what's called geometry, as it evolves in all these theorems and what you try to prove, what you try to disprove. Very interesting. The only thing is that I little comprehend because I'm a molecular biologist. So I sort of try to understand you in the beginning, then I lost track. No, but no problem. One thing I learned from you, that apart from the doctors who advise you, they prescribe you some medicines, how to stay healthy, not fall so ill so easily, and have a longevity. And then also the nutritionists or dietitians who try to make a diet for you that you can live long, but you gave the formula geometry, so I will probably I also want to live beyond 80, so maybe this will work. And the second thing, I want to make a very quick comment. Late Professor Revered, my teacher, was not teacher but is a Vice Chancellor, Professor, what's the name, Trivikrampati, and he was such a versatile figure, and he would come to my home early when I was a lecturer. Every day he's coming, stopping the rickshaw in front of my home and walking up the steps, telling my father to wake me up, and I say, "Arey, VC sahab ghar aa gaye, and Dijayan ji, let's go to coffee housing." Well, I said, "When is a coffee house open at 7, 8 o'clock?" No, we'll find some way, and that is it. So he was such a genius person, and I have never seen such a person with that. He was a good painter, he was a poet, and he was a philatelist. So when I went to Germany, he asked me to bring the philatelic album, and so that was it. I've never seen a person. The other thing, the quality was that if you don't stop him, he can talk for hours. That I saw that glimpse of that in you. If I had not interjected, you probably would be talking like that, like teacher, like student, like that relationship. You have it. So we all thank him for that. Any questions from the distinguished people? Yeah.
Sir.
Models to study the deformation and is it possible for you to analyze the results which they get using your approach? And have you tried that?
At least I know that this Cassarauty curvature is very much well. I mean, they use Cassarauty curvature as compared to Gaussian curvature because Cassarauty curvature is 0 only for planar points, while the Gaussian curvature becomes 0 even for any point on a cylinder. So the Cassarauty curvature is more suited for them. But my students are studying some of those problems, and I think in the future we will come with some new results.
Okay, thank you.
Sir.
Thank you, sir. Your inspiring words and deep insight have added immense value to today's session. Thank you very much, sir. To express our heartfelt appreciation, I invite our session chair, Professor Gupta, kindly present the memento to our distinguished speaker.
Sir. Thank you, sir. Sir. Thank you, sir. Sir. Thank you, sir. Thank you, sir.
80 के आगे चल रहा है हमको भी।
आर.एस. मिश्रा जी सर हमारे पीएचडी का वाइवा उन्होंने लिया था सर, केवल 3.5 घंटा सर। नहीं आर.एस. मिश्रा जी,
वही मिश्रा जी,
वो लखनऊ गए थे।
नहीं है
वो
रीवा में उनकी डेथ हो गई ना।
नहीं वो कानपुर और लखनऊ में थे सर। हाँ
मिश्रा जी,
हाँ
जो वहाँ गए थे रीवा में
नहीं वो लखनऊ गए थे सर। उन्होंने मेरा सर वाइवा लिया था, पीएचडी वाइवा, ओनली 3.5 hours। Thank you, sir.
Now it's my great honor to introduce Professor S.K. Narasimhamurthy, distinguished academician who completed his MSc, MPhil, PhD from Queenpa University with more than 32 years of teaching experience and around 30 years of research experience. He has made remarkable contribution to the field of mathematics. His research area include differential geometry, Finsler geometry, general relativity, cosmology, fluid dynamics, and heat transfer. He had published over 220 research papers in reputed journal, has successfully guided 25 PhD scholars and 2 postdoctoral fellows. He also authored several academic books, served as a reviewer for leading international journal, and is a life member of many prestigious professional societies. We are truly privileged to have such an eminent scholar with us today. Kindly address the gathering on Professor R.S. Mishra Memorial Lecture. Sir, please.
So, as always, I will request you to, curtail the lecture to say 20 minutes. Professor Narasimhamurthy. Great.
Yes, sir.
Shumoga.
Namaskar. I extended my sincere thanks to the organizer and CONIAPS, the Executive Committee of the International Academy of Physical Science, for giving me a second time the memorial talk in this occasion. This is the second time I have given. And I extended my thanks to all the organizers first. Dear student friends, this is a very simple basic talk what I am presenting here in front of you. That is geometrical structure of universe. This is entirely different information I am going to present in front of you. This is a mathematical physics part, mathematical physics, but how we can describe our universe in terms of geometry, or geometry how it will going to define the structure of the universe. So that is what I am concentrating now for last 5 years. I am shifting that Finsler geometry to some applications to cosmology. This is what is that very basic concepts I am going to present in front of you. You can just enjoy the slides, okay. This is very basic concepts. And in nature actually we recognize 4 basic interactions or forces, what we can call it as interactions or forces. One is, I think you know, that is a gravitational force. That is a very basic and fundamental. Everywhere, every minute we have to interact with that force, that is gravitational force. And second one is electromagnetic force. Students, listen me here, it is very interesting. very basic geometry I am going to define. Okay. The second one is and it is very curious, where you are really want to understand this universe, because anyhow we are living in this universe, you know. At least we have to understand how to define this universe basically. Okay, I will tell you that very interesting points, and at the same time at this point I will tell you that our universe is defined by using the two wonderful mathematical words. One is homogeneous and another one is isotropic. That principle is their cosmological principle. You believe it or not, that is a wonderful contribution of the mathematical structure of the universe just by defining two mathematical words, that is homogeneity and isotropic in nature. That is a wonderful thing. Now I am going to connect with those concepts. Second one is electromagnetic interactions, so that is now everyone is doing research, and third one is actually we are facing the lot of problems of strong energy interactions or forces and weak energy interactions and forces. Okay. These are the four fundamental basic forces or interactions every day we have to face in our nature. This is what my plan of my talk, that is I am given the basically introduction. Next one is we have to connect how that geometry, basic geometry is describe universe, and how universe can be explained using very basic geometry is one thing. And second thing is we have to extend that geometry, differential geometry, to the another most important branch of geometry is called Riemannian geometry. How Riemannian geometry is described the universe is the second part. And the third part is my research work, that is Finsler geometry. How this Finsler geometry is described, give the relation to the relativity and cosmology is the next concept. And ultimately we have to think about, you know, what is the future behavior of our universe. What happens for the future? That Big Bang theory already explains everything, how the origin, evolution, inflation of our universe. But what is the future of our universe? How our mathematics or geometry to give the explanation about the future of the geometry. You can just observe that, and last conclusion and publications. This is what that in the introduction. The question that arises now, however, is, look at that. What will the universe do in the future? What will the universe do in the future? And ultimately the most important factor in determining whatever it may be, the gravity is the most important factor to decide the fate of the universe, fate of the universe. That is why ultimate fate of the universe is decided by the gravity once again. So how this gravity can be described in the physics, we can see in the later. And one of the key concept in Einstein's special theory of relativity is that space and time are inextricably linked, space and time. I think you know this is a very good combination. We know very well three-dimensional space, what you call it as a x-axis, y-axis and z-axis, is linked with the time t. So it will become a one-dimensional t, it will become a four-dimensional concept that is called a space-time. Okay, space added with the time, that is a four-dimensional concept. Of course, in four-dimensional, while difficult to visualize in terms of geometry, but in terms of mathematics we know that any number of dimensions we have to define and describe. Okay, n dimensional space, even dimensional space, odd dimensional space, n plus 1 dimensional space, and etc., etc. But mathematically it is very easy to describe that dimensionality. But space time is such a four-dimensional space which gives us, look at that, everywhere direction, length, width, breadth and time also it will gives that. So that is why this coordinate system is actually very useful for understand the universe. It's all over conclusion of the Einstein, that is Einstein equivalence principle, don't bother about that. The effect of gravity and of accelerations are exactly equivalent is the Einstein principle. So that is it is very impossible to distinguish locally between the gravitation as well as the acceleration is the principle of that Einstein meaning. Second leap of the imagination is from the equivalence principle to the curvature of the space time. Again it is a geometry, curvature of the space time. Okay. That is the more important things we have to consider for understanding the structure of the universe. Okay. Then the obvious question is, what does a curved space time? Okay, because we know all of us we know that apple falling story of right Einstein, you know that Newton, apple falling. So apple is immediately falling, but till today the moon is falling, not falling, you know. It is also in the above that earth, till today it is not falling. Why? What is the reason? Okay, so that apple falling story is different from moon falling. How? Because also moon is also a heavy body, it is revolving around the sun, every earth and sun every day, every minute, every second. Why it is not falling down? Okay. So that can be answered with the help of that curved space time. Okay. These are all the simple mathematical models in terms of we have to explain in terms of geometrical concepts. So that is what is that meaning of the curved space time. Space time definition is a 4-dimensional, but its original Einstein definition of the space time is more difficult because it is completely involved the physics as well as the what we can call it as a geometry also, different types of geometry. So that is why our moon is still not falling in front of, right. So that is what is that interesting story. Because of that is what you have seen that is a curved space time. Okay, how to define that curved space time? You can look at that. To answer this question, physicists, mathematicians, geometers proposed 3 types of geometries. So this is we have connected to that geometry. Look at that. These geometries are very well known. One is very much we know that in our high school or primary level, that is we can call it as a Euclidean geometry. But in terms of physics we call it as a flat geometry in terms of that physics. And the second one is the Riemannian geometry, or in terms of physics we call it as a closed geometry or a spherical geometry. So that is both geometrical mathematical expression as well as the physics explanations. And the third one is another proposed that we are all know that hyperbolic spaces, okay, in the conic section, hyperbola. So that is what is that Lobachevsky geometry, or we can call it as a open geometry or saddle geometry or hyperbolic geometry. Okay. So these are the 3 types of geometries are possible only to explain the fate of the universe. This is brief explanation, only 2 points I will explain what these type of geometries are. Just you can look at that. In the Euclidean geometry we know this is developed for the flat spaces only, that is the first point we have to consider. Second one is in Euclidean geometry, the shortest distance between the 2 points is a straight line, that is we know that shortest distance is a straight line, and parallel lines never cross, means we are using different word, never intersect. And third one, fourth point is sum of the angles in triangles is exactly 180 degree, that is we know, that is well known geometry in our high school, you know. So that is how this geometry will be influenced for study the further geometries. You can look at that. Second one is immediately we can move for that Riemannian geometry. In Riemannian geometry we are developed for a spherical surfaces. Look at the what changes actually occur in that just to enter into the Riemannian geometry. On a sphere, 2 shortest distance between the 2 point in a segment of a great circle, they are not a line, they are a great circles. Look at that, they are the great circles, and
lines that are parallel at one point, like two longitudinal lines or latitudinal lines at the equator, eventually cross, at least at the pole they have intersect. So that is what is the difference in the spherical geometry. And the last one is, look at, you think that this is complete change of Euclidean geometry to non-Euclidean geometry. The best example is Riemannian geometry. So sum of the angles in the triangle is greater than 180 degree. Actually our principle is 180 degree, but it is greater than 180 degree though. So that is a triangle. Look at that, this angle and this angle, the sum is more greater than 180 degree. This is what explains Riemannian geometry. And in the saddle geometry or a Lebowskian geometry, the developed in the curved like surfaces. Okay, this geometry is in the curved like surface. Shortest distance is a segment of a curve known as an hyperbola, shortest distance. And lines that are parallel at one point eventually diverges from each other. Look at that, the divergence infinitely. So sum of the angles in that case is less than 180 degree. That is the difference between Euclidean geometry and Riemannian geometry and the spherical, what is that, saddle geometry or Lebowskian geometry. Now we can look at the second part is how our geometry is describe the universe. Our universe can be explained in terms of three geometries. That is what is that this structure, just you can observe that the shape of the geometry or universe, the structure of the universe gives us important information about its past and future. That is, will the universe expand forever is the first question ask ourselves, and second one is the universe collapse somewhere in some time, that is the second question, and third is the universe is finite or universe is infinite. Okay. These four questions can be explained or described or to give the answer to the fate of the universe. That is why look at that, all geometries in this figure, it will creates all types of geometries, and that universe, what structure it is universe we can't understand in that. So that is why these two, how we can go to link with the geometry to the universe. Look at that. And one of the mathematical, the geometric model, that is we can call it as a FLRW, the four great physicists and cosmologists, Friedman, Lemert, Robertson and Walker model is a very famous model in this case. Model successfully demonstrate that there are only three possible geometries that can describe the universe as a whole. That is, the universe is possibly it is a open, and or it is closed, or it is flat. So what type of universe we have to look in the nature, that is very interesting thing. We will go to connect with these two things. First possibility is about we have to consider universe could be closed. How it is closed, you can look at that. This is a closed universe because fraction of second it will run some coordinate system. This is in this closed universe. Look at that. The mass density, this matter density, we call it as notation that omega will represent a matter density. The mass density omega is sufficiently high, means density, because this is entire the universe is full of 80% of dark matter, I think you know, dark matter and dark energy. So this are sufficiently high that gravity will stop. Look at the process how that universe will taking place. The expansion of the universe and will eventually collapse. Okay, eventually collapse. Geometrically that can be explained as this model corresponds to the space time with a spherical geometry in R3. We have to connect this to the R3, and that is mass density caused by the space to curve back on itself, folding and open immediately. So that forming like a 2D surface of a spherical balloon. Okay, so this is what is that geometry, and in such a universe, if we travel along this straight line, you could eventually return to your point of origin. So that is the property of the spherical geometry. We already know that in the second slide, last slide. So this is what is that one possibility. We have to understand what is our geometric structure of the universe. Second one, this is spherical and this is spherical balloon. So that is what is that going on, expanding, and after that it is collapse, right? And second possibility is universe could be open. Universe could be open. So that is this is open university. You are open. You can go on what is that, zoom out and zoom out your telescope. That is open, 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 open everywhere. That is why we call it as a homogeneous and isotropic. Homogeneous means for any direction, anywhere you can look into the universe from your as an observer, it looks like a same. If you start to move in any direction, the direction should be same. Okay, looks like same. So that is what is that homogeneity and isotropy nature. So that is why when we can zoom out our universe, it is open, open, and open up everywhere. So that is why the value of the omega in this case is less than 1, and that so that gravitational field is too weak to stop the expansion, and universe will expand forever. Okay, the universe will expand forever. Geometrically, while in a closed universe space curve back on itself to generate a finite volume in an open universe space curved away from itself, that is called hyperbolic. Thus, it produces an infinite space. Okay, hello students, hello, stop your mobile seeing, either sit or go out. You do any one, at least one thing. Okay. And so in this case, the geometry of an open universe can be approximately described by the surface of a saddle. Okay. So this is second type of geometry we have to describe that universe. Look at that. That is how that saddle, the step by step the universe can be. We have to look into that. Okay, hyperbolic universe we call it as. And third possibilities is universe could be flat. Okay, our universe today, how it will be flat looks like. This is the flat universe. So here that geometry and physics, how they are coincide in this case, the mass density omega is preciously equal to 1, omega is equal to 1. It means that density is equal to the critical density, exactly equal to the present critical density. This puts the universe on the broader line between external expansion and eventually collapse. It means it expands forever, but the expansion speed becomes closer and closer to 0. Then space in this case is very flat. Okay, there is no curvature, nothing can formed, and infinite. This geometry is identical to the what we can call it as a flat geometry or a Euclidean geometry. Okay, so these two geometries are exactly describes the present nature of the universe. This is one thing. And the conclusion and impact of those connections between that geometry and universe is, if without cosmological constant, without using a cosmological constant, whenever that geometry will occur, we are not using cosmological constant. Each type of geometry corresponding exactly to the one fate of the prescribed fate of the universe. That is, if the cosmological constant or an energy density of a vacuum is not 0, we can find redefined the factor omega. Means we have to redefine the omega density. That density can be defined as the new parameter is total, omega total. So that omega total is a matter density plus occupied that vacuum density. So that is a new parameter. So from this new parameter is connected to the our geometry. That is, whenever the total density is equal to 1, that is a flat universe, and it is less than 1, it is an open universe, and it is greater than 1, it is the closed universe. So ultimately now there are good reasons to suspect that our geometry of universe is flat. Okay, many of the results are shows that our universe is flat. This is what is that exactly, the flat university, positively curved universe and negatively curved universe, and along the what is that our space time. So this differential geometry, that geometry and Einstein theory of relativity. In one slide I will show that that flow chart, how that differential geometry to reach our cosmology. So there are two types of differential geometry. One is local differential geometry and another one is global differential geometry. Usually we have concentrated on local differential geometry, means the wherever we can see it is look like a flat, but it looks flat, but it is not flat, it is always a curved shape. So that is global differential geometry. And generalization of that geometry can be, we can call it as a manifolds, because this universe we can look at that folding and folding. That is, we can call it as a manifolds. That entire structure or surface, generalization of the surface, we call it as a manifolds. Some manifolds to some Riemannian metric, that is distance what we can measure. With a differentiable manifold, with a metric, we can call it as a Riemannian metric, we call it as a Riemannian manifold, or a contact metric, we can call it as a contact manifold, and other etc. etc. There are so many special types are there. But Riemannian geometry is directly connected to the special theory of relativity, because Einstein is developed on the basis of that Riemannian geometry only, and general relativity. So then we can move on to that cosmology. So another branch of generalization of this Riemannian geometry, we call it as a Finsler geometry. So that is the ultimate last type of geometry at present in the universe. There are other branches, so many branches are there in Finsler geometry. So that is Finsler geometry, directly we can deal with general relativity, special relativity, very special relativity, and doubly special relativities. All the types of relativities we have to connect it to that Finsler space. And there are many applications in biology, thermodynamics. Now we are concentrating on only the cosmology. We are concentrating on how our Finsler geometry is connected to the cosmology. Look at that. Riemannian geometry is connected to general theory of relativity, how it will be connected. That is space-time. The first structure we can call it as a space-time. Look at that.
Professor Murthy, please conclude.
Okay, sir. Okay. That is what is that space-time definition is very interesting. Matter acts on gravity, and gravity acts on matter, that will create a space-time. That is the structure. Space-time structure. This space-time structure is directly related to the Einstein field equation. That is what is that space-time is a four-dimensional topological manifold with a smooth atlas carrying a torsion-free connection compatible with a Lorentzian metric and a time orientation satisfying the Einstein field equation. So this is what is that a physical key definition of the world. That is what we can take about that Einstein definition of a space-time. To understand this definition, we need all these colored words. Each colored words have its own definitions. Such a big meaning it will give to that to the word. So that is what is that geometry of that one. Sir, thank you. I will complete that. Look at that. The Earth and spaceship motion can be motion can be represented by points on a Minkowskian plane. This is another four-dimensional best example of a four-dimensional geometry. I think it will describe that when we can move along with the coordinates, the space and time and how they are connected. When we can move into the speed of a light, so then naturally that the time that will be very less. So this is what is that the, and sir,
can you please?
This is what exactly the relation between Einstein field equation. One side, that in LHS completely it is described by geometry, and in RHS it is completely described by physics, is the key definition of that one. Each one we are explained here. That is the nature of the how the space is curved. Okay, so that is what is the nature of that physical explanation of that equation. Okay, this equation tells that tells matter and energy how to curve spaces, and that equation will tells the matter and energy how to move through the curved space time. Okay, I think you know that is nothing can happen when we can take a zero vacuum.
Please rush.
Yes, sir.
Because you already exceeded 5 minutes.
Okay.
Never, actually 7 minutes. So I think we have a few other talks now in pipeline. So maybe you can conclude now, just now.
Yes.
You said most of the things now. Yes.
Just a minute.
No.
Madam, 1 minute. I lost 3 slides. I will conclude.
You just flash the slides and people understand. They're all experts here. This will save time. Yeah. Great.
Sorry, some time constraint. I will finish my talk. Future behavior of the universe. We have to predict 3 important things. One is based on dark energy and dark matter. One is big freeze, that is we can call it as that universe is death, that is we can call it as a heat death. And second one is big rip, that is the universe at a moment it is tearing part and part, that is tearing apart. And the last one is a big crunch, that is recollapsing our universe. This is what is that a big freeze. Freeze means everything become constant, there is no motion at all. That is one concept. And second concept is it is disappearing, rip apart, that is we can another. And last one is what we can call it as a rip. Again we can move on to the singularity. What we can call it as the Big Bang theory is also moves from singularity. We are again move to that singularity concept. So that is a big crunch, right? Yes, madam. This is a very important book. If you want to refer that, those who are interesting. And this is complete, our universe is explained in this book. For example, there exists a multi-universe, that is our mathematical universe. And another one is God a Mathematician? Is a wonderful book. And these are all just like mathematical novels. And third one is God created the integers. So that is written by Stephen Hawking. Okay. So this is a very great contribution. These are of all our
publications.
Papers. Yes, publications. We have published almost 45 papers for last 5 years. Thank you. Thank you very much.
Thank you very much, Professor Murthy, for a very, very wonderful talk. And I'm sure among the audience they might have tons of questions. And because we don't have time, I would request them to pose the questions before you during the tea break.
Sure.
And one thing I can say, that whether the universe as described by the geometrical estimation structures, flat, curvy, or
that's spherical.
Spherical. I would say it is actually, if we describe it in terms of the thermodynamics, first law, so that says the total energy of a universe and surroundings is constant, which means the energy cannot be destroyed, not created. So it is interconvertible. So that is exactly, but in terms of geometry, you can have so many sort of explanations. That's first time I'm hearing. So anyway, thank you very much.
Thank you, sir. Thank you so much.
Thank you, sir, for very inspiring lecture when you explain all the geometry and its relation between cosmology. Thank you, sir. Now there is a short break, tea break for the 5 minutes, and there is a announcement from the Dean. Please, all the dignitaries who present here keynote or something, your lecture, so please collect your certificate from the Dean office, and please don't forget this. Please have a tea which is waiting outside of this central hall. Okay, sorry. I request session chair Mr. Gupta please present a memento to our respected speaker. Sorry, sir, I forget this. Request all the dignitaries. Professor Gupta, please wait. The tea is coming here so that the session is running continuously. Yes. If you permit this. Thank you, sir. Photo? क्या बोल? Now we move forward. I invite, it's indeed an honor to welcome V. Lokesh sir from the Department of Studies in Mathematics at Vijayanagar Sri Krishna Devariya University, Bellary. A distinguished academician and researcher, Professor Lokesh has made notable contribution to the field of mathematics. We are truly pleased to have him with us today. Please, sir, deliver your talk.
Given, downloaded. It is downloaded. You downloaded something. CONIAPS. This one? Ah. No, you downloaded. No, not that one. Just now you downloaded. Given, sir. Huh? You don't? Huh? PDF. Location. First of all, I would like to thank the organizer for giving an opportunity to share few thoughts of my talk, and also a special thanks to IAPS because I am a member of IAPS and organizing committee and many other things. And here they are given R.S. Mishra's memorial lecture for me. This is one of the fortunate because he is a mentor of our Panda sir. That's why I am very surprised, and also I have many things to see because I am basically a graph theorist and discrete mathematician, and I work some of the last 1 month before I went to some conference related to cosmology. Then I got some idea related to what we working in the topological space last 15 years. We worked in more than 100 research articles in the topological spaces. Then I got some idea related to cosmology and the topological indices. That's why I made an attempt in last 1 month. We gave the revising of the many things related to graphs as well as the cosmological aspect. That's why I given the title is Topological Indices and Network Geometry of the Universe, that this is the bridging between the graph theory and cosmology. In my talk I will make a few introduction related to the whatever the theory we are introducing, and also some cosmological aspects and topological aspects in the graph theoretical things. Then we made an attempt for interconnection between the graph and as well as cosmology. Then we observed some of the ideas what we can make in the further research. This is my flow of my talk. We propose a network geometric framework for gravitation and cosmology, in which graph energy derived from the spectral properties of the network Laplacian serves as the fundamental physical quantity. The universe is modeled as a dynamical network whose state is characterized by energy like, that is a connectivity indices, generally that is Betti indices are the general phenomena they are utilized. Now that can be rearranged in the graph eigenvalues. In this formulation, effective geometric notions such as curvature, dimensionality, horizon structure emerge from the distribution and flow of the graph energy across network modes rather than the underlying space time is metric. And gravitational interaction you already seen in the Professor Nasimurthy's slide, and this approach is intrinsically background independent and suggests that the gravitation and cosmic dynamics arise from the spectral energy organization in network topology. In general bird's view of the topology, everyone knows about that in the topological aspect. The topology studies the properties space that remain unchanged under the continuous deformation. You can observe stretching, bending, but not tearing or gluing. You observe in the right hand side the study of the properties that remains unchanged by continuous deformation. That is coffee mug and dot net. Some of the examples of a topological spaces, that is circle, torus, sphere and Mobius strip. And these are some of the key properties, that is connected, compact and number of holes depending on continuous deformation. And geometrical aspects you already seen in the previous slides, that is plane surface, spherical surface, hyperbolic surface, and these things zero curvature where the positive curvature and negative curvature. After that Nasimurthy is given a detailed structure about the positive curvature, negative and flat curvature. These are the fundamental things we look into the bird's eye view. Then after that we compare with the topology versus geometry, that is distance in topology, geometry and the topology, it is connectivity, curvature, holes and metric dependent and metric independent. Then finally I come to my original field. What is topological index? That is, a topological index is a numerical quantity derived from the structure of a graph, geometric object that captures the structural information. Actually this topological indices are come into the picture of the chemical mathematical chemistry, mainly on molecular graph, that is Wiener introduced the connectivity index in 1947. Then network science is also some of the aspects, and graph theory. These convert the complex structure into a single measurable descriptor. There are nowadays there are more than 6,000 topological descriptors are derived. In that some of them are famous, some of them are useful in the nature. Here the graph, simple graph means we always represent a vertices and edges. Similar way in the galaxies are nodes. Gravitation interaction means proximity of edges. then the universe becomes a cosmic network graph. Then, but in the two-dimensional it is a very difficult task to judge the things. That is why a network of interconnected circular nodes with a directed arrows indicating edges accompanied by a labeled graph, that is G, that is U comma V means U is a global attributes of the graph, and E means edges and V is the vertices. Then we can make some edge set in the form of EK, RK and SK. RK is equal to I and K running 1 and NE, you can see in the diagram. And here the index K running from K is equal to 1, NE comprise the edge and vertices set, EK of the cardinalities, and NE which may be, sometimes it is directed, sometimes it is not directed, connected via receiving the indices between the nodes. Some edges can be equivalently parameterized by an adjacency matrix Aij, in which I and J are index sender receiver, that is the general index, and where each node Vi is the vector features, and in physical system like one might represent V as the set of individual particles attributes like mass, position, velocity. Now we can make an interconnection between the connectivity indices, that is degree centrality means local interaction density, clustering coefficient means local curvature analog, betweenness is centrality means geodic flow of concentration, average path length means emergent distance metric. Then major thing in our work is, that is spectral gap. Spectral gap means that is global stability and expansion. These are the metric tensor fundamental level, and some of the definition related, some examples, we made some connectivity between these two. Now I will give you the simple structure related to a graph and a Laplacian matrix. Here we taken a P3 graph, that is a 3 vertices and 2 edges. Then first we can represent in a adjacency matrix, that is 3 cross 3. We can make there is a connection from A to B, that is why it is 1. Similarly B to C, there is a connection, and B is connected to A as well as C, then you get a adjacency matrix. Then you know the degree of the matrices, that is D, that is degree of A is 1 and degree of B is equal to 2 and degree of C is equal to 1, then we get a degree matrix. Now then we can discuss about the Laplacian matrices, that is L is equal to D minus A, then you get a matrix simple calculation you get, then after solving this you get an eigenvalues. Different eigenvalues we can represent if lambda 1 connected to network is connected, and lambda 2 means algebraic connectivity indicates the connectivity strength of the network. Larger eigenvalue describe the higher frequency structural modes of the network. This is the some important thing we observe. Then local and global connectivity measures. After observing the Laplacian, we can make some connectivity for the range of indices including degree and distance, and also we can use the status connectivity indices. These are the fundamental things we can utilize for our global study. Now I will move on to our topological indices, that is this is the degree based topological index, that is W of G. Usually these scalar summaries in our cosmology model we mainly use for spectral summaries, that is Laplacian eigenvalues, energy, because they connected naturally to diffusion for flow on the network. Actually this is a distance based topological index, this can be utilized for the galaxy dispersion measurement. And this is the Zagreb, it is introduced in 1972 by Gutmann and his team, used for degree based topological index and measuring clustering tendency and capturing connectivity intensity. And Randic index, this is the formulas for Randic index. It is useful for branching and tertiary structure. Now this is the recently introduced by one of my scholar, that is topological index, VL index is introduced by Deepika. That is a distinct, it is a degree based topological index. It is a modified by the Zagreb indices, that is dE is equal to du plus dV minus 2, that is degree with respect to u and degree with respect to v, and another one. This is major applications we studied in the tensor products of F-sum graph, that is published in the TWMS journal. And I will give you some hint because many degree students are here. That is why how we can calculate the VL index means, this is a simple graph, that is a T13 graph, that is tadpole graph of T13. If you see that V1, the V1 degree is 1 and V2 degree is 3 and V3 and V4 degrees are 2. Then if you substitute that there is a edge connection UV, means V1, V2 if you take, then you get 1 plus 3 plus 1 into 3, then easily you can calculate the VL index. This is the simple structure, but in the generalized structure it takes more time to calculate. Similarly, the status of a vertex of a graph. In Frank Harare is a main graph theorist, he worked on the transmission or status of a vertex, means we can find the particular vertex status that can be calculated using it. Similarly, that is the distances from V1 to V2 and V1, all the means if you find the status of particular vertex means you can take a sum of the distances between the particular vertex and all other vertices. If you see that there is a relation, the status of vertex V1 means the distance between V1 to V2 is 1 and distance between V1 to V3 and distance between V1 to V4. That is the connectivity. If you add, then you get a status of a particular vertex. Using this we can find all other vertices status, then you get a status of that particular graph. Similarly, in the recently in the 2023, another scholar, my scholar, he done replaces the degree based topological index to status connectivity index. That is the calculation is you already know. This is motivated by Dobrin and Kochetova in 2017. They are introduced the first status connectivity index. After that many things came and many applications are also there. Then these are the combination whatever we observed in our research. We done some degree type index, distance and status. These three combinations we mixed with the connectivity, new connectivity index, that is distance based topological index developed in graph theory that can be connected to connectivity structure of graph. That maybe it is useful to cosmic network modeling. This is the basic idea what we are thinking about the next future work, that is VL status index measures how connected vertices to the entire graph by using the concept of vertex status. Similarly, vertices are the centrally located, have a smaller total distances, means status connection, and peripheral vertices have a large distance total distances, then this information of graph become a global connectivity descriptors. These are the general cosmological terms and the relation between the graph. We make a large scale structure, symmetry and stability and vector space modeling. These are the important things we can observe the things. Then we make an interpretation, that is local connectivity as well as global position, the distances of all the observation. We observe that sensitive to branching, centralization as well as the overall topology. Higher connectivity index means it is more extended are less centrally compact. Similarly, lower connectivity index means network is compact and strongly interconnected. This is the status connectivity related that is gravity as a network hub. We can use this, and assembling of the graph, that is the operation related to graphs can be applied here, graph operations. Then you get a non-invariant representation as well as invariant representation. You can observe this non-invariant graph and invariant graph. Non-invariant graph nodes are labeled with explicit grid coordinates. Edges encode relative distance only, represent depends a coordinate system. But here in the invariant graph, nodes do not store absolute coordinates because in the space. Then edges encode full relative geometric information, distance as well as angles, and properties remain unchanged under the rotation and translation. This representation embeds the symmetry directly into a graph structure. These are the two important aspects we must aware of this. And the network geometry of the universe, these things you already known, and galaxies are connected through dark matter filament, gravitational interactions, and some of the terminologies from the cosmological point you must observe, that is cosmic web, galaxy cluster, filaments, walls and voids. And in the combinatoric nature, the branch of mathematics dealing with counting, arrangement, combination of discrete objects. That is this diagram represents a space-time as a discrete network of interconnected geometric units rather than a smooth and continuous fabric. Here we can show counting and arrangement of these fundamental building blocks can model the complex evolution of the cosmic structure. This is the graph theory, a field you know that, nodes and traces, filaments. This is the filamentary structure and versatile tessellation, and this is the Betti number. It is in the famous number counts a topological feature at different dimension, that is beta naught, beta 1 and beta 2, isolated clusters and filamentary structures forming cycle. This helps to quantify the structure formation, compare the simulation versus observation. You can study the dark energy effects, and there are persistent homology, the study topological feature persists across the different scales. These are some of the process. Start with the discrete point distribution, gradually increase the connection radius, track when features, components, loops, voids appear and as well as disappears, create persistent diagram. Then we have an interpretation between this long-lived features and short-lived features, and you know the famous Euler characterization, classical topological invariant with respect to the relationship vertex, edge and faces, and Betti numbers also provide the descriptor. Then we have a node level metrics, different metrics we are approaching. Then global level matrices, that is average path length, network diameter, graph entropy and modularity. Now finally we move on to a general relativity, the Einstein field equation. It is large scale structure, discrete geometry, graph curvature, network entropy. This allows the local geometrical interpretation of the cosmic clusters. And using, now we propose that we propose a network analog to eigen equation, that is LCI is equal to TI. L means graph Laplacian, Ci is the clustering curvature, Ti is the energy information density. Using this we can make this already we explained in the graph field equation, and clustering curvature, energy information density. Then using the Einstein equation says that matter tells the space time how to curve our Network field equation state that energy tells the connectivity of the network how to reorganize. The graph Laplacian measures how connectivity curvature spreads across neighboring nodes, producing gravitational behavior as an emergent phenomena. And these are the some of the striking aspects. These are the aspects, nodes, edge, forces, topology, indices and scale related to that molecular network and cosmic networks. And these are the some of the key differences: dimensionality, evolution and completeness. And these are some of the applications related to topological classification. Now we dealing with the machine learning on network metrics to classify cosmic structures, and that is our main motto to study. And also in the multi-scale analysis, persistent topology reveals nodes, filaments, wall and void, and cosmological constraint, that is dark matter distribution model, galaxy information efficiency, initial condition from inflammation, dark energy, effects on structure growth. And these are the some key takeaways, that is topological indices provides and numerical descriptors of complex network structures, and cosmic web can be rigorously analyzed as a mathematical graph or network. Betty numbers and persistent homology offers a powerful tool to quantify connectivity at multiple scales, and network metric reveals the properties of cosmic structures. Machine learning to topological feature can be classify and predict the large scale structure analysis, and some mathematical tools we can utilize, and multi-scale analysis, and is essential universe as a structure. Future survey will provide unpredicted data for topological analysis. These are some of the things, the new work can be done related to cosmology and our graph theoretical aspects. And future direction, we have some global topology of the universe, hyperbolic network embedding, topological phase transition, GNN learning cosmic topology. These are the some identification areas we can do some work. And these are the some of the philosophical significance, practical impact and interdisciplinary bridge between these things. And some of the papers we referred, as well as our recent papers related to index, and some of them are cosmology related area.
Done. Thank you, Professor Lokesh. We are also happy that you finish your talk within the time allotted, even probably 1 minute earlier, and that's a discipline, you know, in mathematics too. So let's clap for him.
Thank you for giving an opportunity for
the cosmic topology and geometrical, you know, sort of interventions. You know, I understood a bit, but it was very interesting talk. And this is especially Professor R.S. Mishra Memorial Talk. So rightly deserved, very beautiful talk. So let's, if you have any questions, probably we can take some. I think he has given full dose, so probably there is nothing left for asking.
Thank you.
Thank you.
Thank you.
Thank you, sir, for such an engaging and interesting presentation. To express our heartfelt appreciation, I request our session chair, Professor Gupta, kindly present the memento to our distinguished speaker. Now, it's my great honor to introduce Dr. Ajay, professor in the Department of Physics at the Indian Institute of Technology, Roorkee. He is a distinguished researcher in the theoretical quantum condensed matter physics with more than 30 years of teaching and research experience. Dr. Ajay has published over 130 research papers in reputed international journal and has successfully guided 11 PhD scholars and numerous master students. His research focuses on strongly correlated quantum material, superconductivity, graphene nanostructure, and the quantum computation. He has received several prestigious recognition, including the Young Scientist Award by the Government of Uttarakhand and the International Award for Research and Innovations in Physics 2025. We are truly privileged to have such an eminent scientist with us today for Professor O.N. Srivastava Memorial Lecture. Sir, please.
अजय एक कप चाय पी लीजिए लेक्चर के पहले थोड़ा सा वो कैफीन लेके बोलिए अच्छा रहेगा थोड़ा कैफीन ले लीजिए
बीच में पीता रहूंगा
कैफीन लेके बोलिए अच्छा रहेगा वहाँ तो पहाड़ में चाय पीते ही रहते हैं हमेशा
So at the outset, let me first express my gratitude towards the organizer, especially the KPIs, what you say, International Academy of Physical Sciences, and this conference here at AKS Institute. And I was given the task to talk about in the memory of the Professor O.N. Srivastava, and there are some glimpses of his personality that will be very important to inspire the student, and also some of the things which connected with my career and my current research at Roorkee. So the talk is related to the memorial lecture Professor Omkar Srivastava, who has been a legacy at BHU and is known internationally. In his own time, he known as the hydrogen man of India. So my talk is actually the application of superconducting quantum dot structure. You students should not scare, because I will be at your level, atomic level, and this structure is being used nowadays to understand the quantum communication and quantum computing. Sorry. So let me first introduce, this is the famous, you can say, mark of the BHU. Most of the faculty are here. And this office is the, you can say, the legendary, how he managed to do work 24/7. And he used to use water, to use sunlight to create hydrogen energy. And in the December, one of my young colleagues, Himanshu Pulara, is a stud professor. He visited BHU campus. You see the nameplate of that legendary is still there. Nobody could dare to remove it. Okay. So this is our campus from where I belong. It is beautiful campus, I think, and it is oldest institute in the South Asia. It was basically made in 1847, 100 years earlier than the independent India. Yes.
Oh, beautiful.
Yeah, and chairman immediately got. This is the center arena of Roorkee, where the Thompson building is there. So my talk will basically control these 5 milestones. I'll first give you a foundation, and then very brief foundation will brought you to the different structure, and then pedagogy, how quantum physics giving you a turning point now you are graduate student, and what are the technological implications and what should be the next? So I come on to the 10+2 level. You might have learned that resistivity versus temperature. Most of the BTech students go in the laboratory and was asked to measure the resistivity of, for a semiconductor and to find the band gap. That is the easiest way. And we use four-probe method. So if you measure the resistance versus temperature, temperature on the say x-axis, and you plot the resistance versus temperature, you see in a normal metal, usual metal, just like copper, aluminium, the resistivity goes down first, and if it is a pure material, it try to go to, if you extend it, the people at old, बहुत old बोल रहा हूँ, उसके बाद ये बहुत changes आए, these dotted lines are extended version, that what is going to happen? Okay, and if you say it is a material which has some impurity, so there will be some interaction with the electron as well as with the impurities. Then the resistivity show the second one. This resistivity does not go immediately zero. It show exponential downward and still have some intercept on the y-axis. So this was the scenario. There is one more scenario due to Kondo. One of the faculty has named a theoretician who said, okay, at low temperature, if the impurity is magnetic in nature, say iron impurity, cobalt impurity, then this curve may take an upturn, a downward minima and then an upturn, asymptotic behavior towards y-axis. So these were the amazing application, and nowadays these all variations are in the form of the application. So there were the two person, you know, the Kelvin and Drude is the basically famous theory where the electron can be understood in the pure metal. Just they can be without any resistance, just like fluid, and their resistance may produce to be zero, but not exactly zero, tend towards zero at a very low temperature. But Kelvin was of different view. He says the resistance of a metal first fall and then it bottom up, okay, and it actually happened, and because you are not able to find out very pure material, there will be some impurity, and this impurity will try to bring the resistivity finite even at absolute zero. So though we are still, it is a message for young graduate student that we are still far away from absolute zero. The lowest temperature is 4.18 degree Kelvin, and we want to brought it to the zero by using some laser technique, and there is a separate group working on the low temperature feature. Okay, so the next observation is the very big discovery which basically started from here. It was done in 1911 by Kamerlingh, and what Kamerlingh did, he placed the material, a metal which is actually having a purest form, mercury, and try to measure the same resistance. What he find a phase transition in the resistivity, and you look at the point, he has only taken very few points. From this point to this one, there was no, you can say, the continuity. It sharply go suddenly a large distance within the very small temperature range. So it was a big observation, which basically Ons was given a, you can say, a different kind of feature which Drude and Kelvin could not understood. And if you say that the mercury has the purest material and its resistance state is roughly zero, of course it is of the order of 10⁻⁵ ohm, which can be called, because it is immeasurable, it is almost zero. So though this is still a finite resistance, it's still a finite resistance, we have to make it zero to measure devices, to have certain length scale, and you can say the electrical engineers and electronic engineers are working hard to break this scale. What are the further downward thing? And for this measurement, he was given 1913 Nobel Prize. So the important thing is this triple group is actually a different structure, heterostructure. This guy is Bardeen, an electrical engineer, and two of them is basically this is Bardeen, and this is Cooper, and this is Schiffer. So these both were basically the theorist. Schiffer has a very strongest theorist, and this was an electrical engineer. So electrical engineer, he was having the leading of the theory, and the theory was that at low temperature, the electron may pass through the lattice without hindering it. And you look at this very interesting feature, the atom which are at a larger distance from the location of the electron, they are not being basically at low temperature disturbed. Only the very close, they are called virtual phonon or local disturbance, and this local disturbance create a bound state that pass through the solid, and this will actually give you a phase transition. The electron convert to a spin 0 entity in the standard BCS superconductor, and the electron with the down and up spin get connected together. Sorry. Yeah. So they get bound, okay, and this bound state remain around the Fermi level as a Fermi C in this shadow region, because this region has all the bound state of k and minus k electrons. So this state in this region is now bosons with spin 0, and these bosons have very large coherence length, and there is a gap, just like in semiconductor, the gap is there, but the origin of this gap is different. This gap is generated by bound states at the Fermi level, and the coherence of this pair state is very large, of the order of 10 minus 4 centimeter. So one can take the technological advantage of this, and these are the usual band structures. If you know the density of state of metal with respect to energy, it goes as square root of energy, and density of state of a superconductor at Fermi level does not have single electron here. This state is embedded by pair of electrons, and this pair of electron can generate a gap from the ground state to the, you can say, the excited state, and this gap is the binding energy of the Cooper pair. So this physics, mathematics you not to go to the observation. If I summarize this thing, this give you I think one of the important discovery idea. First is superconducting state has DG resistance close to 0, and the magnetic property of the superconductor are dramatically connected to its electrical property. They expel out the flux, they are diamagnetic in nature, so they can keep the state of a system in a mild field remain intact. When you apply field, the field should not be very strong, okay, and the superconducting state is highly ordered state, and this ordered state can be thought of to have application in quantum computing. The electrons are ordered below a transition temperature, and when your transition temperature increases, the electron may disappear, and the superconducting state has been found have the lowest entropy, because this entropy is basically related to the available energy. So the energy will convert it into certain information, as earlier in one of the event, our chair has said that entropy is important for a superconducting state. And later on, Bennett and Lander had developed a theory where entropy has been used to communicate the information. Okay, so this, if I summarize it in terms of a technological way, if you look at now, there is a galaxy of superconductor available across the periodic table. These materials are having increasing transition temperature, and you are close to around 77 or 90 degree Kelvin. And now you have a carbon based material also, say graphene. It has double you can say structure. You are having metal, you are having insulator, and you are again matter, and when you reduce temperature, this peak convert into superconductor. And the transition temperature resistance curve for this material is still an amazing thing, which can be, what is happening? Yeah, look at this curve. This curve, if you have a graphene structure, and these two graphenes, one is close to you can say 0, but both the curve in a single layer and double layer has different you can say transition temperature. So these are some hope, and this is a very good problem for a PhD student. Nowadays you have big data, you can use this data, you can model it, and you can find out the parameters which can be used to still assist that what can be the possible combination of the material that can grow the transition temperature, say up to room temperature. It will be a big breakthrough. So one of the students with me, master student, is working on this. that how to make this graph actually a more linear, and its regime had to be made very, you can say, close to say 200, 300 degree Kelvin by using certain data from this galaxy of superconductors. And it can be possible because there are certain materials which are above the high TC material, the iron based system which is magnetic, the tri-layer or bilayer graphene, and also some iron and graphene combinations, they are amazing. So you can use this result to predict a material which can produce a zero resistance state at room temperature. Now next one is the Josephson. In the morning session there was a person from young student from Cambridge. So B.D. Josephson was 23-year-old graduate student. He just took the two materials and produced them in a very thin regime, insulating or a dielectric material, and they found that this Cooper pair can move through this region which is very small. And the Josephson could not understand it. His mentor was Phil Anderson from Princeton. They basically tried to explain this feature, and he got later on the Nobel Prize, and this Nobel Prize was shared with the Phil Anderson. And also the third Nobel Prize was Badnor and Muller for high temperature. The fourth Nobel Prize was given to the Ginsberg and Abrikoso, and this year Nobel Prize was given to see this feature in a bulk material, that a bulk material also produce you the macroscopic quantum tunneling which can be used. So the properties which we are using is that you don't have any voltage, the electron can tunnel from here to here and back and forth through this very small insulating region, and this region actually can produce you a DC current, and this is because of the phase difference between the two superconductors, because the density of the Cooper pair here and here may be different and they may be oriented differently. So they are self-aligned. It's just like self-ordered, you can say, material, just like biological people and chemistry people say, if you put different kind of molecule, they make themselves assembled, and they can move from one place to another place in a very well-defined way. So here you find that the phase can dictate this current to move, and this current convert a oscillation which is the directly difference of the phase of the Cooper pair. But if you apply certain voltage across it which is DC, you say that there is some time dependent phase, it is 2 EV T by H cross, and this time dependent phase create a very interesting technological feature because your DC voltage is converted into AC. So student, you know that inductor where you apply a DC voltage convert oscillation. So you can contain oscillation at the nano, you can say, scale by using Josephson current, okay? And this property of this superconductor is being used as a quantum qubit or superconducting qubit. I'll show you in the next slide, okay? So the other discovery is the Feynman. If you see the Feynman would have been a very, I assume him a very, you can say, next to Einstein, a very fundamental theorist. He has not gone to any laboratory, he did not did any experiment, and you can see his Berkeley physics volume. They are very small experiment he has done. And he was the chairman of Manhattan Atomic Bomb Committee, a theorist who produced atom bomb, and after that, when this atom bomb was produced and it was basically used at the Japan, after that he became very volatile and he became ill. So that semester he could not take any course, and he became very, you can say, in a different mind state. So the story I want to tell you that this guy did not did any sort of laboratory experiment, no fun he used to use. And there are Berkeley Physics Volume 1, Volume 2, Volume 3, Volume 4. If you read them, you will see that there are amazing physics. So I'll say you that you go into my website at the physics department at IIT. The Berkeley book is available freely. So don't go to ordinary books. Go to some fundamental facts. Okay. So the another point Feynman has done, he was also a very popular physicist. He said that, okay, if you want to see electron tunnel one by one, you have to basically generate not the bulk but some cluster of atoms. they are called as artificial atoms. So, in no single atom, but you can have several atoms together and can see that electron can tunnel together. So, this fabrication was done. So, the next physics was started from here. You have a bulk material, the density of state goes like this, square of energy. If you make a chip of it, so you have some steps, plateaus, and if you make this chip just cut into points, you have spikes. So, by changing the dimension of the material and you make it dimension to the order of angstrom. Say if you look at a hydrogen atom has the size of say 1 angstrom, 0.56 angstrom is the radius. So, you can be few atom in this region. You see the state of these atoms are discrete, and these discrete state can produce you can say certain benefit. The electron can be made excited from one state to another state without loss of any energy in between them. And this is a famous result where you can have electron trap in a very atomic like regime, where this has discrete energy level, and the energy level separation is increasing because the ground state at the first excited state, at the third excited state, instead of going continuum, it is increasing. And when it is increasing, the probability of finding the electron in the ground state and here will go on changing, and also their gap. So, this gap can be used to make certain devices. So, nowadays we have a lot of you can say quantum dot out of the semiconductor metal and combination of that, they are available. Okay. And what are the next step? That is quantum dot can be aligned together to make the basis of quantum computing. How they will do? Because you can have confinement of the electron in these energy level. The energy level can be tuned. The energy level can be basically accommodated electron and can change the capacity to accommodate electron in these states, and the spin and charge can also be controlled. Okay. And if you have this property, the manifestation are that discrete energy level actually are important for quantum confinement, and also the controllable size and shape and gate voltage can further give you technological lead, and Coulomb energy and Coulomb blockade become actually positive aspect for motion of the electron, and this can be done by having a source and a drain. This source can be a metal, but for quantum computing we are using this is superconductor, and this guy is a quantum dot, and this Cooper gear try to move through this dot. Now, what is the idea? Idea is now you have quantum dot based Josephson junctions. So, you have a superconductor, instead of insulator you put a quantum dot. A quantum dot is just like an atom, just like hydrogen atom. Okay. And you can have now instead of two phases, this is due to phase change, this is due to temperature change. If superconductor on both the side are of different you can say material and transient temperature, you have one more phase, and other is you can apply voltage. So, now you have controllable parameter, not one, not two, but third, and all three can be operate together at different frequency, and you can say different phase also. So, if these are the you can say properties of this system, a small system, you can see you can generate basically Josephson junction qubit out of it, because these states can be blocked to the ground and first excited state, and you can use the quantum metrology, you can use the quantum squid, just like you do the MRI, and you can use thermal transport. Why thermal transport is nowadays important? It is important because if I use the semiconducting device like this becomes heat up. A semiconductor has 56% efficiency. The 36% or 35% energy is going to lose, because there is some indirect band gap, and there is always phonon which try to absorb the electron energy, and after a certain time we have to switch off our system. Even when we charge it, it becomes heat up. So, you should also understand how the thermal energy of the system is controlled and how it is behaving when you are using electrical energy. So, this is a very important technological aspect, and the device which I am predicting on the basis of the theoretical assimilation control both. They are very good thermal conductor, and they are also very good control of ground and excited state that can be used to the quantum computing bits. Okay. So, this is a dot energy level. Here I try to give you the feeling because of the graduate student. You see there are three regime. The gamma is this width. This is called the full width at half maxima. There is a peak, and you find out the half of the intensity. At half intensity of this peak, the width can be written as gamma. So if you look at the gamma, the gap, superconducting gap, and the correlation, they are of the same order in this quantum dot superconducting system, and this is a boon. So you can go from intermediate to weak coupling and strong coupling on both this side, where you know the result in this regime. In this regime, we know exact result. Our group has done a very, you can say, very effective calculation in this regime. And once you know exact result here, there is no way to basically stop you to predict the thing exactly here and here. So you can go in both the limit. So though two mathematicians are sitting here, when exact thing are not known, it is better to know approximation, which is always happen. So I say that universe is flat, but when I am walking here, yes, universe is flat, but in the limit of this room, it is not flat. Okay, so it is here. So you have a Cooper pair here. This Cooper pair has to go to this side, and you have a dot. Okay, once you put a dot here, this dot can have a single occupancy. First I am talking about single occupancy. Now how this Cooper pair will transport through this dot? It is just like you have an island, and in this island this bound state has to go from this to this island, and this region is very small, though there is some quantum state, and this energy level is below the Fermi level. So what this electron will do, because the electron is bound, wherever a bound electron go, it try to generate a bound state because of its coherence length, because the coherence length of this pair is of the order of few centimeter, while this distance from here to here is of the order of few angstrom. So you take the advantage of this, and you see that a single electron first try to go here, and when it try to go here, it create a resonance. So when this down spin electron go here, it try to kick the up spin electron to the out of the bound state, because this electron will not let this state here. This electron will make a resonance state, and this single particle state is not in this region, and because of the coherence, it will try to make a home here to go to the single particle state above the Fermi level. And once it is going there, the another electron comes here. This guy comes here. It go here. And the third stage is now this down spin electron become up. So the say up spin is not even here, and this down spin electron go to this side. So what you see? You see that up down spin Cooper pair transport through this island to the down up. Okay, so the phase of the Cooper pair can be changed by using this device. Okay, so your Cooper pair was having up down, and this side you have basically down up. So what is the phase change? Phase change become pi. So it become a pi device. Okay, now on this side, if this island has doubly occupied electrons, एक की बजाय दो इलेक्ट्रॉन हो, just like there are many metals, okay, iron, cobalt, nickel. Okay, so you see that this Cooper pair try to make a arrangement without changing the phase. It is up and down. The same technique can be used, and it remains same, up and down, without, and remain here the same bound state. So here you say the single level doubly occupied side keep the transport of the paired state uniform without changing the phase. Phase means the Cooper is going in this direction, does not coming back. And here the Cooper pair may go from here to here, but its phase is opposite. So this way you can use this technique to generate phase, and you can use a phase splitting case. So how this technique is using? Actually our group is now focusing on, you know this circuit.
Hello.
Yeah.
Time is up.
I'll close. I just want to tell this student, you know this circuit, this is tank circuit, inductor and capacitor. What this tank circuit does, this create a frequency of 1 upon under root LC, bacho, okay, and you have a voltage, okay, but you can replace this inductor by a Josephson junction, and if you replace this inductor by a Josephson junction, and Josephson junction generate oscillations, so what will happen? This potential which was symmetrical will become a flat, little bit flat, and the ground state and the first side state are having certain gap, which basically make a microwave excitations, and rest of the states become very close together. Okay, so here you have uniform distributed states. The probability of finding the electron will be in all the states, but in the ground state its probability is maximum. The electron may go in the excited state also, but their probability is less. But total probability, the electron has to be somewhere in this potential regime where you have discrete energies. But here you can block the electron to the ground and the first excited state. So you have 0 and 1. So in semiconductor, we can have a 0 state and 1 state, and you can make, using 0 to 1, a sphere. One of my friends said that this figure is a geometry, but yes, it is geometry. It is being used, a block sphere, a localized state, only the variation is between theta and phi, and you can make various kind of combination of 0 and 1, and this will become a quantum qubit. It will move around the sphere. Okay, and instead of having one qubit, 0 and 1, you have infinite number of the point at the same, you can say, curvature or the surface of the sphere, and these points will generate a parallel computing scenario. So मैं यहीं पे रुकता हूँ. You can have, there is a lot of physics, because the energy level you can be tuned, so you can do the physics. The idea is the coherence length. The coherence length may penetrate up to the normal state and make this normal material superconducting. So interesting physics. It was done by Anderson. We use Kondo model. So these are the technique we are using. So we at a time, now I want to do finite U. We have done U0, U infinite using slave boson. And this technique I also collaborated with Professor Mishra. I visited once when I was the PhD student, very young, at the Institute of Mathematical Sciences, and Professor Bhaskaran. So what you see is magnetic moment, doublet and singlet. So if you increase the, you can say the magnetic field, and you see the doublet and singlet transition, the Cooper pair enhance the magnetic moment, and it is an interesting story. So this work has been very large number of the citations from our group. We have done basis theory to increase it, and I will fail if I am not able to introduce. This is my PhD guide, Professor R.S. Tripathi. He has been gold medalist from Allahabad University and having postdoc from Cardiff. He is the only person who has done path integral approach and Feynman diagram technique with Professor Luke. I can show you many papers, and this is his individual paper from IIT Kanpur. His thesis has all paper which was written by him as a single author. So this inspired me, and this paper is published in 1967, 11 September. Okay, and this time will be, if you look at the age of Professor Owen Srivastava, he may be very youth, 25, 26, because born in 1942 on the last day of the December. So at that time, Professor Tripathi was also working at Kanpur, and this was his paper. This paper he just discussed with the T.V. Ramakrishnan, a famous personality at that time, a theorist who got a Tagore Award, and this was done on 4th of July 1969. Okay, so this paper inspired me. The theory which we have developed inspired by this paper. This is a letter paper, a 5-page long paper, and this actually generate. I can see that this paper has very original calculations which he done. He was not having any computer at that time, done everything by hand, but we people with my PhD students has done computational aspect and go to those limits which could not be understood at that time. And you will get the famous book of Abricoso and Gorko. This book will sit it everywhere in theoretical arena, and also this guy Soda. So these are Kadanov. So if you look at this group is very you can say who has turned it theoretical physics.
All right.
So बंद कर दिया. Yeah. So this work has been published on the front page of European Physical Journal. This from our group. So and we have done a lot of combinations. Let me go and theory. This is U equal to 0. This is U equal to infinity. Both are equivalent result. So if you know U equal to 0, U equal to infinity, this gap is for finite U. So I am looking one of the students who can basically fill this gap, and the idea has already been generated with Vidyadhi Raja and from our group.
All right.
And now actually limit is you can use DNA, the fingerprint of life, and idea is this. Now you have semiconductor hub at Gujarat, so you are using microprocess which are serial process. We have to replace it the property of brain, I think the first lecture in the morning has said the brain has 10 power 12 cell, it has 10 power 11 neuron. And one message which I want to tell जितने भी स्टूडेंट बैठे हैं, अगर ब्रेन का न्यूरॉन खत्म हो जाए किसी स्टेट में, आप क्रिएट नहीं कर सकते. So don't kill your brain, keep your neuron healthy. If one side goes, you can only live with certain, you can say, transformations. Okay, you cannot create. And a child create first heart, later brain. You know, when it is in the womb of her mother, पहले बच्चे का दिल दिखाता है डॉक्टर. मेरे 2 बच्चे हुए, तो when I go to the doctor, so he said, okay, heart is beating first in the first 3 months, and then your brain comes after 3 to 4 months. So brain comes later. So vibrations are later filled by brain, generated by heart. Okay. So this is actually the quantum result, because parallel processing. So 0, 1, 0, 1. So if you want to do this regime, this is a challenge for the student. This regime we have done. I think we must have, this is due to semiconductor, that is due to semiconductor, this display due to semiconductor, everything is done here, almost. So technology you have, the challenge is here, and now these are some galaxy, वो मैं आपको बता के जाऊँगा. Last one है, ये, this is my PhD guide, Professor Joshi, he is also Bhattagar and Padam Shri. This is another Bhattagar Awardee and Padam Shri, Professor Rohan Srivastava. This is Govind, this is Professor Bhaskaran, and also यहाँ से मेरे पास एक picture चली गई. I used to visit Professor Mishra also, but we are working together. Let it be there. And this Ram Kishore, this is that lab which generated Bhattagar Award. Professor Joshi used to sit in the front office, and he never used to say, okay, deliver. You have to write on the board. Until unless he got satisfied, he will not let you out of his room. So this was the kind of the teacher we used to have.
All right.
और ये खुफिया दरवाजा था. Sunday, Saturday आते थे. NPL में किसी को पता नहीं होता था. Professor Joshi is inside the NPL. चुपचाप. From ICR side. Those who are there. Okay. And this is my guide. And I got my PhD thesis from APJ Kalam. यहाँ पे from after that. And this is the legacy you should enjoy. यहाँ पे भी कई भटनागर अवार्ड है. He is President of India. He was having very good affinity with the Professor APJ Kalam at Metcalf House. The galaxy of very, you can say, black and white student, and having Murli Manohar Joshi has given him the Homi Baba award also after Bhatnagar, and 2 Bhatnagar awardees are sitting together. Professor Asutosh Sharma was the president in INSA, now become Professor Mande, and they are doing some discussion. And it will be not good for my side if I could not narrate my students who brought this physics here, and also my guides and my collaborator, and all the literature which has been cited here, and all you students.
Just for the unversed or who don't know, Professor S.K. Joshi was my father-in-law.
Okay, then. Yeah.
उनकी बेटी
Yeah.
And
I
also
was a student. In the morning I see you're silently sitting there.
वो उसके DRDO को भी थे ना chairman थे. Professor.
He was very humble person. Yeah.
Very humble, down to earth. Very. Other thing I want to say that I had a good fortune of traveling with Professor O.N. Shrivastava from ISC Bangalore to Bangalore airport, and we had a very fruitful talk. We were 2 together in the taxi, and we shared so many things. And second thing was that I sent Vijay Tripathi and Manish Dwivedi to do some nanophosphorus preparations, and they learned from there, which I use for like loading and this thing, the quantum dots work. Your work kept me very absorbed and is very interesting. So
actually, ये मैं इसलिए दिखाना चाह रहा था. यहाँ पे first time when I was postdoc here, I met Professor Rohan Srivastava in this lab. He was having great affinity to NPL because it was generated in 1942, and Professor Rohan Srivastava born in 1942 around 31st December. मैं भी दिसंबर की पैदा हूँ. मैं 15 दिसंबर को पैदा हुआ. Okay, but he is 1942, and I wrote a DST project, and he was I think the chairman. So when he just visited here, he said, I introduced himself to him. मैं जो हूँ सर मेरा project ये हो गया. So he just give me first fund as a PI, and the work which I have shown here has been some link with that also. The funding is also important if it is going to the right person. If it is going to the wrong person, that's also right. It will generate infrastructure. But fund to the right person. Okay.
So very, very nice lecture. Should you have any question, just, go ahead.
So you can write me.
It's a last lecture, like, na?
Yeah.
कुछ और तो नहीं है अभी? है एक और?
Yes, you can
वो
answer
अच्छा ठीक है.
anything.
कुछ कहना चाहती हैं क्या ये?
Yes, ma'am.
Thank you, sir, for this inspiring lecture.
I was not having that.
बहुत ही अच्छे वो SKG
I request Professor Gupta, please present memento to our respected
Shri
speaker.
Krishna Joshi.
Yeah. Actually, I also have a Yugita in my room also. Yeah, I'm also. I belong to Arya Samaj family, sir. So bye. So I'm sorry, मैंने आपको थोड़ा लेट किया. Let have another round of tea. Okay. Okay.
कर्व लें और फ्लैटन लें या वो लें?
Yeah.
सैडल वाला कौन सा लें? ये लेते हैं कर्व, तो फिर ये स्ट्रेट. ठीक. So congratulations.
Okay, sir. Yes, sir. May I try to come to the down?
I request to Manish, sir, please come on the stage.
Okay, sir, at least this is due to because we have a very legacy of mentors, sir. I'm lucky that I have very, you can say, everywhere in the India group. Yeah,
He's living in Chennai, which is my home family. I was born, brought up in Madras.
Yes.
He's taking care of me.
Actually,
Sir, I want your permission to conclude this session. Professor Gupta? Okay, sir.
Sorry.
Okay, sir, thank you. I would like to express our sincere gratitude to our esteemed keynote speakers for delivering such an insightful and inspiring talk. Your valuable perspective have greatly enriched this session. I also extend our heartfelt thanks to our respected chairperson, Rajendra Kumar Gupta, from the Department of Biochemistry at the University of Allahabad, Prayagraj, for gracefully chairing this session and guiding the discussion with this valuable observation. We truly appreciate your team wisdom and contribution in making this session meaningful and successful. Thank you once again to all the speakers, participants and organizers for being the part of this enriching academic exchange. I would like to give thanks to dear students and our IT team for the wonderful support. Now I hand over the mic to the Radhikishan Shukla sir.
Thank you, ma'am. With this, we bring today technical session to day 1 offline platform to a close. I request Dr. Dinesh Kumar Mishra, coordinator, Faculty of Basic Science, for vote of thanks. Sir, please.
Good evening all. Respected chairperson, distinguished speaker, honored guests, faculty member and dear participants. It is my great privilege in the proposed vote of thanks and end of the incoming technical session of the CONIAPS 2026, organized under the Faculty of Basic Science. First of all, I would like to express sincere gratitude in the respected chairperson, Professor Digvinder Kumar Gupta sir, for guiding the session with great insight and wisdom. I extend the Professor Ranjit Kumar Upadhyay, ISM Dhanbad sir, very grateful thanks for the molecular modeling and mathematical sciences. I extended the hereward thanks to our distinguished speakers of their excellent and thoughts providing lectures. We are the deeply grateful to Professor Mukul Mani Tripathi sir from the Banaras Hindu University for his valuable keynote lectures and for his sharing his expertise with us. Our sincere thanks for the appreciation also goes to Professor S.K. Narasimha sir from Karampi University from the insightful talk which increased with outstanding of the advanced mathematical concept. I would like to the expertise our gratitude to Professor V. Lokesha sir from Vijayanagar Sri Karishmandra University for his exciting presentation on network geometry and cosmology. Our special thanks are due to Professor Ajay from the Indian Institute of Technology, Roorkee for the valuable lectures and the contribution for the scientific discussion. In also expertise the sincere thanks to contribution anchors Dr. Ekta Srivastava and Radha Krishna Shukla for and coordinator of the auditorium of Central Hall, Dr. Manish Agrawal with team, IT support and volunteer also thankful for the and also faculty of basic science. Finally, I would like to thank all participants, researchers, students and the organizing for the active participation and support which made the session triply. Thank you. Again, thank you.
Thank you, sir, for expressing your gratitude. Now, for move forward, I announce the academic proceeding for this session conclude here. We now invite, please pay attention here. I request all the dignitaries present here pay attention. There is one announcement for you. We now invite you all to join us for the cultural program scheduled from 6:30 p.m. up to 7:30 p.m. in the same place. After the cultural program, dinner will be served at the Annapurna Rasoi, AKS University. We warmly invite all the respected guests and participants to join us for the dinner. Thank you once again for your presence and participations. Have a pleasant evening ahead. Namaste.